Hello, my dear warriors. Welcome aboard, welcome aboard, welcome aboard. I hope I am visible and audible right now. Yes, there were some technical issues at the start, but I hope right now I'm audible as well as visible. So sorry to keep you guys waiting. And you know what happened? I was talking, and in fact, I went to the first problem also. Then I realized that something is wrong. The chats were going, but something was wrong. And then, I realized that I was not yet live. So here I am. I think I'm live right now and I'm audible, visible, everything. All clear. Very good. Anugna, thank you so much for trending the WPWP hashtag and also letting everybody know to smash the like button on the session. This is your Captain Shreyas. And a very important notice before we begin the JEE Marathon, please join the Telegram group because you're going to get tomorrow's mock test link, which will be activated for your tomorrow's test, which is a free mock test for the JEE preparation. The link will be active. So please join the Telegram channel. You will also get the DPP links as well as the sessions, updates, timetable, PDF after the class, everything on the Telegram. The link is there in the description box below. Okay, so keep this in mind. And in case you have missed the modern physics class or the inorganic class or the limits differential continuity class, please watch the replays. Sessions are there right now on this channel. Today is the PYQ marathon session where only PYQs, just imagine, just PYQs. In modern physics, right from atoms, nuclei, photoelectric effect, photons, wave particle duality, semiconductors and logic gates. All the PYQs which are very important and crucial. From that you will also understand that see, whatever Sir taught was very important. There are only certain topics through which or on which you will see questions are being asked. Then coordination and DNF block by Navamita ma'am after me, and then limits, continuity, differentiability PYQs by Namrata ma'am after that. So that's the flow. It's a long session. Please get your drinks, please get your snacks, please get your rough sheet. Don't just sit and keep on watching, okay, without solving anything. Please solve as we teach. Okay, ready my dear warriors? So Vijay bunked the school for this session. Hats off to you, Vijay, and I'm pretty sure this session is going to be worth it. Good morning, Nigamath. Hello Suresh, hello Glossy, hello Arvinda, hello Johan. Nice to see you, all of you, waking up this morning and studying for your JEE, because hardly any time is left. And also wake up your friends and tell them Shreyas sir is live, and the JEE channel is right now conducting this marathon session. Okay, so let's begin with the class. And those of you who do not know me, that's my small little introduction for all of you. Please smash the like button and please subscribe to the channel, or else you are going to miss many classes. Okay, so Anugna, Suresh, Venkata, Mani, Luxury Hitler, Tiger, everybody, Beluga, everybody is ready. Beluga is also having a lot of hidden motives to attend the session. I hope those motives and those ambitions also come true. Okay, let's begin then. Lucky day, today is the holiday for some of you. Good. So here comes the first question on your screen. If the de Broglie wavelength with a proton and an alpha particle are equal, then the ratio of the velocities are, this was asked in 2018. So let's try to solve this question. The de Broglie wavelength of alpha and proton are equal, then the ratio of the velocities. See, we know that the de Broglie wavelength is nothing but h by the momentum, and the momentum is nothing but mass into velocity. So if lambda is equal, h is a constant, think about it, lambda is same, h is same, what will be different is the mass, and that's why the speeds are different. So mass of alpha into velocity of alpha will be mass of the proton into velocity of proton. Everybody gets this? These two numbers when multiplied should be same, because lambda is same, h is same. So m into v, the product should be same. So what is mass of alpha particle? It is 4 times the mass of the proton into v alpha is equal to mass of the proton into velocity of the proton. Mass of proton and mass of proton will get cancelled right over here. And what you will be getting is 4 times v alpha is equal to Vp. So velocity of the proton upon velocity of the alpha particle, bring that down over here, will be 4:1, which is option number A. How many of you wrote option number A? I can see many of you. Very good, Revati, Sanjit, Shivalingam, very good, Luxury Hitler. Very nice, very nice. You guys were really quick. Proud of all of you, my dear students. Proud of all of you. Keep it up. Moving on. Okay, so this was based on momentum is mass into velocity and de Broglie wavelength is Planck constant by momentum. And then it is just ratio and common knowledge of alpha particle and proton. Here is the next question. Get ready for it. What does this say? This says there is a particle which is traveling 4 times faster than an electron. Assuming the ratio of the de Broglie wavelength to that of the electron is 2:1, what do you think is the mass of the particle? A particle is traveling 4 times faster, speeds are different, de Broglie wavelength is different, the mass. Again, I think we should use this formula. Lambda is h by momentum. Momentum is mass into velocity. Great. So, since we want to find the mass of the particle, you can just rearrange. Mass will be h by lambda into v. So, therefore, mass of the particle upon mass of the electron into mass of, upon mass of the electron, right, will be, it is inversely related. Mass, lambda, mass, velocity are inversely related. So, it will be lambda of the particle, velocity of the particle, lambda of the electron, velocity of the electron. So, the mass of the particle upon mass of the electron will be, how much is the de Broglie wavelength of the electron to that of the particle? De Broglie wavelength of the particle to that of the electron is 2:1. Particle to that of the electron. So, this is 2/1. I hope this is clear. Particle to electron is 2:1. So, electron by particle is 1:2. Electron by particle is 1:2. And then particle is 4 times faster. So, this is this 4 times faster than this. Velocity of the particle is 4 times faster than velocity of electron. So, this will be 1/4. Correct? So, it is 4 times faster than this. So, this will become 1/8 times. So, that means mass of the particle is 1/8 of the mass of the electron. So, where is it? 1/8. D option. IIT Delhi is the option. Just check this out, everyone. Very good. Very good, Luxury Hitler. Glossy. Very nice, Azil. Very good, Shobha. Very good, Advait. Very good, Teja. Excellent. Awesome. Next, going on to the next problem. We are solving the problem very slowly so that everybody understands. Obviously, if I was writing the exam and I would be doing the problem, I would be doing all of this in the rough work very, very fast. But I want you to understand all the steps. That's why we will take it slow and steady. Okay? Moving on to the next question. Kinetic energy of the particle is E. The de Broglie wavelength is lambda. Increasing the kinetic energy by some amount, the new wavelength becomes half. How much is the change of energy? Very good if you guys are getting the answer even before I am doing it. That will be very good, but don't get scared. Don't feel demotivated if you are not able to solve on your own. If you are able to solve everything on your own, then I would not be standing here. There is a reason why I am here, because you have come here to learn the solution, to see how things are done, to apply the concepts in problems. Okay. Is kinetic energy somehow related to the wavelength? Yes, I believe. How? Lambda is h by p and momentum, do not forget, is root of 2 times m times the kinetic energy E. Here that E stands for that kinetic energy. Kinetic energy, right? So, can you see lambda is inversely proportional to, lambda is inversely proportional to root of the energy, is inversely proportional to the root of the energy. So, if lambda becomes half times, lambda becomes half times, that means root E has become how many times? Root E, lambda became half, that means the denominator has doubled, that's why it became half, right? So it has become 2 times, that means it has become 2 times. Everybody with me? Everybody with me on this? If that has become 2 times, how many times does E become? How many times does E become? If that root of the number has become 2 times, if the root of the number has doubled, that means the number has been quadrupled, has become 4 times. So won't it become 4 times, my dear warriors? Won't it become 4 times, my dear warriors? Very good. So earlier the energy was E. Where is it? E. Now the energy is 4E. So from E, it has become 4E. So how much is the change in the energy? Obviously 4E minus E, which is 3 times of E. Where is 3E? Is it not option A? Many of you made a mistake and wrote 4E. I can see many of you got -1. Please put -1 for all of you. Tomorrow there will be some puller, or there will be some video for all of you regarding the top 10 topics which you can study for JEE exam, specifically with regards to physics. I'll be putting up a video or something, and day after tomorrow again you have marathons and you have flash and PYQs, everything. Cool. Yes. Can you use E is equal to hc by lambda? Obviously not. Why not? Because this is a particle. hc by lambda is used for photon, not for proton, electron, neutron or other such matter-like particles. Only for light, that is photons, you can use hc by lambda. So that's why I have used this. Okay? You cannot write that energy as hc by lambda. That will be wrong. That's why you need to be really careful. This is the next question, a beautiful question coming up on your screen. I hope you are learning a lot, and it's very important that you get -1 marks. If you get -1 marks today, that is very good. That means you are learning. That means you are adding 4 marks in your first attempt. The number of -1s that you get today, that many +4s you will get in the JEE Mains first attempt. Remember that. An electron of mass m, magnitude of charge E, initially is at rest, is accelerated by some field. The rate of change of the de Broglie wavelength at some time, ignoring relativity effects. Okay, fine. Let's have a look. Vijay, don't spam bacha. Whatever schedule will be there will be put up. Like we said, right? Monday to Saturday all classes, and Sunday you will have some special classes also sometimes. So here we go. Concentrate on this rate of change of de Broglie wavelength. Okay. De Broglie wavelength is again h by mv. But velocity is not constant. It will change with time because it is accelerating. And if that particle of mass m accelerates with some acceleration, after some time it will have a velocity. How much is that acceleration? It will be force divided by mass. How much is the force? It's the electric field into the charge. How much is the charge? E upon the mass, right? So that is the acceleration. So now what will be the velocity, my dear students? It is u plus at. It starts from rest. It is clearly mentioned. It starts from rest. So it will be 0 plus E by m into t. So therefore, can I say velocity is E by m? That is the velocity formula. I will substitute it over here. So what are the velocity terms? It has E, it has this E, and also this t, and that m goes on the top, and that m goes on the top. So that is h by m over here. H by m as it is. V is EET divided by m. You can see this m and this m just cancels out. So it is h by EET. But that is not the answer. That is not the answer. Read the question carefully. What is asked? The rate of change of de Broglie wavelength is asked. Rate of change of de Broglie wavelength is asked. Many students, when they see this as the answer, h by EET, they look, is it there somewhere? Okay, it is not there. But sir, t is there on the top. This minus sign is there. Maybe I made a mistake. So in a hurry, many students mark option A. No. Read it again. What it says is rate of change. That means you have to find d lambda by dt. d lambda by dt. So this is h by E, and this is derivative 1 by t means basically t raised to minus 1's derivative. T raised to minus 1's derivative. So what is t raised to minus 1's derivative, my dear warriors? It is nothing but minus 1 into t raised to minus 2. So it will be minus h by E, and you have t square. Minus h, t square is there as C for Captain Shreyas. How many of you got it as C? Satya Vagnisan has got it. JEE Chaser has got it. QB has got it. Very good. Varshita Reddy has also got it. Luxury Hitler understood it. Very good. Awesome. Srija, very nice. Proud of all of you. Let's go ahead. Let's go ahead to the next question. Are you loving these questions? Aren't they amazing questions? That's why PYQs are very important. And PYQ sessions are very different from your regular flash sessions, and flash sessions help you build those concepts as well. So I hope you have subscribed to the channel and also smash the like button. Show your love and support, without which we won't be able to conduct classes. You have to make the channel popular. You have to talk about the channel. You have to be regular, and it is not for us, for your own benefit. Next question, brilliant question. A particle is formed due to completely inelastic collision of x and y having some de Broglie wavelength. If x and y were moving in opposite direction, then the de Broglie wavelength of that particle P is how much? Let's have a look. So see, my dear students, what is happening? X particle and y particle both were going in the opposite direction. This was before. Afterwards, what happened is they became one single particle, and maybe they are moving right now like this, a one single particle, and then they started moving, let's say this way or that way, doesn't matter. The point is that the new de Broglie wavelength is how much? Okay, I think we need to use little bit knowledge of mechanics over here, and we need to use the principle of conservation of momentum. Conservation of momentum. What is the momentum of x? I will call it px. What is the momentum of y? I will call it py. Should I put a plus over here or should I put a minus? Answer in the chat box. Answer in the chat box. Should I put a plus or should I put a minus? Both are going in opposite. Momentum is a vector, so minus. If one is positive, other is negative. Finally, momentum of that particle. Is momentum related to de Broglie wavelength? Of course, yes. It is h by lambda. Momentum is h by lambda. So h by lambda x minus h by lambda y is equal to h by lambda of the particle. H cancels. Now take the LCM. It will be lambda y minus lambda x upon lambda y lambda x is equal to 1 by lambda p. So therefore lambda p will be, take it on the top, it will be lambda x lambda y upon lambda y minus lambda x. But who said this momentum is more than this momentum? I can't know that. So it is not given. So it is better that we put a mod everywhere. It is better that we put a mod everywhere when we do not know who is more, who is less. So hence the answer to this particular question is option B for IIT Bombay. B for IIT Bombay. Everybody with me? How many of you wrote B? All the IIT Bombay students? Who are the IIT Bombay students? Wow, so many IIT Bombay students are there. This question looks very confusing initially, but actually when you write conservation of momentum and relate it with wavelength, it looks very straightforward. Okay. The mod thing is very important. This is very good question. This is 2018, very good question. If this question comes, many people will get stuck, so pay attention. Two electrons are moving with non-relativity speeds, that means ignore the relativity effects, okay? Perpendicular to each other. The de Broglie wavelengths are lambda 1, lambda 2. If the de Broglie wavelengths are different, that means their speeds are also different. the de Broglie wavelength in the frame of reference attached to their center of mass is. Now, you should realize that if you sit on the center of mass, their motion will be completely different. So, combined with center of mass, this question is asked, number one. But in the question, they did not mention who are you looking at. Are you looking at particle 1 or are you looking at particle 2? They did not mention. So, many people thought maybe this is a bonus question because they did not mention whether it is particle 1 or particle 2 that you are looking at from the center of mass frame. But actually, when you solve it, you will realize that both their speeds, or not speeds, sorry, both their momentums are going to be same from the center of mass frame. Both their momentums are going to be same from the frame of reference of the center of mass. Yes, that is one property of the center of mass. If you sit on the center of mass of two particles, if one particle has 5 units of momentum, the other particle will have 5 units of momentum in the exact opposite direction. The magnitude, the modulus is the same. How many of you know this property? How many of you know this property? Come on, come on. Think about it. Dushan, don't worry, bacha. Many people are jealous about our channel because we are doing well. Many people, they can't afford or they do not have the sufficient, technical knowledge for conducting these kind of things. And especially, there are very few channels which help South Indian students. And there is only one channel which has the best teachers, and that is Vedantu JEE English, Vedantu NEET English. The best set of teachers. There is no other English channel apart from that. Trust me on that. Many teachers don't know many things. All right. They promise something, they don't deliver something. So don't fall into all those rumors and all that. Just follow these classes. That's all. So come on, my dear students. Did you understand what I just said? In the center of mass frame, I'll just repeat over here. Maybe I'll add it in the next slide. In the center of mass frame, the particles momentum magnitude wise are going to be the same. Therefore, their de Broglie wavelengths will be the same. That is the first important thing that you should realize. Okay. Now, let's actually solve the problem. The particles are moving perpendicular. Let's find out the velocity of the center of mass and all of that. So, I'll do it on the next slide. So, one particle is going here, one particle is going here. This is, let's say, mass 1. Actually, the masses are also equal if I'm not wrong. 2 electrons. Yes, 2 electrons means the masses are equal, but their speeds could be different, V1, V2. Their center of mass could be traveling like this with a velocity Vc. And that Vc will be m v1 j cap plus m v2 I cap, whole thing divided by m plus m. Cancels. You will get v2 I cap plus v1 j cap, whole thing divided by 2. That is what I get my Vc bar as. Which I can also write it as V2 bar plus V1 bar by 2. V2 bar is this velocity, V1 bar is that velocity. So that is your velocity of the center of mass. Now, what is the velocity of particle 1 with respect to center of mass? It is V1 minus Vc. So V1 bar minus this term, which is V2 plus V1 by 2. Check what will happen. V1 minus V1 by 2 is V1 by 2. So it will be V1 by 2 minus V2 by 2 minus V2 by 2. There you go. Minus V2 by 2. Everybody with me till this point? Everybody will with me till this point? Perfect. Now, what will be the magnitude of this? What will be the magnitude of this? What will be the magnitude of this? Think about it carefully. One is V1 by 2, one is V2 by 2, one is V1 by 2. And one is basically minus V2 by 2. So both these vectors are perpendicular to each other. Their magnitude will be their magnitude will be, by Pythagoras, take the roots, it will be root of V1 by 2 whole square plus V2 by 2 whole square, which is 1 by 2 root of V1 square plus V2 square. Correct? And whatever this magnitude is, will also be the magnitude of the second particle with respect to the center of mass. Both of them will come out to be the same. You replace V1 with V2, V2 with V1, doesn't change anything. Magnitudes will be the same. How many of you realize this till now? Everybody okay? Both the particles have this velocity with center of mass, with respect to center of mass. I hope this is very, very clear. Very, very clear. So now the de Broglie wavelength with respect to center of mass will be h by mass of the particle into velocity of any particle, either this or this. Both of them have the same velocity. Both have basically the same speed. Remember that. So you can put V1c or V2c. So let's start substituting this. H by m into what is V1c or V2c? This term, V1 square plus V2 square by 2. So it will be V1 square plus V2 square by 2. So that 2 will go on the top. But wait a minute. I think I know what is the value of V1 or what is the value of V2. What is the value of V1 or what is the value of V2? Because lambda 1 was h by mv1. De Broglie wavelength is momentum in the denominator, Planck's constant on the top. So V1 will be h by m lambda 1 and V2 will be h by m lambda 2. Take these two values and put it over here. So it will be h square by m square lambda 1 square plus h square by m square lambda 2 square. Now h comes outside, cancels with this. H comes outside, cancels with this. M comes outside, cancels with this mass. So what is left actually? 2 divided by root of 1 by lambda 1 square plus 1 by lambda 2 square. 1 by lambda 2 square. Take the LCM now. That's all that is remaining. So it will be root of lambda 1 square plus lambda 2 square upon lambda 1 square into lambda 2 square. The root of the square terms will become lambda 1 lambda 2. Take it on the top, it will become 2 lambda 1 lambda 2. 2 lambda 1 lambda 2 goes on the top, and what remains over here is lambda 1 square plus lambda 2 square. So I think there is an option like that somewhere. Yes, there is an option. You can see that. Option B. Option B. So it's a beautiful question involving multiple concepts. Will you solve this question in the examination? Will you solve this question in the examination? No. In the first go, no. Avoid this because it is lengthy. It will take a lot of your time. It's like higher order JEE Mains question. If you are aiming for 99 percentile, even if you leave this question, that is okay. But if you are aiming for 100 percentile, 99.95 percentile, 99.91 percentile, then this question will be done. Okay? Then you have to do it, but don't do it the start. Still, you will do it at the end because you know this question is time consuming. Okay? Moving on. A particle is going 5 times as fast as an electron. Ratio of the de Broglie wavelength of the particle to that of the electron is this much. The mass of the particle is close to. The mass of the particle is close to. Come on. Let's do this. Let's do this question. Particle moves 5 times faster. The ratio of the de Broglie wavelength of the particle to that of the electron. All right. Lambda is again h by mv. Okay. So lambda of the particle upon lambda of the electron is mass of the particle, velocity of the particle below, because they are inversely proportional, and same thing for the electron, mass of the electron and speed of the electron. Now, what is the next step? The wavelength of that particle will be, first of all, we'll take this on the top, wavelength of the electron over there, mass of the electron and mass of the particle. Do I know? Oh, sorry. I don't have to find that. I have to find the, what is it? The mass of the particle. My bad. So the mass of the particle, take it on the top and take all these people here. So what will be remaining? Mass of the electron, velocity of electron by velocity of particle, lambda of electron by lambda of the particle. Okay, mass of the electron 9 into 10 to the power minus 31. Velocity of the electron and velocity of the particle. Particle is 5 times fast, so 1 by 5 over here, into wavelength of the particle to that of the electron, the ratio, wavelength of the particle to that of the electron, the ratio is given to be 1.87 into 10 to the power minus 4. 1.87 into 10 to the power minus 4. Come on, do the math and tell me the answer. Do the math and tell me the answer. So 9 is there, 5 is there, 1.87 is there. Here you will see 10 to the power minus 27. 5 into 1.87. Come on, my dear students. Almost it is like 2. Almost it is like 2. So it will be close to 9 only. And you will have the power in 10 to the power minus 28. Is it this one or is it this one? Option C or option D? Check it out. It is option C, I believe. Just check it out. Slightly, yeah, less than 1. Option C. Very good, very good, very good. Excellent. Excellent. Very nice, very nice. Very good. Awesome. Check it out, calculate it, see if it is 10 to the power minus 28, 9.7. Okay. So this will actually basically come out to be, this will come out to be 9.7 into 10 to the power minus 28. Okay, cool. Let's go to the next question coming up on your screen, again on de Broglie wavelength, but this time with electrostatics. They have coupled it by accelerating it. The de Broglie of an electron and a proton, by accelerating them through the same voltage, the ratio of the wavelengths is, see, the wavelength is h by momentum. Momentum is root of 2m and into the kinetic energy. That kinetic energy, you can write it as the charge into the voltage by which you accelerate it. The voltage by which you accelerate it. Kinetic energy is the value of the potential energy. Potential energy is charge into voltage difference. If you realize here, this potential is the same. So that means this delta V term is the same. Delta V term is the same. H is same. 2 is a constant. So indirectly, lambda is inversely proportional to root m as well as root q. Root m as well as root q. So when you want to find the ratio of the wavelengths, lambda of the electron upon lambda of the proton, what will you basically get? Mass of electron here, mass of proton here, and then here you will have charge of the electron here and charge of the proton here. But we know the charge on the electron as well as the proton is the same. Charge on the proton or the electron is the same. Hence it is basically 1, because same magnitude of the charge is there. So forget this part. So only thing which remains is this one. Only thing which remains is this one. And how many times roughly is the mass of the proton with respect to the electron? How many times is the mass of the proton with respect to the electron? Even if these numbers are not given, you know it is approximately like 1837, 1836, around that figure. 1837, 1836. Do you remember this? How many of you remember this? Very good. Now what is the root of 1837? Root of 1837, is it 43 or is it 41? I think it will be close to 43. Yes, it is 43. So this is close to 43. So this is 43. Hence that is the correct ratio. Yep, very good. Easy peasy, lemon squeezy, easy peasy, biryani tasty. That's all. You just had to realize charges are same, only masses are different, and then take the ratio. Okay? If you want, you can divide this, but you avoid this division because you know the standard result. proton is 1837 times heavier than the electron. Next question coming up on your screen. I hope you realize we are trying to solve as many questions relating to as many chapters, and I'm telling you, photons and that wave particle duality, maximum questions come apart from atomic structure in modern physics. Like you can see, almost every year so many questions. De Broglie wavelength of an electron is this much times the wavelength of a photon of frequency this much, the speed of the electron. Photon with wave particle duality. Very tricky question. Read it carefully. Electron's de Broglie is these many times the wavelength of a photon of certain frequency. So if you talk about the electron, the de Broglie wavelength of the electron is given by h by mass of the electron into velocity of the electron. I think we have to find the speed of the electron. Okay. But if you talk about the photon, the wavelength of the photon, what is the formula for wavelength of a photon? Use speed formula for wave. Speed is frequency into wavelength. So wavelength is speed by frequency. Speed by your frequency. And these both have been given to be equal. How many of you understood this equation? This part is directly related to electron. Photon is related to wave. So remember, this is a wave of the photon that we are talking about, and this is your de Broglie wavelength of the matter wave that we are talking about. Now, question is to just find how much, what is it? The speed. So V is asked. So VE will be HF divided by ME into C. Substitute everything. H is given, M is given, C is given, F is given. What else you want in life? So this will be 6.63 10 to the power minus 34. Frequency 6 into 10 to the power 14. Mass is given to be 9.1 into 10 to the power minus 31. And speed of light is given to be 3 into 10 to the power 8. Come on, my dear warriors. Quickly do the math and tell me the answer. Quickly do the math and tell me the answer. What is it? What is it, my dear students? Come on. Do the math quickly. Just try to multiply 6.63, 6 and 3 and this. So try it out. This will become 2, correct? 6.6 into 2, close to 13, right? 13, 14 and this is 9. So it will be almost like 1.5 times, close to 1.5 times. So I think it should be D. Yes, it is D. It is D. I just did it mentally. I didn't worry about powers of 10. I just thought 6.6 into 2, it will be close to 13 point something and divided by 9. So it will be slightly close to 1.5, slightly less than that actually. And there you go. It is 1.45. So you can avoid the actual calculations. How many of you do these things in the actual exam? This is like more like approximation, gut feeling. You get a feeling that it will be more than 2, less than 2, more than 3, less than 3, whatever. So these kind of things help a lot, especially in the objective exam, not for integer type, right? How many of you do that? Very good if you have been doing that. Moving on to the next question coming up on your screen, and here it is. Particle of certain mass is moving along the axis, collides elastically with another particle of at rest of m/3 mass. Both the particles move in the x direction. The change in the wavelength, in the de Broglie wavelength of the particle in terms of the initial wavelength is. Read it, take a screenshot. Read it, take a screenshot. Yeah, Gautam Raj, it will not work in all the problems. Obviously, in some problems it will work. Okay, so let's try to do this. So one particle is there, particle A of mass m/2. This is particle A of mass m/2. It is moving with certain velocity. How much velocity? With velocity v0. Okay. Another particle B is there. Another particle B is there of mass m/3. Of mass m/3. which is right now at rest. This is before. After the collision, they are colliding elastically. Yes. So after the collision, maybe this particle of mass m/2 has a velocity v1 and this particle of mass m/3 has a velocity v2. Question is, what is the excuse me, de Broglie wavelength of particle A, in terms of the wavelength before. Okay. So basically we need to focus on this particle A. Okay. We need to find V1. If I find speed, I can find the wavelength. If I find speed, I can find the wavelength. Correct? Okay. Great. Let's do this. Which equations will you use? Obviously, conservation of momentum. Let's conserve the momentum. And see what happens. m/2 into v0 plus 0 is equal to, this will be m/2 into basically v1 plus m/3 into v2. M cancels. You will get v0/2 is v1/2 plus v2/3. This is equation number 1. Also, because it is elastic collision, it is clearly given to be elastic collision. That means speed of approach will be speed of separation. Speed at which it approaches. What speed is it approaching at? v0 will be equal to the speed relative for separation. So once it collides, what is the speed of separation? One is v2, one is v1. One is v2, one is v1. Yep. So won't this be v2 minus v1? That is your second equation. This is for approach. This is for separation. I don't want v2. So therefore v2 will be v0 plus v1. I think I will take this value of v2 and I will substitute it over here. I'll substitute it over here and see what do I get. The moment I substitute it, let's see, v0/2 is equal to v1/2 plus, instead of v2, I will have v0 plus v1. So it will be v0 plus v1, the whole thing divided by 3. Rearrange this equation. Take v0 on one side, keep v1 on the other side. So v0 1/2 minus 1/3 will be v1 1/2 plus 1/3. So what will this be? v0, 3 minus 2 is 1/6 is equal to 3 plus 2 is 5. So v1 into 5/6. 6 cancels. So v1 will be v0/5. v1 will be v0/5. We've got this. How many of you got this till now? We use momentum conservation and elastic collision. So approach and separation is going to be same. 2 unknowns, 2 equations. I just found out v1 value. v1 is 5 times lesser than the initial velocity. So now coming back to the problem regarding de Broglie wavelength. De Broglie wavelength is h by mv. De Broglie wavelength is inversely proportional to the velocity. So if velocity becomes 5 times less, the wavelength will become 5 times more, right? Velocity becomes 5 times less. It's in the denominator. So it will go on the top. It will become 5 times more. So basically lambda naught has become 5 lambda naught. So how much is the change, my dear students? Is it not 4 lambda naught? Just check this out. Option C should be correct. Yes, option C is correct. Very good. What a brilliant question, my dear students. These questions are telling you that if you just study modern physics, you might not be able to crack, that question. They are going to involve either magnetism concepts or electrostatics concepts or momentum concepts or center of mass concepts or kinematics and Newton's laws concept. So these chapters can be interlinked and asked in the JEE Mains. These are combination questions. Okay? Combination questions. These are some of the best things. You will, even if you read the solution in many books, you will not understand. That's why I'm going step by step, explaining you everything. Look at this question. A particle of certain mass and charge is accelerated by 50 volts. Another particle is accelerated by 2500 volts. The ratio of the de Broglie wavelength is. The ratio of the de Broglie wavelength is. Okay, let's do this again. Lambda is again h by p. P is nothing but root of 2m kinetic energy. Kinetic energy is not known, but voltages and charges are known. So instead of kinetic energy, I can write it as charge into voltage difference. Now the mass is m, charge is q. Another particle, mass is 4m, charge is q. So clearly over here, the charge is q at both the places. 2 is anyways a constant, h is anyways a constant. Only mass and voltages are different. So therefore, if I divide, or I can see the proportionality, root m, root delta v, inversely proportional. So I can say lambda of A by lambda of B will be, this will be MA over here, MB over here, and this will be VA over here and VB over here. Inversely proportional to the root of the mass and the voltages. What is the mass ratio? I think it is given. Mass of A is m, mass of B is 4m. Mass of A is m, mass of B is 4m. What is the voltages? First voltage is 50, next voltage is 2500. First is 50, next is 2500. So root of 4 is basically 2. What is this over here? This will go 50 times. So this will be root of 50. This will be nothing but root of 50. Everybody with me? What will you do next? What will you do next? Is it somehow manageable to do something over here? Is it somehow manageable to do something over here? Think about it. Think about it. Yes, 50 is 25 times 2. 25 times 2 and 25 is a perfect square. So 2 into 5 root 2. So this will be 10 root 2. Root 2 is basically 1.414 etc. So this will be 14.1 something. So 14.1 something is option C. C for Captain Shreyas. Perfectly. Perfectly. Very good. Awesomeness. Option D is the correct answer. Yep. Very good. Congratulations. And I also want to know how many mistakes have you made till now? Or when you're watching the solution, how many of you realized certain things that you would have done, certain mistakes which you would have done in the exam had you not seen this video? What is the number till now? Is it 2? Is it 3? Is it 4? Is it 5? Yeah, you can take root 50 as approx 7 also, no problem. So 7 2s are 14. So 14 point something. Yes, you can do that. Here comes the next question. Here comes the next question. Let's see. Okay. Very good. Photoelectric experiment. Wavelength of the light is changed from this to this. The decrease in the stopping potential is. The decrease in the stopping potential is how much? That's the question, my dear students. That's the question, my dear students. Come on, let's see how many of you can do this. Come on, let's see how many of you can do this. The photoelectric experiment. In a photoelectric experiment, come on. The wavelength is changed from 300 to 400. Then the stopping potential decrease is how much? First of all, let's recollect the equation. What is the equation? It is nothing but hc by lambda is your work function plus E times of Vs. So therefore, my Vs will be hc by E into 1 by lambda minus phi by E. Just check this out. I just divide this equation by E. So E comes below and take the phi on the other side. So minus phi by E. As simple as that. Now, first time I can say the stopping potential in the first case will be hc by E. The lambda value will be nothing but 300. This is minus phi by E. Next time it will be hc by E. This will be 1 by 400. This is minus phi by E. I hope this is fine till this point. Very good. And next step next step will be the difference V1 minus V2, whichever is bigger, V1 minus V2. Actually, V1 will be smaller than V2. So actually I should do V2 minus V1, V2 minus V1, this minus this, which is the difference in the potential. Can you see phi by E will get cancelled? Phi by E will get cancelled. So HC by E, here you will have 1 by, 300 and minus HC by E, and you will have here 1 by 400. Correct? Everybody with me? Everybody with me on this? Correct. So now what is the next step? Take HC by E common. HC by E is given to be 1240, and here you have 1 by 300 minus 1 by 400. Very good. So now taking the LCM and all those things, so 1240, 400 minus 300 is 100, and here you have 300 multiplied by 400. 0, 0 cancels, 0, 0 cancels, 0, 0 cancels, sorry, 1 0 cancels, this 0 cancels. 30 into 4, 120, so 124 by 120, approximately 1 volt. Approximately 1 volt only we will get. Just check this out. Yes, it is 1 volt. Yes, it is 1 volt. So what we found out over here was the voltage difference. What we found out over here was the voltage difference. Correct. Srikanth, V1 minus V2. Just check this out. Oh yeah, sorry. By putting it over here, I think I put V2 minus V1. Yes, it should be V1 minus V2. Anyways, we are trying to find the positive difference. I'm putting a mod, so I'll always find the positive value, which is 1 volt. Okay, perfect. Let's go ahead to the next question. The de Broglie wavelength of the electron in the nth Bohr orbit in the hydrogen atom is this much times A0, where A0 is the Bohr's radius, then the value of n by z. So again, atomic structure combined with wave particle duality. Atomic structure is combined with wave particle duality. Let's see if you can do this, my dear warriors. Okay, let's see. We know that in case of Bohr's model of atom, you take any orbit, you can fit in that circumference, exactly principal quantum number times of the de Broglie wavelength. So always remember this rule. I have given this during our flash series also. The circumference is n times of what? The de Broglie wavelength. N times of the de Broglie wavelength. Keep this rule in mind. Very, very important. So just use this, you will get the answer. What is the circumference? It is basically 2 pi r. Now r I do not know. What is n? I don't know. What is de Broglie wavelength? I'll just put it over here. Now it is clearly mentioned that de Broglie wavelength is equal to 1.5 pi times A0. Okay, this is 1.5 pi times of A0. But wait a minute, I know the radius formula. Nth radius is n square times the Bohr's radius. This is standard formula again. The radius of the nth orbit is n square times the R0 value. I hope you remember this Z is also there. So if Z is the same, that it will be proportional to only n square. So over here, can I just not put n square A0 by Z, n square A0 by Z? Check this out, n and this n just got cancelled. This n and this n just got cancelled. So what is now remaining if I want n by Z? If I just want n by Z, check this out. Even this pi and this pi got cancelled. So I have 1.5. In fact, even A0 and A0 also got cancelled. 1.5 divided by 2, which is nothing but 3 by 2 into 1 by 2, which is 3 by 4, which is 0.75, which is D option. No, it is not B, it is a D. Is there a lag or something? I hope it is fine. Mohammad Adil, I think you should be fine now. Just refresh in case there was a problem. Just refresh in case there was a problem. Yes, yes, yes. Yes, Eskinath, it is option D. Very good. Beautiful question. You had to use proportionalities of radius. You had to use this concept, which I have again revised in my previous class just day before. Please watch that in case you have missed it. Just substitute that over here. You will get the answer. Moving on to the next question. Consider an electron, okay, which is revolving in the second excited state. The de Broglie wavelength of the electron in this state is, let me tell you, give you a hint. Use this concept directly in this problem, you will get it. Use this concept. The circumference is n times of the de Broglie wavelength. N times of the de Broglie wavelength. That's all. So what is the circumference going to be? 2 pi into r. What is r? R is basically 4.65 angstroms. What is n? I think that has to be seen from here. Second excited state means n is not 2, n is 3. Ground state, n is 1. First excited state, n is 2. Second excited state, n is 3. Common mistake done by many students. So n is 3. Lambda of the de Broglie. Okay. So now you just have to find lambda. So lambda will be 2 into pi, which is 3.14 into 4.65. The whole thing divided by 3. Correct? Now 3.14 and 3, almost 1. So 1 point something. So 2 4s are 8. But it is 4.65, so very close to 5. So 2 5s would be 10. So it will be somewhere in that range. Just check this out. 9.7. Yes, it's slightly going to be less than 10, but more than 8. So it will be between 8 and 10 the answer. Between 8 and 10, only one option is there. Because 2 4s are 8, 2 5s are 10. So this value was almost like 1. Yep. So that's how you can do the math. Very good, very good. Let's go to the next question coming up on your screen, and here it is. Let's go to the next question. Yes, coming up on the screen. The de Broglie wavelength associated with the electron orbiting in the second excited state is related to the one in the ground state by. Again, a direct application of this concept. Circumference is n times the de Broglie wavelength. That's all. Circumference is n times the de Broglie wavelength. Let's try this out. So if you are in the ground state, n is 1, lambda is lambda g. Circumference will be 2 pi, let's say r0. 2 pi r0. If you are in the second excited state, the value of n will be 3. Value of lambda will be 3 in that particular, excited state. And the value of the radius, come on my dear students, radius in the nth orbit is n square into r0 by z, right? So if n is made 3 times, n square will be made basically 9 times. So won't the radius be 9 times of r0? Won't the radius be 9 times of r0? Everybody with me? 9 times of r0. Very good. Very good. Now just have to divide both of them. 2 pi, bye bye. 2 pi, bye bye. r0, bye bye. So 1 by 9 will be there here. Here, I think I'll have lambda g, and here I'll have lambda b. But the question is, the de Broglie wavelength lambda b is asked. So this 3 and this 9 cancels, this will become 3. So lambda b will be 3 times of lambda g. 3 times of lambda g, which is B for IIT Bombay. Easy squeezy, lemon squeezy. Oops, some of you thought answer was D, RK videos, Deva, Shresht, Abdul, Nani, है ना? So many of you made a mistake there between the two. Be very careful. They both look very similar. If you make one silly mistake, you will get the other answer. The answer was B. So -1 over there. Put yourself in that -1 and remember these mistakes. Be very careful in these kind of things. These things happen. I mean, you don't have to feel very bad about yourself, but you know, that's why they are called silly mistakes. You forgot to take that 3 below or up, gone. That's it. You will get -1. So be very clear in your rough work. If your rough work is neat, not very neat like boards, but decently legible, then you will not make any silly mistakes. Cool. Let's move on to the next question. The maximum velocity of the photoelectrons emitted from the surface is V. Okay. And the light of the frequency n falls on a metallic surface. If the incident frequency is increased to 3n, then the maximum speed of the ejected electrons will be more or less than these values. This is one of the best questions. This is one of the really good questions. Let's do it. Maximum speed, frequency n. So, light frequency is n. So, Hn is the energy of the photon, is equal to work function plus the kinetic energy, which is half mv square. Cool. That is the first equation when light of frequency n falls on the metal surface. Phi is assumed. Next time the frequency is made 3n. So h into 3n is phi plus half m new speed. I will call that v1 square. Now what I will do, I will substitute hn over here. So it will be 3 times, instead of hn, I'll put this. So which is phi plus half mv square. Why am I doing that? I want to compare the speeds. And see what happens. I don't want to eliminate phi. I don't know about phi, but I just want to compare the speeds. Okay. So I'm just getting rid of this n. I don't like this n right now. Is equal to phi plus half m v1 square. Okay. Now let's play with this. This is 3 phi. This is phi. Take the phi over here. So it will become 3 phi minus phi plus this will become 3 by 2 mv square is equal to mv1 square by 2. 3 phi minus phi, this thing will become 2 phi. Now do one thing, multiply both sides with 2 by m. So this will become 2 phi into 2 by m plus, if you multiply by 2 by m and 2 gets cancelled, so 3v square. So this will be equal to, multiply by 2 by m, only v1 square. Now I am very close to the answer. 2 2s are 4. So 4 phi by m plus 3v square is equal to v1 square. So my dear students, what is the final step? I can put it on the top maybe. So v1 will be root of 3v square plus 4 phi by m. From this what can you tell? 100% v1 is more than root of 3v square. v1 is more than 3v square because v1 has this plus some term. So that means v1 is more than v root 3. That is the final answer. v1 is more than root 3 times of v. Correct? Got it? Everybody with me? What a brilliant question, purely mathematical after this part where you substitute Hn over here. If you substitute Hn over here, you can directly do the comparison. There is some bit of inequalities also involved, like you can see. Great question. Let's go to the next one coming up on your screen. Which of the following property of the electromagnetic radiation do you think depends on the stopping potential? Come on, our stopping potential depends on which of the following property? Think. Is it the phase? Is it the intensity? Is it the amplitude? Or is it the frequency? Waiting for all your answers. Very good, Anugna Deja, for giving the previous answers. Awesomeness. Thank you, Archie. Okay, D, is it true? What do you say? Pakka? Lock kiya jaye? Come on, come on, come on. Come on, come on, come on. Aishwarya, the previous question, it just asked if you make the frequency of the incident light thrice, more energy, so more speed, so that new speed is more than or less than which of the following quantities. So first time light energy was Hn, next time it was 3 Hn. So I use this Hn, which is this value, I substituted here. And then solved it. This is simple algebra, simple calculation. And I found V1 in terms of V. From this, I understand V1 must be more than 3V square, because 3V square plus something is there in the root. So V1 must be more than this value. So V square's root is V. So that's why this answer. Okay? Yep. Cool. The answer is very good, frequency. Very good, my dear students, because we all know HF is work function plus EVS. Frequency decides the stopping potential. It is independent of the intensity or basically the amplitude or basically even the phase. It does not depend on any of these quantities. It is independent of this. It's only dependent on the frequency, the stopping potential with the incident frequency. Let's see how many of you can do this problem. Gayu, sometimes NEET questions have been repeated in JEE and JEE questions have been repeated in NEET. So if I find some question in NEET and you find it in JEE mains, don't be surprised. Ditto question, sometimes even value change in the recent years. Earlier this never used to happen. Ever since NTA has taken charge, I don't know, there are, very few questions, not like 10, 15, maybe in a paper, maybe 1 or max 2 questions are little bit similar. Okay. Srija, the lecture is going to continue for a very long time, bacha. It will go till probably 4 o'clock or 5 o'clock as well. There will be a break also in between. Don't worry about it. Okay. Come on, my dear warriors. Come on. Think. In a photoelectric experiment, the graph of the stopping potential versus the reciprocal of the wavelength. When I say reciprocal of the wavelength, is it not basically directly proportional to the frequency? And we have seen the graph of stopping potential versus frequency. It is always a straight line with a negative intercept. The negative intercept is minus phi by E, and the slope is h by E. If you remember this. Very good. So that's it. Is it a straight line which shifts as the intensity changes? No. This is not dependent on intensity. Neither is the slope dependent on intensity. No slope change. Nothing will happen. The graph does not even change, my dear students. The graph does not even change. Is that D? Very good. Many of you are going to IIT Delhi also now. IIT Delhi seat, I am calling the IIT Delhi director right now. I am booking your seats. Don't worry. Very good. And how many of you legendary people have not yet liked the session? Don't be a legend. Be an ultra legend by liking and subscribing. Do that right now. This is your only channel which is teaching in English with the best teachers. And if you do not support the channel, because there are so many channels in India and so many other teachers, but this is the only channel in the country which is preparing you for JEE, that too specifically for South Indian students, some of the students in some metro cities, some students who are studying abroad, some students in the Northeast, and so many other places who prefer learning in English. So please do that right now. Moving on, next question. In the hydrogen atom line spectrum, which of the following is in the visible series? Is it Lyman, is it Balmer, is it Paschen, or is it Brackett? Come on, come on, come on. Thank you, Nani, Rupesh. Thank you so much. Aishwarya is the ultra legend. Very good. Thank you, Srija, for liking. Yes. Lyman or Balmer or Paschen or Brackett. This is directly from NCERT. This is directly from theory. So such questions also come. If you are thinking only calculation will come, no. That's why you need to know data points. You need to know certain values. You need to remember certain names. Direct theoretical question, it is the Balmer series. It is the Balmer series. Very good. Very good. Awesome. Awesome. Moving on to the next question, which was asked in 2021. Which level of the single ionized carbon has the same energy as the ground state energy of the hydrogen atom? Which level of the singly ionized carbon atom has the same energy as the ground state energy of the hydrogen atom? Come on. Think about it. What will be the correct answer? Which level of singly ionized carbon has the same energy? So, energy of the carbon must be energy of the hydrogen. Hydrogen, ground state, the energy is 13.6. Z is 1, N is 1 because it is ground state. Energy of carbon, assuming it is following Bohr's model, is 13.6. Z square by N square. Z is 6. N square, I don't know. Come on, 13.6 cancel. 1 square cancels. So 6 square is N square. So N will be 6, my dear warriors. Where is 6? It's a 6. Very good. Very good. Awesome. I hope you did not hit the boundary there. Very good. Amazing, my dear students. Amazing. Let's go to the next question coming up on your screen. If the electron is moving in the nth orbit of the hydrogen atom, the velocity for the nth orbit, this I want all the people to spam the answer. This I want all the people to spam the answer. You cannot go wrong in this. Let's see how many of you are going to enter which IIT. Everyone, come on, my dear students. Standard theoretical question. This came in the paper. Just imagine if this came in the paper, you will be so happy because 100% sure short marks for all of you. Velocity is directly proportional to Z by N. Radius is proportional to N square by Z. So V is inversely proportional to N. V is inversely proportional to N. Bombay, what are you guys doing? Who are these IIT Delhi people? Somebody said D also. No, it is not D. It is B. It's velocity. It is not something else. Energy is proportional to Z square by N square. Z square by N square. Be careful. Alright. So that's the answer for this. Moving on to the next question. What does it say? The energy required to ionize a hydrogen like ion in ground state is 9 Rydbergs, and this unit you need to know. 1 Rydberg is the unit of energy, is the unit of basically energy, and 1 Rydberg is 13.6 electron volt. Okay, 1 Rydberg of energy is 13.6 electron volt. It is not Rydberg constant. Don't get confused with Rydberg constant. Many students do that. Don't do that. It is unit of energy. 9 Rydbergs will be 9 into that much quantity. The wavelength which will be coming out when the electron jumps from second to the ground state. Second means N is equal to 3. Ground means N is equal to 1. Okay, let's see what we can do. First of all, let's find out the energy required to ionize. Ionization energy formula is 13.6. You have Z square by N square. N will be basically 1 because it is in the ground state. So N is 1, correct? So that is your ionization energy, and it is given to be 9 Rydbergs. So 9 times of 13.6 electron volt. So this is 13.6 Z square. 13.6 cancels. So Z square will be 9. So Z will be 3. So Z will be 3. Everyone fine till this point? I think we need the value of Z. We need the value of Z to solve the problem. Without that, we cannot do it. Okay. Now what is the next step? What is the wavelength? For wavelength, for electron transition, you use the Rydberg's formula, that 1 by lambda formula. So 1 by lambda is 1.1 10 to the power 7 Z square. Z square means it will be 3 square. 1 by 1 square minus 1 by 3 square. 1 by 1 square minus 1 by 3 square. Here this is Rydberg's constant. This is Rydberg's unit of energy. That's why this problem asked during Corona time is very tricky problem. Many students got confused in this question because of the units. This is Rydberg's constant, which is R, and this is Rydberg's unit of energy, which is 13.6 electron volt. Be careful. In the exam, you will probably make certain mistake. Avoid that. So 1.1 10 to the power 7 into 9. So this will be 9 minus 1, which is 8. The whole thing divided by 9. 9 cancels. So it will be something like this. Check it out. If it is 11.4, yeah. So lambda will be nothing but, yep, 1.1 into 8 into 10 to the power 7. So it will be approximately 11.4 into 10 to the power minus 9 meters, which is 11.4 nanometers. 11.4 nanometers should be the answer. Remember, this is reciprocal, okay? Do not forget that. This is 1 by lambda. So lambda will be inverse of that. If you forgot to take the inverse, you will get a wrong answer. Okay, everyone? Ready for the next set of problems? How many of you are feeling fatigued? How many of you are feeling, sir, my level of concentration has decreased as compared to the start? How many of you are feeling, tired or little bit, like feeling like giving up at this point of time? How many of you are there like that? Let me know in the chat box. Let me know in the chat box. If you are feeling like that, what is the solution for it? The solution for that is you have to give mock tests. Very good, Srija, not you. Very good, Ram, not you. You have to give mock tests sitting continuously for 3 hours. So we just began the class. What's the time now? It's almost 12:30. We began the class close to 11:10 or something. So after 1.5 hours, imagine if you are getting tired, fatigued, losing focus, not feeling excited. That means in the exam also after 1.5 hours, you will start making silly mistakes. Your speed will go down. That limit of losing focus or feeling fatigued or getting tired, that should be at least 3.5 hours. Not even 3.5 hours. Why that extra half hour? Because you will enter the hall, sometime before. The paper will be, not the paper, the computer will be set up in front of you. You will be filling things. You will be focusing on certain things. So for 3.5 hours, you should not lose any focus. That's the bare minimum, I would say. If you talk about advanced, then it goes to 6+ hours because paper 1, paper 2. Okay? Chalo. Let's go to the next question coming up on your screen. The decay of a proton to the neutron is theoretical question which was asked. So Beluga, I'll tell you something. The paper is going to be on the computer screen. So it is not a pen and paper based exam. Even BITSAT and many other exams are these days computer based. So try to do the following things. After every 5-10 minutes or 15 minutes, close your eyes, open your eyes. Close your eyes, open your eyes. Close it very strongly, open it very wide, and then move your eyes round and round clockwise 5 times, anti-clockwise 5 times. Try to look at a distant object for 5-10 seconds. Do this 20-30 second exercise after 10-15 minutes. It helps a lot. It will hardly take 20 seconds to 30 seconds to do this exercise. You can't wash your face because in the hall you cannot leave your hall, right? So do not try to do that. Washing the face will help you at home, but not in the examination hall. So do this eye exercise. What is the first step? Close, open, strongly and wide open. Second, rotate your eyes once clockwise, anti-clockwise. Third, try to see a distant object for 10 seconds. Okay, distant object, very far away object. Okay, that will relax your ciliary muscles. The decay of the proton to the neutron is, yes, it is possible only inside the nucleus. Oh, very good. Now you can, yes. Okay, only inside the nucleus because it is a nuclear reaction. Nuclear reaction. It involves nuclear forces where you will see that the neutron gets broken into proton and the electron. It does not happen outside the nucleus. How can it happen outside? Not possible as a proton? No, that is not correct. Not possible, but neutron to proton conversion is possible. That is wrong. Always possible as it is associated only with beta plus. No, that is also wrong. It only happens inside the nucleus. Okay. The ratio of the radius of the nucleus of these two elements is in which ratio approximately? Is in which ratio approximately? Come on, think about it. This is straightforward question. I want everybody to spam this answer because I had given you one formula in the nuclear physics class in the modern physics flash series. So radius is directly proportional to a raised to 1 by 3. A is the atomic mass number. Come on. Out of these two, which is the atomic mass number? Is it 13? No. I think, oh, this was, I think, inverted. I think this is wrong. This should have been exactly opposite. Forget this. This should have been T 125 and 52. I think this is what it was supposed to be, right? Forget this. Forget this. Okay. So this is 125. This is 7. This is 125. This is 7. Yes. So what is the correct answer? Everybody is saying B option. Very good. Oh my God. I think every slide has a different. Okay. So ignore this. This is not even going to matter. Wow. So this and this. Yep. So R1 by R2 will be cube root of 27 by 125. This will be 3 by 5. 3 by 5, option B. Yes, that's the correct answer. I think there was a printing mistake there. Okay, let's go to the next question. If M0 is the mass of oxygen, isotope, MP and Mn are the masses of the proton and the neutron, then the nuclear binding energy of the isotope will be how much? Interesting question. Come on. The nuclear binding energy. Binding energy formula is the mass defect into C square. Mass defect into C square. Everybody knows this? Very good. So what is the mass defect going to be? Well, the mass defect will be the higher mass minus the lower mass. Where will the mass be higher? I think the protons and the neutrons will be of the higher mass. So how many protons are there? I think there are 8 number of protons. So 8 times of MP. How many neutrons are there? The number of neutrons will be 17 minus 8, correct? So that will be 9. So 17 minus 8, 17 mass number, 8 atomic number, subtract them, neutron number. So plus 9 times of mass of the neutron minus the mass of the oxygen atom, which is M0. So this is delta M. So where is it? I think it is here, but I feel there was again a printing mistake here. Maybe this was modulus sign. I think this was modulus sign. This was modulus sign. Yes. So I think with that, the answer should be B, I guess. Yes, it is B. but it is not bracket, it is modulus. Basically, you take the positive value. Is that okay? Is that okay, everyone with me? Cool. Awesome. Bombay is the correct answer. Moving on to the next question coming up on your screen. Binding energy per nucleon for deuterium and helium is 1.1 and 7. If two deuterium react to form a single helium nucleus, then the energy released is how much? This is like a, yes, that was a pre-PYQ advai. I mean, just imagine these kind of questions do come, but also good level questions come. So we are doing all the spectrum of questions. So if you write the reaction, it becomes very easy. So for making the deuteron, so what do you need? I need basically one neutron and one proton to make a deuteron. So hydrogen isotope, right? Like this. And the binding energy will be 1.1 per nucleon. Per nucleon. Be careful. How many nucleons are there? How many nucleons are there? Obviously 2. So 2 times of 1.1 mega electron volt will be released. I hope till this point it is clear. To make helium, what will you need? You will need 2 neutrons and 2 protons. And how much energy will be released? Check this out. 7 per nucleon. There are 4 nuclear particles. So 4 into 7 mega electron volt, which basically gives you 28 mega electron volt. Here you get basically 2.2 mega electron volt. Now just take this first equation, multiply 2 times. Take the first equation, multiply 2 times. What will you get? What will you get? Just think about it. If you take this particular equation, multiply 2 times, what do you get? You will get basically 2 neutrons plus 2 protons will be basically that hydrogen isotope, plus multiply this 2.2 also 2 times, it will become 4.4 mega electron volt. Oh, the LHS is the same. LHS same. So use this and equate the 2. Use these 2 and equate the 2. So there is only one thing over here missing. This was into 2. This was also into 2. So I can then say 2 such hydrogen atoms plus 4.4 will be equal to this thing, RHS, helium plus 28. So 2 hydrogens will be equal to helium 42 plus, take the 4.4 over here. What will you get? 28 minus 4.4. How much will be there? How much will be there? Come on, my dear warriors. Is it not going to be 23.6? Is it not going to be 23.6? So 2 hydrogen atoms gave you a helium atom and you got 23.6 mega electron volt. So that is the energy which is released. You do it like your normal chemical reactions, how you balance them, how you balance the chemical reactions, exactly the same way. So just to give you a final idea of what we did over here, neutron plus proton gave you hydrogen plus some energy which was basically 2 into 1.1. This was 2, this was 1. Why 2? Because 2 nucleons, 1.1 was per nucleon. If I take 2 neutrons, 2 protons, I'll get 2 hydrogen atoms and this will become 2 into 1.1. Similarly, if you take 2 neutrons, 2 protons and directly make into helium, then you get 4 into 7 mega electron volts. 4 nucleons, 7 was per nucleon energy. So essentially what I have done is, since LHS is same, I have just equated the RHS. That's all I have done over here. And then if you notice, the difference of these two will be the energy released. Is that clear now? Is that clear? Understood, Rishabh? Vrihari, is that clear? Very, very clear. Pakka, what we just did. Okay, so 2H1 plus 2 into 2 into 1.1 will be 4He plus 4 into 7. So when you take it on the other side and subtract the 2, you just left with 23.6. Cool? Shall we go ahead? Shall we go ahead? These kind of questions can come. This is one common question which comes where they ask you how much energy is released from this conversion to that conversion, and they give you binding energy per nucleon. That's all. It's like balancing chemical reactions. Okay. Next question. In the figure, the potential difference between A and B, little bit of current electricity, little bit of semiconductor diodes. We have come to semiconductor chapter. We have slowly come to semiconductor chapter. Come on. You are also ultra legend. Thank you so much. If you do this Disha book completely, it is more than enough. Kind of. Yes, for PYQ practice. Definitely. Here, this diode is in forward bias. This diode is going to conduct electricity. So whatever current comes here is going to get distributed here and again going to come back and add up over here. This is what is going to happen, right? Now, this diode is an ideal diode because nothing is mentioned over here. So now this circuit just becomes basically a 10 ohm resistance, and these two are going to be in parallel. These two are going to be in parallel, which is then connected to your 30 volts, which is then connected to your 30 volts. Now this 10 and this 10 together, this 10 and this 10 together will make up 5 ohm resistance because they are in parallel, and that is connected to the battery of 30 volts. So what will be the voltage drops across each of them? Just calculate the current and multiply by the resistance, you will get the answer. The current in the circuit will be voltage divided by total resistance, which is basically 2 amperes. But the question is, what is the voltage difference between A and B? This is basically A, this is basically B, this is basically A, this is basically B. You can see that A and B, those are the exact 2 points. So voltage difference between A and B is the current into the resistance. Current is 2, resistance is 5, so it will be 10 volts. So where is 10 volts? C for Captain Shreyas. Yes, 10 volts is the answer. How many of you wrote it? Very good, Gayu. Awesome. Very nice. Very nice. Did you understand? Actually, was there any much role of diode? Nothing. But let me tell you, if the diode was opposite, then the answer will be completely different. Let's see how many of you can give the answer right now. It is not one of these options. If the diode was like this, if the diode was like this, oppositely connected, if it was in the reverse bias, then what do you think the answer would be? Come on, spam the chat box right away, right now. Spam the chat box right away, right now. Come on. Think, if the diode was reverse bias, then no current will go here. This branch of the circuit is completely blocked. Forget about this. So the current is only going to go in this particular branch, in this particular loop. And there are only 2 resistors, 10 and 10, 10 and 10. So think about it. Across each resistor, same voltage will be dropped. Across each resistor, same voltage will be dropped. Across 10, 15 volts, I think the option is one of them only. So 10 over, so 15 over here, 15 over here, answer will be B. Answer will be B. Okay? It is not 20 volts, it will be 15 volts. 15 volts. Yes, K square C. Understood? Because this diode will block the current completely. Okay, nothing will go. Forget this now. It's just this resistor and this resistor. Both are equal. So 30 will be distributed equally. 15 and 15 volts. Exactly. Perfect. Let's go to the next question. If there is a conductor, semiconductor, diode, photon with wavelength this much, then its band gap energy is. There is a standard formula for this. The band gap energy is the minimum energy to excite an electron from the valence band to the conduction band, and that happens via various ways, and one such way is by absorbing a photon. So the energy gap will be the energy of the photon which it absorbs. So it is hc by lambda. hc by lambda. Okay, so everything is given. What you need to find out is the energy gap. So this will be 1240 divided by 400. 0 cancels. So I think you will get this as 3.1. 3.1. Very good. See how many of you got it?
Please, I need to come and I need to leave. I have
Yes, very good. Hello Charan, thank you so much for all the love and all the hearts. So I hope you got this as 3.1 electron volt. Very good, very good. I'm using this. Why did I not use these values? Because it will be unnecessarily complicated, unnecessarily it will be lengthy. I know this standard value 1240, so I use that prior knowledge. Next, LED is constructed from this semiconductor material. The energy gap of this LED is 1.9. How much is the wavelength? I think you just have to use the same logic as before. You just have to use the same logic as before. Come on. You don't even have to worry about actual color. You just find the wavelength. That's it. Use the same formula. Energy band gap is hc by lambda. So lambda will be hc by delta E. Do I know the energy? Yes, it is 1.9. It is 1.9 and hc value is 1240. How much does that lambda come out to be approximately? I think it will come out to be 654 approx, because 1240, 1.9 is 2. So 124 by 2 is 62 over there, right? And it will be slightly more than 620, I guess. So 620 is will be the answer if it was 2, but it is 1.9, so slightly more than 620, which is this answer. But will it be orange or will it be red? I think 600 is close to the red color, not the orange color. Yep, it is going to be reddish in color. Remember the range of the wavelength? Remember the range of the wavelengths of visible spectrum? It goes close to 700 nanometers and starts from 400 nanometers. So 400 is for violet, close to 700 is for red color. So it is almost going to be reddish color. Correct. The color will be reddish. Remember the range of the visible spectrum, 400 to 700. It's slightly less than 700 actually. So it is option A. Okay, it's not orange. So these kind of things can also come. This kind of things can also come. We are now slowly entering logic gates. This is going to be fun. This is going to be fun and everybody loves this. Everybody loves this. Come on. Which of the following will be the output for the given circuit? Is this a NOR gate, NAND gate, AND gate or XOR gate? Because this is a complex circuit, I believe we better do this properly via truth table. Otherwise, I might make some mistake. So A, B and Y, we will try out all the combinations which are possible. So 0, 0, 0, 1, 1, 0, 1, 1. So these are the only possible combinations. So let's start with 0, 0 now. If this is 0, then this is 0, this is also 0, this is also 0, and this 0 also comes over here. 0 and 0, 0, not of that is 1, so that 1 comes here. 0 or 0, 0, so that 0 comes here. 1 and 0 will be 0, correct? So 1 and 0 will be 0, so this will be 0. Check this out. Check this out. Very good. So next you can try it out for other things also. Next you can try it for other things also. Like for example, this is 0, this is 0, this is 1. This is 0, this is 1. If this is 0, this is also 0. The same 0 will come here. This one will go here. This one will also go here. 0 and 1, 0. Not of that, 1. So that 1 will come here. 0 or 1 is 1. That same 1 will come here. 1 and 1 is 1. 1 and 1 is 1. Okay, perfect. Now, rather than trying 1, 0, I think we will try this 1, 1. What will happen with 1, 1? 1 and 1. If both are 1, see what will happen. The same 1 will come here. That same 1 will come here. This will be also 1 and this will be also 1. Okay. 1 and 1, 1. 1 or 1, 1. 1's opposite, 0. So that 0 will come here. This one will come here. 0 and 1 will be 0. Oh, most likely this will be also 1 now. And that means it will be an XOR gate. It will be most likely an XOR gate. Yes, check this out. Try the other one. Try the other combination also. You will get it as a XOR gate, because if both are false or both are true, then it is false. Only when one is true, it is true. It is an exclusive OR gate. Exclusive OR gate. No, it is not an AND gate or anything. Okay. It will be a XOR gate. So XOR gate questions can also come in the exam. XOR gate can also come in the exam. Be careful. Moving on. Next question. The output of the given combination of the gates is very standard type of question. And remember one thing, whenever I have told you this also, whenever you have a NOR gate which is shorted or a NAND gate which is shorted, it will be a NOT gate. It will be a NOT gate. When you combine both the inputs of a NAND or a NOR, it will be a NOT gate. So technically speaking, this is actually a NOT gate. This is also a NOT gate because I have combined both the inputs of the NOR gate. Now, over here, this is also a NOT gate. Over here, this part is also a NOT gate. And when you combine two NOTs together, they basically cancel out each other. They basically cancel out each other. Everyone? Everybody with me on this? Perfect? Okay. What next now? What next now? Just redraw the diagram to make it look easy. So from A, you have a NOT gate. From B, you have a NOT gate. So from A and B, you have a NOT gate. Both are going to go into a OR gate. There is no NOT after that because both the NOTs just got cancelled. Both the NOTs just got cancelled. So only OR gate is remaining. Only OR gate is remaining. And finally, you are getting the output Y. Both these got cancelled. These both are NOT gates. So what is the operation here? You are ORing A bar with B bar. You are ORing A bar with B bar. And there is De Morgan's rule which says if you have A bar plus B bar, it is A dot B whole bar. If it is plus, make it multiplication. If it is bar separately, combine them. Basically, if it is separate, combine them. If it is combined, separate it. So that's how the De Morgan's principle is. This is your De Morgan's theorem, okay, which is there in your logic gates, not in NCERT, but I am telling this to you separately. Use this as a trick to easily solve the problem. So what is this then? This is basically a NAND gate. A dot B means AND, with a bar means NAND. So hence it should be a NAND gate. So if you do it via truth table, it will be very, very lengthy. Else, if you use my method, it will be very, very short. And this trick also I have told you. This was the first trick which I told you. This was the second trick which I told you. NOR and NAND shorted is a NOT gate. Keep this in mind. Next, the logical circuit shown is equivalent to which of the following? I feel you can again use De Morgan's over here. I will tell you how. See, this input A goes over here as it is. This input B goes over here as B bar. This is a NOT gate. Okay. So here I am ORing it. Here I am ORing it. ORing it means I am doing A plus B bar. So technically what is C? The naught of this. So A plus B bars naught. Everybody understood this expression? This was A, this was B. Here it became naught of B. I am ORing it, so plus. Finally I am naughting it, so I put a bar over all of them. Now let's use De Morgan's principle. It says if it is a plus, make it a dot, and whichever two variables are there, A and B bar, if this was common, separate it. If it was separate, bring it together. Here it was common, that bar, so separate it out. Separate it out. So this will become A bar dot B bar is the same variable, is the original variable. Like 0 bar, naught of naught or negative of negative is positive. Same way. So what is this? You are doing AND operation of A bar and B bar and B. A bar is right over here and B is right over here, and this is nothing but a AND operation. So I think it is option A. Yes, it is option A. Very good. Very good. Awesomeness. Kudos. Moving on to the next question. In the given circuit, the value of the output Y is how much? It's like a maze. It's like a beautiful maze. Let's see how many of you can do this. A is 1. So the naught of that will be 0. So that 0, I think, is also going here, is also going here, also going here. 0 and 0, 0. Naught of it, 1. If this is 0, this is 1. This one will go like this and come over here. This one will go like this and go over here. Okay. This is 0, so this will be 0. 0 and 1, 0 and 1, 0. Naught of it, 1. So this one will go over here. 1 and 1, 1 and 1, 1. Naught of it, 0. So I think the answer will be a 0. Yes, it is a 0. What a brilliant question. Just like a maze, you have to slowly track it. That's it. Right? Very good. Very good. Now, there will be DPP quiz even below this session. Obviously, this session is not yet over. Please watch the session till the end because maths and chemistry is still remaining. And I want to show you two peculiar PYQs over here. You can put the answer in the comments or solve it at home. This problem, we solved it in the flash lecture. Exactly same problem, and it is asked in a slightly similar manner only. You can see this was asked in 2020. How many of you remember this question which we did in the class where the energy of an electron and the photon was same and we had to find the ratio of the wavelength? Same question. Then also look at this question. By the way, the answer to this will be posted in the Telegram channel. You have to join it. Look at this question. This also, we have done it in a slightly different way in the flash series. This also was repeated in 2021. So whatever questions you do in the exercise in the class or somewhere else get repeated some way or the other. Some way or the other. This question we have done in the flash lecture just 2 days back. Just watch that, you will get an idea. So where is this DPP? I will let you know. And meanwhile, do not forget to comment WP after the session is over. Now you will have the chemistry session after some time, and then you will have the math session. So here we go, right over here. This is your favorite Vedantu JEE English channel. You can see the marathon is continuing. You can see all the lectures which were conducted in the last few days are right over here. And as you are watching this lecture, right over here, go to the description box and you will see there is a link to join the Vedantu Telegram channel. Why you should join it? PDF, test link, everything will come up over here. So please click this link, join the Telegram channel. Okay. All right. Then the next thing is the test quiz is also there. So based on today's session, just click on that, enter your phone or your email, free registration of course, and then you can begin with today's assignment. Okay. So now it's time for Navamita ma'am to join in. It's time for Navamita ma'am to join in. Meanwhile, keep trending. WP. Let me just check with Nabamita ma'am if she is ready or not. Okay, just hold on. Hello ma'am, ready? Okay. Okay, so guys, ma'am will be here soon. So hold on to the session, right? You can finish your snacks quickly, grab something to drink, okay? Relax your muscles, do the eye exercise which I told you, okay? And keep smashing the like button, okay? Nabamita ma'am for chemistry is going to be here, and after that, yes, your ninja ma'am for mathematics is also going to be here. So stay tuned on the channel, do not go anywhere. I hope you enjoyed the class. Please let me know in the comments after the lecture is over.
Hi guys! Am I audible and visible? Hi everybody! Yes! Hi guys! Hi Beluka! Hi Teja! How are you guys? Okay, quickly go and call up your friends everybody. We are going to start. However, there is a slight bit of a thing that I have done which I should not have. I shouldn't have done this, and you know what I have done is I haven't charged my iPad. Now it is not getting switched on, so you have to give me a couple of minutes and then it will start. So in today's session we are going to do around 40 questions from coordination, compounds and DNF block, and I have mostly the recent PYQs, that is the questions from 2023 and questions from 2022. Okay, why not blackboard? How many times have I told you guys here? Why do you keep asking me the same question again and again? Aren't you tired of asking me this? Huh? Aren't you tired of asking me this? Okay, so you guys, what you can do is, no, I haven't eaten. I'll finish it after the class. You guys can get your lunch. You guys can get your lunch and you can study with me. Because it is chemistry, it's not going to be that difficult. It is the most scoring part of your session, and you know all of that, right? Yes, I believe that you all know all of that. So, shall we start, everybody? Shall we start? No, but you still have to wait. You still have to wait. Yes, so how was the session, everybody? Let me give you a couple of minutes. You call up your friends and then we will start. What do you all think? Yeah? Let me give you a couple of minutes. Or no? If it doesn't work, you can use Shreyas sir. Do you know how far he stays? And it's not like I can pick up the board and put it on my home, right? I can't do that. So come on, talk sense. Talk sense. How can I use Shreyas sir's board? He stays very far. If I have to go to his house, it will take me 1 hour to go, 1 hour to come back. That's a lot of, you know. Ye dekho. You can ask Captain Foot. What do you think? How big is the digital board? I will need a truck every single time I want to take a class. It's just not possible. So stop it. Get used to it. This is how it is going to be. Okay. This is how it is going to be. So let's not worry about it at all. Yeah. Okay, guys. Looks like this thing is not working. So I believe I will have to take you through. Two more minutes. We will have to go old school today. Yes, we will have to go absolutely old school today. Why? Because Abnormal electronic configuration, eh? What is that? Okay, here we are. Yes, can you guys see this? Can you guys see everything clearly? Don't worry, with practice everything gets better. With practice every single thing gets better. So don't worry about it. Yes. Chalo, let us start everybody. Let us start. No more delay guys, no more delay. All right, yes. Okay, everybody, in today's session, we will be doing coordination compounds and DNF block like I have just told you. And you know that you are going to get DPPs just after the session. And by the way, one last thing that let me tell you is that in the Telegram channel, you will be getting the PDF of this session as well. So do make sure that you are following our Telegram channel. All right. Yes. Now, let us go with the first question that we have here, everybody. And the first question is, what is the primary and the secondary valency of cobalt, respectively, in CONH35Cl2? Anybody? Yes, I'm pretty sure that you all know this answer. But let me tell you one more time, everybody. I think that we all know. NH3, 5 and Cl. There is 1 Cl and 5 NH3. Now we all know that coordination number is equal to what? It's equal to the secondary valency, isn't it? This is equal to secondary valency. Correct, everybody? Do we all know this? Do we all know this? Great. Amazing. Now, primary valency is equal to what, bachos? What is primary valency equal to? Primary valency is equal to what, guys? Anybody? Primary valency is equal to what? It is equal to the oxidation number. Correct? Everybody? Right or wrong? Right or wrong? Yes, we are right. Primary valency is equal to oxidation number. So how do we calculate the oxidation number, everyone? We will consider the metal. Yes, we will consider the metal to be X because we do not know the oxidation number, right? So we will consider this to be X. Now, every ligand has its own charge. What did I say? Every ligand has certain bit of charge in them. But we know that NH3 is a neutral ligand. So, all we have to do is, there are 5 NH3. So, 5 multiplied with 0 because it has no charge. It's a neutral ligand. And then what do we do? Is equal to, right here, do you see, if this is Cl2, Cl has a negative charge. Always Cl has a negative charge. So that means that if Cl is 2 minus, I am assuming that you all know that this will have what, 2 plus charge right here. Correct. So this will be equal to plus 2. But here we have another Cl. So I have to calculate here minus 1. So that means that X is going to be equal to plus 3, isn't it? X is going to be equal to plus 3. And we can see that the coordination number right here is 6. So that means, yes, some of you are absolutely correct. It is option number D. Now, everybody please have a look at it and let me know. I'm moving out of the board just so that you can have a clear picture. And let me know, is there any confusion or did anybody else find a different sort of answer? Did anybody find any other answer? Abdul, very good. Option D. Gayu, Sahiti, Abhinav, very good. Yes. Hi Rishi, Babu, very good, very good. You guys are doing an amazing job. Yeah. Nazar na lag jaye mere bachos. Yes. So what do we say after this question? And by the way, do you guys see JEE Main 2023? I'm not even kidding. See, I'm not even kidding. JEE Main 2023. This question has come. So that means easy peasy biryani tasty 4 marks. 4 marks. Hence proved coordination compound and DNF block together can fetch you 16 to 20 marks. Now tell me, are we going to study these two chapters thoroughly so that we know each and every question? Are we going to do that or not, guys? Are we going to do that or not? Everybody answer me. Easy peasy biryani tasty. Are we going to do that? We are going to do that, isn't it? What happened to the chat? Why am I not seeing the chat? Hey guys, where are you? Now I can see. Yes. Now I can see. Chalo. Shall we go to the next question then? Let's go to the next question. Secondary valency is 6 now. Secondary valency is equal to number of ligands attached to it. So we see that there are 5 NH3 plus 1 Cl and that is equal to 6. Hai na bacha? That is equal to 6. Clear? Crystal clear? Perfecto? Understood? Chalo. Next question, everyone. See, this is the correct answer. We are absolutely right. Moving on. Next question. The next question is, which of the following cannot be explained by crystal field theory? Siddharth, I'm very sorry, but look at the channel name. The channel name itself is Vedantu JEE English channel. Hence, it will be very difficult for us to, say something in Hindi, right? The channel name itself is English and we are going to make sure that we follow English thoroughly here, right? Okay, everybody. Now, which of the following cannot be explained by crystal field theory? Anybody, any idea, guys? I believe that you know. But let me still ask you. Now, we know that in crystal field theory, what were the postulates? Remember, what were the postulates? The postulates in crystal field theory clearly said that the metal will be considered as positive, right? And the ligand, if the ligand is an anionic ligand, then we will consider it to be what? A point charge. And we assumed that the interaction was completely electrostatic interaction. Do you remember that? Yes, we do. So that means now that the anionic ligands, which are point charges, they are supposed to be what? They are supposed to be strong field ligands, but that was not the case. In spectrochemical series, we saw that the halide family, that is I minus, F minus, Cl minus, they were all in the weaker side of the spectrochemical series. Then came oxygen donor sites, then came nitrogen donor site, and the carbon donor sites were the strongest. So that means that the order of spectrochemical series, which was gathered from experimental data, that was not explained by crystal field theory, right? Yes. How Cl oxidation state is +2? Where did I say that Cl has +2 oxidations? No, Baba. See, you guys, so many times I have taught you. Dekho bacha, CO, cobalt, NH3, 5, Cl, right? Now, outside you have Cl2. One Cl has one negative charge. One Cl has one negative charge. That means 2 Cl will have 2 negative charge. Clear? If Cl is 2, that means this has 2 minus charge. That means the whole coordination entity has 2 plus charge. Agreed? Now do you understand? Yeah? Now do you understand? Clear? Who was it who asked me this? Yes. Vahini Anand, did you understand now? Yes? I hope you did. Chalo. Now moving on. So the order of spectrochemical series could not be explained by crystal field theory, which is why we had to move towards molecular orbital theory, and that we study in the chemical bonding chapter, which we will be doing in we will be doing that on Monday, everybody, and I need you all to come on Monday as well. Okay, Monday, I think at 2 o'clock I'll be taking a session so that you are done with your lunch and then you can come. Okay? Alright, chalo guys. Moving on, next question. The hybridization and magnetic behavior of cobalt ion in cobalt NH3 6,3 plus complexes. So can somebody tell me what is cobalt's atomic number? Can somebody tell me what is cobalt's atomic number? Anybody? Cobalt has an atomic number of Every time you have to remember what is an atomic number. Always count. Sachin Tendulkar, very crazy man. Free coaching. Coaching is cobalt. So 27 has to be cobalt's atomic number. If it is 27, that means the electronic configuration, very easily we can say it is 3d7 4s2. Correct? Very good. 3d7 4s2. But now we have to calculate the oxidation number. So let's say that cobalt will have X plus NH3 is a neutral ligand. So 6 multiplied with 0 is equal to plus 3. That means directly relation is X is equal to plus 3. Correct? Great. Now what will happen? So cobalt in plus 3 state will have a electronic configuration of 3d6. Am I right? 2 will fly away from 4s2 and 1 will fly away from the 3d. Correct? So it will have 3d6. Correct. 3d6. So 3d6 with NH3. Let's draw the orbitals here. Okay. So we will have 1, 2, 3, 4 and 5. Right. Then 1, 2, 3, 4 and 5. And here we will have 6. Now NH3 is belonging to what? N is the donor side. That means it is almost at the strongest side of spectrochemical series. Am I right? It is almost at the strongest side. That means pairing will happen. Yes, pairing will happen. So this will go here and this will go here. Pairing will happen. After pairing, then what will we get? We will get D2sp3 hybridization. And since I see that everything is getting paired up, plus there is NH3 which will come, that means there are no unpaired electron absolutely. Are you listening, everybody? No unpaired electrons. No unpaired electrons will be there. Everything here will get paired up, and then NH3 will use this two d orbitals, plus it will use the s, and it will use the p. 3 orbitals together, D2sp3 and diamagnetic. That means option C becomes our correct answer. Very good. Many of you are giving the correct answer. Beluga, Nani, Shefali, well done, well done, well done. Clap for yourself, guys. Clap for yourself. If you are able to answer these kind of questions, then that means that you are definitely getting at least 16 to 20 marks in your examination, right? Everybody, good to go? Good to go, everyone. Good to go, good to go, good to go. No? Yeah? Good to go, guys? Cool? Alrighty, alrighty, alrighty. Chalo then, moving on. Next question, everybody. Next question. Yes. Ooh, okay. Guys, there are 2 or 3 types of questions that they will definitely ask in JEE Mains paper. Okay. Number 1 is they will ask you one question that is related to NiCN, nickel coordination complexes. Okay, because there are certain you find different geometries and with different ligands, and I can form different sort of things, right? So they will definitely ask you one question which is related to nickel coordination complex. One will be this match the following type of question. One will be regarding absorption of wavelength, right? Okay. And there will be one question that will be, maybe it will be related to Warner's theory, which we will do. Okay? So these 4 or 3 type of questions are given. It will definitely come. Whatever you do, make sure that you try and practice as much of these questions, because they'll definitely ask you this. Okay? Chalo guys. Now let us have a look at it. And I'm going to give you a trick, by the way. I'm going to give you a trick here also. Okay? See, what you have to do is you have to match list 1 with list 2. Okay? What do you have to do? List 1 with list 2. We have to match. Now coordination entities are given and wavelength of light absorbed in nanometer is given. Now do you know something? Do you know that whichever has a strong field ligand attached, have a look at the list. Have a look at the list. Find out, does any of the option have a strong field ligand attached to them? If there is a strong field ligand attached to them, then the strong field ligand will absorb shorter wavelength. Bole to shorter wavelength will have high frequency. High frequency bole to high energy, right? High frequency, high energy, shorter wavelength. Shorter wavelength. What is wavelength? Wavelength is the distance between two consecutive trough or two consecutive crest. Correct? Right, everybody? Great. So, out of all of these, we can clearly see that Cn is a strong field ligand. In fact, one of the most strong ones, right? Cn is a strong field ligand. That means it will definitely, yes, it will absorb a shorter wavelength, that is 310 nanometer. Now, let's have a look which one of them is the weakest. Water. Aqua. Aqua is one of the weakest ligand, and that means that it will definitely absorb the large wavelength, right? So 600 nanometer, because it will be able to absorb what? Low frequency, low energy, right? Great. Okay. Now have a look, everybody. Now we see that these two ligands have NH3, NH3. However, here option A has Cl as well. Now Cl being an anionic ligand will be even more weaker than NH3. Am I right? So that means directly we can say that because of the presence of Cl, we will have option 535 that will be absorbed by option A, and B will be absorbing option 2, that is 475. So now that means that what do we get? We get A is equal to 3, B is equal to 2, C is equal to 1, and D. Yes, option B is the correct answer. How many of you told me the correct answer? Yes. Why will you ask me physics questions in my class, Siddharth? I'm not a physics teacher. Option B, best edits, very good. Naga, Gayu, well done. You guys are on fire today. So write down EPBT, everybody. So these are all JEE Mains 2023 questions. Last year, recent PYQ, so easy, everybody. So now confidence is up. Confidence is up. You think you will be able to do it? See, chemistry is the most scoring, guys. Chemistry is the most scoring. The more you practice chemistry questions, your chances to get above 95 percentile becomes very good. Okay? Best edits moe moe karenge, ठीक है? Moe moe, moe moe. What else to do? Chalo, moving on. Now, chiral complex from the following here is. You are already given that En means ethylene diamine. Okay. So let me quickly tell you, everybody. See, look at this. Cis isomer of PtCl2En2. Okay. Let me draw this structure, and I think you will be able to do it. Okay. Let me draw this structure. See. Cis isomer, right? So here is Pt, right? Here we will have 1, 2, 3, 4, 5 and 6, correct? So let's say that I have Cl here, I have Cl here, then I have En here, En is a bidentate ligand, so we know this. Now let me draw the mirror image, okay? Let me draw the mirror image here, and everyone check it out. Everybody check it out here. Pt, 1, 2, 3, 4, 5 and 6, right? Now what will happen is Cl will come here, Cl will come here, then we will have one En here, and one En here. Acha. Now tell me, for a chiral complex, right, there should not be any plane of symmetry. So let us try and cut it. Let us try and cut it in different direction. See if you get any. See, do you get any plane of symmetry? If I cut it like this, do I get any symmetry? No. If I cut it like this, do I get any symmetry? No. If I cut it like this, do I get any symmetry? No. If I cut it like this, no, there is no symmetry. There is no symmetry. Plus the mirror image, if you see, is it overlapping? Is it overlapping? The mirror image. Try. Let's pick this up. Let's pick this up. Let's pick this up and let's try to put it here. Do you think that this is overlapping? Not at all. So here our correct answer is PtCl2En2. This is your cis isomer. Now try and do it with everybody else. Try and do it with all the other options and check it if this is the correct answer. Everybody, come on. Have a look at all the other diagrams also. Make all the other diagrams just so that you are sure. Now I know that this is the correct answer, but please, the diagram is not clear. Acha. So you want me to have a better handwriting also now, huh? Expectations are a little too much from your teachers, no? Huh? Now you want me to have a better handwriting also. Sorry, bro. At this age, you know, having a better handwriting is kind of difficult because I do not really have time to practice on a cursive handwriting book. But chalo, let me try it again. Yeah. Today actually the worst part that I have done is I haven't charged my iPad. That was the mistake that I have made because I was looking at Shreyas sir class and I completely forgot that I had to charge my iPad. But anyway, let's try it once again, guys. Let's try it once again. Let's see if I can draw it now. Here is a PT 1, 2, 3, 4, 5 and 6. So we have Cl, Cl, En is a bidentate ligand, so we will connect this together like this. And now what am I going to do is, we are going to draw a mirror image. Is this better? Wait, I'm moving. I am moving, wait. Here, so we have 1, Cl, Cl, En and En. Yeah, now is it better? Now is it better, guys? Yes, this diagram is fine. Now do you understand? Trans PTCl2 only dextro and levo. Exactly, that's why I said now make the diagram and find it out. It's not even possible. So option A is our correct answer. Correct. Option A is our absolutely correct answer. So do we understand this? Are we good to go? Are we good to go, guys? Yes or no? Good to go? Chalo, let's move on to the next question. The next question, everybody, is the correct order of spin-only magnetic moment of the following complex ion is. But choose, I don't know how many of you have watched the Flash series. Have you watched the Flash series of coordination compound and DNF block? If you haven't, do watch it, because why am I telling you? I have provided you certain tricks there that are useful while you are solving these kind of questions, because if you are trying to calculate and make the diagram of the d orbital, make the diagram of the sp orbital, and then you are trying to calculate, it is going to take up a lot of time. Otherwise, these questions are very easy. You should be able to finish it in 1 minute. Please watch that session. It's a 3-hour session, but 2 chapters are getting completed in that 3-hour session, and you can get 16 to 20 marks from there. Please do watch it, okay? Chalo, guys. Now, let us solve this. You have to correct order of spin only magnetic moment for iron. Now iron okay, let me write it with yellow color so that it's more prominent. Iron has an atomic number of 26, correct? 26 bole to 3d6 and 4s2, right? Very good. If that is the case, now we clearly see that F6, fluorine, is a weak field ligand. If it is a weak field ligand, and here we see it is in 3 minus, that means that iron will be in +3 oxidation state, because fluorine also has a negative charge. Are you getting it? How am I trying to orally solve it, everybody? Here there will be -6, -3, -6 will go to right hand side. So +6, -3, +3. So in +3, iron will have 3d5. That means 5 unpaired electron. And fluorine, being a weak field ligand, won't be able to pair up the electrons at all. So what will we have? We will have a Bohr magneton that is equal to 5.84, 5.75 sort of. Correct? Great. Okay. Now have a look at cobalt. Cobalt has an atomic number of 27 boleto, 3d7 and 4s2, my dear students, right? Rakesh Bacha, chapter name is coordination complex, right? 3d7, 4s2. Have a look, everybody. 3d7, 4s2, right? Now, once again, clearly it is visible that cobalt is also in +3 oxidation state. So in +3 oxidation state, cobalt will have 3d6. 3d6 bole to 4 unpaired electron. That means it will be 4 point something something. That will be the Bohr magneton, right? That will be the Bohr magneton. Correct. Very good. Now C2O4. Everybody have a look. C2O4 is a oxalate ion. Carbon being the donor site here, we will have a strong field ligand. So 3d6 boleto, there will be pairing up. Once the pairing up happens, what will we get? We will probably get a diamagnetic complex, because 3d6 pairing up will happen, and then there will be 2, 2, 2. This is a bidentate ligand, by the way. Yes, this will be a bidentate ligand. So 3 into this bidentate ligand, that means it's an octahedral complex but diamagnetic. So this will have the least amount of Bohr magneton. Magnetic moment will be lesser here. So yes, some people were absolutely right. Option A is the correcto answer. Nagasai, very good. You calculated. Yeah, it will be. Acha, one more trick, everybody. One more trick. Let me tell you. So you all know that the magnetic moment is usually almost equal to number of unpaired electron. Do you know by how much? SFL means strong field ligand, bacha. SFL means strong field ligand. WFL means weak field ligand. Okay. Yes. Now, what was I telling you? The trick is, everybody, remember, you don't always have to calculate. You don't always have to follow this, this formula. You don't always have to follow mu is equal to root over n plus 2. Why will you calculate so much? No, you don't have to calculate so much. Always remember, whatever is the number of unpaired electron, the magnetic moment is almost equal, but generally it is seen that it is 1.75 or 0.75. It is 0.75 more than the unpaired electron. Generally, not always, but generally, the number of unpaired electron is, let's say, 4. So 4 plus 0.75, generally, almost 0.75 more than the number of unpaired electron is your Bohr magneton. Yes. शोमी चैटर्जी मैम लिगैंड क्या होता है? अरे बच्चा क्या कर रहे हो? हैं? कब है तुम्हारी एग्जाम? जनवरी 24 तारीख को ना. आज अगर आप पूछोगे कि मैम लिगैंड क्या होता है, कौन से क्लास में हो बच्चा? कौन से क्लास में हो? प्लीज जल्दी से बता दो कि यू आर नॉट अपियरिंग फॉर योर JEE 2024 राइट नाउ ऑन जनवरी 24th, बिकॉज इफ यू आर इट विल बी वेरी डिफिकल्ट. ठीक है? Please tell me you are not appearing for the Jan 24 wala exam. If you are, it's going to be very difficult. Okay? Yeah, I told you no. I'm not using my iPad today. I'm using this vacuum thing. So it's not working very well today. It's not working very well today. Somehow it is not getting... Also, I have a new laptop, right? Remember? My previous laptop was giving me sound problems, so I had to get it changed. And now that app is not installed here. So a lot of trouble here. My life is not perfect. What to do? My life is not at all perfect. But yeah, you can't help it. There are some times when you just cannot help it. What to do? Yeah, but life has to go on also. Na? Life also has to go on. So I think it's okay. It's okay. Anyway, guys, how's the Josh? Are we good to go? Shall we move on? Shall we move on, guys? Congratulations for what? Chalo, next one. Which of the following is the correct order of ligand field strength? Yes. Which of the following is the correct order of ligand field strength? Okay, this you should be able to tell me. I am pretty sure that you all know. Once again, everybody telling you the trick. The anionic ligands are the weakest. Yes, that is the halide ions F minus, Cl minus, I minus, Br minus. They are the weakest. Then what you have? Then you have the oxygen donor sites. Then you have the nitrogen donor site. And the strongest ones are the carbon donor site. So easy peasy, biryani tasty. Let's have a look at which is the correct answer. We can clearly see that this is... what do you think, guys? What do you think? What do you think, everybody? I think it is option B because... No, it cannot be option B. What do you think, guys? Come on. Let's have a look at it. What is your answer? S2 minus C2O4, 2 minus NH3. You really think so? You really think so? I think S2 minus, then NH3, then En, then CO, and then... no, CO has to be the strongest one, right? Option B. Everybody is saying option B. Let's check it out. Yes, option B is the correct answer. Very good, very good. En is a strong field ligand. CO is the strongest ligand, guys. Carbon monoxide is the most strongest strong fill ligand available. And the weakest one is I minus and Br minus. Okay, remember this. All right, H2O, NH3, they all come in between. The strongest is CO, and then it is Cn minus. Then somewhere it is, there are all the other ones which carbon donor side, and at the end this side the weakest ones are always the anionic ligand. Okay, all right, best edits. We are doing coordination and DNF block. Don't ask me questions from other chapters. Ay, virtual punch you will get. That too I'm showing you slab. See, life is not perfect, told you. Okay guys, very good. Moving on, let us do another match list 1 with match list 2. Everybody ready? Okay, so what do we have here? We have NiCO4. NiCO4 will have what type of hybridization? CuNH3 2 plus will have what type of hybridization? FeNH3 2 plus will have what hybridization? And FeH2O 2 plus will have what hybridization? So shall we solve it? Yeah. Let's solve it, everybody. The first one is what? NiCO4, hai na? NiCO4. I hope everybody knows that nickel has an atomic number of 28. That means it will have an electronic configuration 3d8 and 4s2. Correct? Great. Okay. Then what will happen is, let's find out the oxidation state. We can clearly see that CO is a neutral ligand. So X plus 4 multiplied with 0. Overall charge here, do you all see, is also equal to 0. So that means this is going to be 0. Yes. So nickel is in 0 oxidation state. That means no loss of electrons are going to happen, right? No loss of electrons whatsoever. So that means we are going to draw it sort of like this: 1, 2, 3 and 4, 5, right? Yes, done. Then we also need here 4s2, right? And let's say that there are 4p vacant orbitals, 1, 2. So we have 3d orbital here, 4s orbital here, and we have your 4p. No, I'm not showing you the options. Let us solve it, everybody. So 3d8, right? 1, 2, 3, 4, 5, isn't it? 6, 7, 8. Here you will have 4s2. Now everybody, do you also remember that carbon mono? Are Baba, I'm not showing you the options. Solve it now. Solve it. Chill, Mari. Solve it. Yes. Now what do we have here? We have 4s2. So this 4s2 orbitals, they will be paired up. Why? Because carbon monoxide is a very strong fill ligand. It's going to push the electrons to D, and here you will see that this will be empty and so will this be. Once these two are empty, then it will take up sp3 hybridization. Yes, sp3 hybridization is the correct answer. Now have a look, everybody. So what did we just figured out? We have figured out that NiCO4 has sp3 hybridization. Cool. Next one, let's solve it. Next one is CuNH3 2 plus. What do we have? CuNH3 2 plus. Okay, CuNH3 2 plus is our coordination complex. Now copper has what? Copper has how many? What is the atomic number of copper, guys? What is the atomic number of copper, everybody? Copper's atomic number is 𝐶𝐧𝐿, CuZn. So that means it will have 29. 29 bole to 3d10 4s1. Remember, this was an exception. This was an exception. Yes. Yes, this was an exception. So 3d10 4s1. Now, here we will also have to calculate the oxidation number. So copper will be X plus 4 multiplied with 0 is equal to plus 2. That means clearly copper is in plus 2 oxidation state. So copper in plus 2 oxidation state will have what? 1 from here gone, 1 from here gone. We will have 3d9. If it is 3d9 and if we draw it, everybody, let's draw it here. What do we have? What do we have? 1, 2, 3, 4, 5, right? Yes, so we will have 1, 2, 3, 4, 5, 6, 7, 8 and 9. But NH3 is not going to be that strong of a ligand. And where is it going to push it? Nowhere. So what will we have? We will have 4, right? So S, then we will have P3, right? P3, sp3d. It will take up the next d orbital that is available, isn't it? So 1, 2, 3, 4 and 5 here. This d orbital from here, it will take up 1d. So we will have sp3d, correct? sp3d2, no, dsp2. Where is it? dsp2, sorry, it will take up dsp2. See, here you have 1, right? 3d9, 3d9. Is it copper only, guys? dsp2 it will take, dsp2, yes. NH3, 4. NH3, 4 with copper, 2 plus. It has got to be dsp2, yes. But where will this electron go? 2 plus, no? 2 plus. 4s1 gone and 3d9. 4d, 4s2, 3d9 if it was dsp2. It will take 1d here, s and then p2. No, there is something wrong. 1 second, guys. 1 second. 1 second. Let us check this out. There is something, there is some error. Okay. Yeah, it will have dsp2. 29, yes. No, but then where will this... Oh, yes. No, there will be pairing up. So what will happen here is, yes, I have forgotten. So now from here, this will be pushed up here, okay? This will be excited and this will go that side. So we will have dsp2. Either it will go here or it will come here. It will come here. Sorry, it will come here. Yes, this is what is going to happen. Chalo, let me draw this once again. Here. Just so that it's a little bit better. Yeah, I was trying to figure out that what will happen here. Yes, guys. You are right. It will have dsp2. It will have dsp2. But like we said, here we will have an s orbital. Here we will have our p orbital. And here there will be the next d orbital, right? 1, 2, 3, 4, 5. So this d orbital, right? This one electron that we have, it will get pushed up here. NH3 will come and attack here. It will come and attack here. It will come and attack here. And it will come and attack here. So it will have dsp2 hybridization. Okay, it will have dsp2 hybridization. Correct? Okay. Yes, one line electron in d orbital will be transferred to the next p orbital. So this will be dsp2. I think by now you already have calculated what is going to be the answer. Looks like it is option D. Looks like it is option D, isn't it? Option D, right? Why, Tanisha? Tanisha, why? Because see, it is convenient. It is convenient for NH3 to take the inner orbital and push that one electron outside rather than taking the next d orbital. Next d orbital will obviously have higher energy, right? So instead of hybridizing 4s, 4p, 4d, 3d, 4s, 4p, they have almost similar energy. So this becomes easier to hybridize rather than 4s, 4p, 4d. Understood? Understood? Yes, Tanisha, I think I've just explained. Did you understand now? It is an exception, but do you understand what I'm trying to tell you? That comparable energy is between 3d, 4s, 4p, not 4s, 4p, 4d. 4d becomes higher energy. Orbo principle, chemical bonding, do you remember? Do you remember? Yes. Now 4s, 4p, 4d directly does not come. After 4s, 4p, you will get 5s, 5p, then there will be 4d. Correct? Yes. So that is why this is what will happen. Chalo, next question everybody. Next question. Yeah, next question. The Cl-CO-Cl bond angle values in a facial. Okay, so this is a facial meridional, that FEC-MER isomerism. Do you remember? So in a facial CONH3 3Cl3 complex is R. What is it going to be? Oh, we all know in a meridional, everybody. Meridional. If the isomerism is of meridional type, then the bond angle becomes 90 degree and 180 degree. But in a facial type of isomerism, you will have only 90 degree. So this was one question where you did not have to solve anything. You are just supposed to know. Option B, 90 degree is the correct answer. Tanisha, no, there are certain other exceptions as well. Right now on top of my head, I'm not getting it. But you know what? I'll take another session, okay? Maybe I'll do a one-off session wherein I'll be telling you all the exceptions and coordination compound. Is that okay? Is that okay? Yeah? I'll do that. I'll do that for you. Don't worry. I'll do that for you. Chalega? Yes? I'll do that for you. Hai na? Yeah. So is this understood, everybody? Can we have some EPBT? Can we have some EPBT, everybody? This is a very easy one. So you have cobalt and you have Cl. Let me draw the structure as well for you, just so that you understand it a little better. So you have CO here. Now you will have 1, 2, 3, 4, 5, 6. Clearly it is saying that this is a facial type of isomerism. So that means you will have Cl, 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 you will have NH3, NH3, and you will have NH3. Now what you have to do is, all you do is take a look at this, okay? Actually, this is not supposed to be here. This will rather somewhere be, one second. This will actually be here. Array. Ha. So it will be somewhere here. Now, calculate it. What is this angle? This angle is 90 degrees. So this is why it will be 90 degree. Okay? Alright? Yes? Okay? Done? Everybody got it? Cool. Chalo, moving on. Moving on. The correct answer is this. Now this is a question that is a very big question and it looks like it is tough. But let me tell you that it is not very tough. Okay? And this is belonging to Werner's theory. Werner's theory, do you all remember? What did Werner's theory say? Werner's theory said that whatever is the counter ion, the primary valency, if it is more, then you will be getting more moles of the product. Right? What will you be getting? You will be getting more moles of the product. Once again, everybody, what did Werner say? Werner said that if you have more moles of or more counter ions, let's say that, okay, understand this. See, do you see that it is only SO4? That means there is only 1 mole of SO4. So this what will happen is, it is only going to give you 1 mole of the product. Remember what was Werner's theory? Does anybody remember what was Werner's theory, everybody? Let me show you what is it that you have to read in your NCERT so that you are able to understand this a little better. Let me show you right away, everybody. I have the book right next to me. Please do study this, everybody. Please do study this particular table. This particular table right here, everybody. It is page number 238. Do you see here? Yellow color formula CONH363 plus. If there are 3 Cl minus ions, then what will you get? You will be getting 1:3 electrolyte. Conductivity was increasing. 3 Cl minus ions were giving more conductivity. If there were 2 Cl minus, conductivity decreased a little bit, right? Do you remember? This particular table you have to study properly. This is what tells you more about Werner's theory. Also, this right here what they have written, okay? Right here what they have written. Please do study that very well so that you understand and you are able to solve the Werner's theory very well. So now read the question, everybody. They're saying that 1 liter 0.02 molar solution of CONH35SO4Br is mixed with 1 liter 0.02 molar solution of CONH3 5Br SO4. 1 liter of this, if I mix it with 1 liter this, that means my resultant now volume is 2 liters, correct? Resultant volume is 2 liter. Yes, now what is happening is this resultant solution is now divided into two equal parts. Two equal parts bole to one will have 1 liter, the other one will also have 1 liter. And now I can see that it has 0.02 molar. So if I divide it equally, then what will I have? I will have 0.01 molar here. I will have 0.01 molar here. I am dividing it equally. Dividing it equally. Agreed? Everybody? Great. Now see here, what do you have? The counter ion right here is Br. If it is Br and if it reacts with AgNO3, then what will happen? You will be getting some amount of AgBr, but you can clearly see that there is only one ion of Br. That means you will be getting 0.01 molar. If you take 0.01 molar of CONH3 5SO4Br, you will be getting 0.01 molar AgBr. Guys, are you able to understand? Guys, everybody, are you able to understand, or everyone is busy with their own chatting? Please tell me, or should I explain this to you once again, everybody? Should I explain this to you once again, or are you good to go? People? Are we good to go? Once again, everybody, what did we do? We took 1 ml. We took 1 liter, right? 1 liter of X solution with 1 liter of Y solution. Mixed it up, we get 2 liter. Then the question says that we are dividing into 2 equal parts. If we divide it into 2 equal parts, chalo, let's do one thing. Let me erase all link, okay? Now, let's again do this from the very beginning. The question says, everybody, question. Read the question, guys. Read the question. 1 liter 0.02 molar solution of CONH3 5SO4Br is mixed with 1 liter 0.02 molar solution of CONH3 5Br SO4. So till here, just the first sentence, guys, just the first sentence, if you read, what is it that you understand? You understand that I have mixed 1 liter of something with 1 liter of something. So my resultant solution will be 2 liters, correct? Yes or no? Yes or no? Now respond. Once again, you will say again. Respond, bachos. 1 liter plus 1 liter will be what? 2 liter, right? Yes? Great. Then, the resulting solution is divided into 2 equal parts. है ना? 2 equal parts. So, 2 liter is divided equally. 2 liter, if I divide 2 liter equally, what will I have? I will have in one container 1 liter. Other container, I will have 1 liter, right? The question also says 0.02 molar solution. Divide that equally, what will you get? 0.01 molar solution and 0.01 molar solution. Till here everything is clear? Till here everything is clear? Is it clear? Very good, Gayu. Very good. Right? Great. Now, 0.01 molar CONH3 5SO4Br. Which one is the counter ion? You understand these terms. Counter ion is the one that is outside the coordination entity. Bole to this Br is the counter ion. This Br, when it reacts with AgNO3, it is going to give you what? It is going to give you AgBr. But stoichiometry, guys, we are taking 0.01 molar of this. That means I will be getting 0.01 molar of AgBr, correct? Yes or no, guys? Yes or no? Ab batao, yes or no? Batao, yes or no? Come on, come on, come on. I need answers, people. I need answers. Anybody? That is what? Arey, Tanisha. Hey. Virtual pity. Bachu, please look at this carefully. The SO4 is in the coordination sphere. That is not going to dissociate. That is not going to take part in the reaction. Remember, that is why this is the secondary valency. Br is the primary valency. Br will dissociate and react with AgNO3 and form AgBr. Now, in the other half, what are we doing? The other half, you have CONH3, 5Br you have, and SO4 is outside. This SO4 now will react with BaCl2 and you will be getting what? You will be getting BaSO4 precipitate. Yes. Now tell me how much BaSO4 precipitate you will be getting? 0.01 molar only, na? You will be getting 0.01 molar only, na? So this is based on Werner's theory and the correct answer is option B. Is this clear? Is this clear, guys? Is this clear? Yes? Is this clear? I'm trying, Gayu, I'm trying. But I have to also explain this to everybody, right? Yes? Don't worry, we'll be doing a lot of question. And I still have another hour. Namrata ma'am is going to come only at 2:15, 2:30. No, she will only come at around 3:15, 3:10. ठीक है ना? ठीक है? चलो. This is done? Clear? Yes, okay. Now, next question, everybody. Cobalt chloride, when dissolved in water, forms a pink-colored complex X, which has octahedral geometry. Chalo, let's solve this. Let's solve this together, everyone. Cobalt chloride, when dissolved in water, forms pink-colored complex. ठीक है? So we have COCl2, yes, plus let's say that we take 6H2O. If we take 6H2O, we will be getting a complex. What will be the complex? The complex will be COH2O6 here, plus we will be getting 2Cl minus. Right? Now this is octahedral because 6. This is octahedral. Now this solution, when we treat with concentrated HCl, okay? Now what are we doing? We are taking this COH2O6 here and we will treat this with concentrated HCl. When we do this, now what do we get? Now we will be getting COCl, isn't it? We will be getting COCl, and this time it is going to have 4 here, okay? It will be having only 4 here. It forms a deep blue complex Y, which has a geometry Z. So what is the geometry here? This is tetrahedral, right? This will be tetrahedral. Correct? Correct. Everybody? Yes? Yes, everyone. So that means what do we get? We will be getting option A. Option A is the correct answer, isn't it? Option A is the correct answer. Yes. Option A is the correct answer. Have a look, everybody. Have a look and let me know if this is making sense to you all. Is this making sense to you all? Yes, this is the reaction that it will follow. Okay? This is the reaction that it will follow. Chalo. Let us move on to the next question. Which of the following are the examples of double salt? Guys, do you see these are all JEE Mains 2023 questions and all of them are so super easy, everybody, isn't it? All of them are super easy, everybody. So which of these are double salt? We just have to look at which of these have salts in both the sides. So you have this FeSO4 is a salt, FeSO4 is a salt, NH42SO4 is also a salt, and this is water of crystallization. Definitely this is a double salt. Great. Then see, CuSO4 is a salt, but 4NH3, is that a salt? No. And then water of crystallization. So this is not the salt. K2SO4 is a salt, Al2SO4 is also a salt, .24H2O, that's water of crystallization, this is also a salt. FeCN2.4KCN, this is definitely not two salts, hence this is not correct answer. That means option A and C are the only correct answer. Make it sense with everybody? Hashtag EPBT? Yes? Make sense? Nonsense? This is hashtag EPBT, correct? Definitely hashtag EPBT, correct? Great, 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 great. Chalo guys, moving on to the next question then. Which of the following complex will show largest splitting of d orbital? Once again, a very simple, a very easy question, everybody. We can directly see that Cn is one of the strongest field ligand. So Cn, Fe with Cn will show the largest splitting of d orbital because Cn is a strong field ligand. A strong field ligand always exhibits a large splitting, correct? Yes, large splitting. Yes, why Cl4? Because that's the reaction, bacha. That is the reaction, okay? That is the reaction. Yes, that will be the reaction if you're taking concentrated H2S HCl. And the question also says, right, that it is not going to be octahedral geometry, it is going to be Z geometry. So Z geometry, you will be getting tetrahedral geometry here, okay? That is the reaction. The reaction is such. Chalo, moving on guys. Next question. The complex cation which has two isomers is. See, this is homoleptic complex. No, not possible. Look at this NH35Cl. NH35Cl. Will we get any isomers? Not at all. Here see NH35NO2. NO2, my dear students, we know that NO2 is an ambidentate ligand, right? NO2 is an ambidentate ligand, and because this is an ambidentate ligand, we will be getting one where there will be nitrito N and one where we will be getting nitrito O, correct? Yes, everybody? Yes, we will be getting nitrito N, nitrito O. So there is a possibility that nitrito will hold on to the metal with the N side once and it will hold on to the metal with the oxygen side once. Hence, we will be getting two isomers here. So option C is the correct answer. Am I clear? Now, you may ask me that ma'am NH35 bhi to hai. But if NH35 is there, the donor site is only nitrogen here, right? Hydrogen is not going to be donating, right? But in NO2, oxygen is also a donor site, nitrogen is also a donor site, and it becomes an ambidentate ligand. And we know that ambidentate ligands, they act like a monodentate ligand, but they have the tendency that they can switch and try and hold on to the metal with the other side. NO2 and ONO. So we will have one where it will be NO2, one where it will be ONO. Hence, this will show two isomers. Correct? Done and dusted, everybody. Chalo, moving on. The d-electronic configuration of COCl4 minus in tetrahedral crystal field is EMT2N, sum of M and N unpaired number of unpaired electrons. I don't know why am I reading like that. Yes, chalo. The d-electronic configuration. Acha. COCl4. Cobalt has what atomic number? Cobalt has, everybody? What is the atomic number of cobalt, guys? What is the atomic number of cobalt? Everybody, come on. 27? 27, right? I'm writing 27, everyone. Find it out, 27. That means we will have 3d7 and 4s2. Oops, battery is running low now. Hanji. Charging. Yes, 27. So 3d7, 4s2. I believe you all agree with me. 3d7, 4s2. Right? Now, we are saying that COCl4 2 minus. That means cobalt will be in +2 state. Cobalt is going to be in +2 state. Am I right? If it is in +2 state, that means it will be 3d7, everybody. If it is 3d7, that means that what will I have? 3d7, everybody. If it is 3d7, then we will have somewhat like this, isn't it? We will have 1, 2, 3, 4 and 5. So 1, 2, 3, 4, 5, 6, 7. That means that we will have in tetrahedral, right? So we will have 1, 2, 3, 4, 5 and 6, 7. So we will have e to the power, e will be have 1, 2, 3, 4, 5. E5 and T2 we will have 1, 2, 2. Correct? So 5 plus 2, everybody, is equal to 7. 5 plus 2 is equal to 7. but sum of m and n, number of unpaired electrons is number of unpaired electron, sum of m and n. It should be only sum of m plus n, right? 7 is the answer, yes. In tetrahedral crystal field, yes, 7 is the answer. 7 is the answer. Very good. Can we have a break? Why? I've not even taken 1 hour. Why do you need a break? Chalo guys, next question everybody, next question. The number of paramagnetic species from the following is, let's solve this. Okay, this will be fun everybody. Chalo. NiCN4 everybody. We all know what is nickel's atomic number. What is nickel's atomic number? It's Nick's cousin. Nickel is 28. Okay, Ni. Nickel is 28. 28 bole to nickel will be in 3d8 and 4s2. Cn has -1 charge. So 4 to the power -1. 4 multiplied with -1 and 2 minus. That means nickel will be in +2 oxidation state. So 3d8. Righto. Cn is also a very strong field ligand. So 3d8 bole to I have to draw it like this. है ना? 1, 2, 3, 4, 5. So we will have 1, 2, 3, 4, 5, 6, 7, 8. Now Cn is a strong field ligand. This will also get paired up. So what will we have? Then we will have ds and p2. Correct? We will have ds and p2 because Cn4, right? So Cn will attack here, 1, 2. And all of them are paired electrons. So that means that number 1, this is definitely diamagnetic. This is not the correct answer. This is diamagnetic, right? Yes, this is diamagnetic. Chalo. Now we go to NiCO4. Once again, CO4. This will be, Ni is in 0 oxidation state. Ni is in 0 oxidation state. So that means it will be 3d8 4s2. But what will happen is, because CO is a strong field ligand, the 4s electrons, okay, have a look everybody. If you are not getting it, have a look. So this is our 3D, right? 1, 2, 3, 4, 5, right? This is 3D. This is 4s. And this is, let's say, our 4p. Hai na? Okay. Now see, 3d8 4s2. Oxidation number is 0 here. So 1, 2, 3, 4, 5, 6, 7, 8. 4s, there are 2 electrons. Because CO, carbon monoxide, yes, carbonyl is a strong field ligand. This two will get pushed here. Okay? These two will get pushed here. So 4s will be empty. There are 4 carbonyls. Yes, so that means it will take SnP3. The hybridization will be sp3. But this will also be diamagnetic because there are no unpaired electrons. So once again, this will not be correct answer. NiCl4 2-. Nickel will once again be in +2 oxidation state. Nickel will once again be in +2 oxidation state. Hence, we will have once again 3d8, 1, 2, 3, 4, 5. So we will have 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electron. This time Cl is a weak field ligand, bacha. Cl is a weak field ligand. It will not be able to pair up. So since there are 2 unpaired electrons, this will be paramagnetic. Okay, this will be paramagnetic. Similarly, if you do it for FeCN6 4-, you will find that this is diamagnetic. This is not the answer. CuNH3 4 2+. This will be a paramagnetic. FeCN6 3-. 3- will be paramagnetic and FeH2O6 2+. This will definitely be paramagnetic. So the correct answer is 4. Please have a look and tell me if this is the answer that you are finding, everybody. Is this the answer that you are finding, everyone? Yes, guys. Is this the answer? Vaishnavi, 4 is the answer. Diya is saying 4 is the answer. Very good. So you guys have figured it out. Chalo. Next question. Total number of moles of AgCl precipitated on addition of excess of AgNO3 to 1 mole each of the following complex. Okay, let's read the question, everyone. Let's read the question and figure it out. What are they saying? They are saying, everybody, guys, can you see it? Can I get some answers for this? Chalo, see, again, this is also based on Werner's theory, everybody. This is also based on Werner's theory. So, have a look. In the first one, CONH34Cl2, only one Cl is outside. What do you have? You have CONH34Cl2Cl here plus, what are they saying? Whatever, AgNO3, right? We are adding AgNO3. In this case, short, we will be getting only 1 mole of AgCl. Am I right? We will be getting only 1 mole of AgCl, correct? Very good. In the next one, let's see. Next one, what do we have? We have Ni. We have nickel H2O. We will have NiH2O6. Outside, counter ions, 2 Cl are there. If we add here AgNO3, we will be getting 2 mole of AgCl. Correct? We will be getting 2 mole of AgCl. Now everybody, in the next one, there are no Cl ions that are outside. There are no Cl ions which are outside the coordination entity. Everyone, have a look. You have PT, you have NH32, Cl2, plus if I do, Cl2 here, and plus AgNO3 if I do, I will not be getting any mole of AgCl, none whatsoever, because everything is inside the coordination entity. That means this will not be able to give me a precipitate, right? But in the second one, once again, in the last one, we will once again be getting 2 mole of AgCl. Now the question asks, what is the sum total of this? So 2 plus 2 plus 4 plus 1 is equal to 5 mole. We must be getting 5 mole. Exactly 5 mole is what should be the answer. Everybody, are we all getting this? Are we all getting this? B. Gayatri, Nishita Reddy, 5 mole. Rohan is also saying 5 mole. Tanisha, 5 mole. Dia, 5 mole. Very good. Very good. Outstanding, everybody. Yes. So now do you see that almost all the questions that we are solving from JEE Main 2023, everybody, these are all JEE Main 2023 questions. Not even kidding. You can check it out. I will give you the PDF. Just copy the question and check it out on internet. All of these are recent PYQ, and trust me, this is the level of the question that comes. So now I believe that all of you will be able to solve the coordination compounds, questions. What do you all think? Will you all be able to do it? I really believe so. Chalo. Next question, everybody. The sum of bridging carbonyls in WCO6 and Mn2CO10 is, everybody, let's draw the structure. Hai, this is tungsten here. You have 1, 2, 3, 4, 5, 6. So that means here you have CO, here you have CO, here you have CO, CO, and CO. This is this is WCO6. And they are asking you about Mn2CO10. Mn2CO10 will have a structure of what? It will be somewhat like this, Mn, and then here you will have Mn, then CO10, right? CO10. So 1, 1, 1, 2, 3, 1, 1, 1, 2, 3. All of these will be CO. Are there any bridging carbonyls here? Are there any bridging carbonyls here, everybody? Do we have any bridging carbonyl whatsoever? None. None of the carbonyls, none of the ligands are able to bridge anything between, right? What we have is a Mn bridge here. But in the tungsten one, we do not have any bridge. So what is it? The answer will be 0. Answer will be 0. Thank you so much, Rohan. Thank you so much. So you know what? Whenever you guys tell me this, I always tell you that inorganic is my forte. I really like it. I find it interesting because I feel like that this is more like storytelling. Okay, this is more like a storytelling. And you know what? In my life, I have trouble following rules. I can never follow rules. And in organic chemistry, you have a lot of rules. So I don't like that. That is why I'm giving it to someone else who does not like rules as well, which is your Pahul sir. Pahul sir will be taking care of will be taking care of organic chemistry. Both of us do not like following rules, but at least one of us can do that better. So he will be taking care of organic chemistry very soon. You will see him, okay? Chalo guys, moving on to the next question everybody. The next question is the denticity of the ligand present in the Fehling reagent is. Okay, here let me tell you directly that the answer is 4 because I'm going to show you the picture of the ligand. Yes, for the second compound, black ops, I mean, is there anything to remember? Is there anything to remember? Ayo, thank you so much. Thank you so much. There is nothing. There is nothing to remember. All you have to do is put a MN bridge and then 5CO this side, 5CO that side. That's it. Done and dusted. Thak, thak, thak. Bas. Khatam. Physical I will take. I will take care of physical. Don't worry. Physical I will do. That is why the next session we will be doing chemical bonding and the next session we will be doing thermodynamic because these are the high weighted chapters. Hai na? After that we will see. After that you guys tell me what you want and I will take it that way. Okay? After that, whatever you guys tell me, I will take it that way. Chalo guys, moving on. So, what did I tell you? That the denticity of the ligand present in Fehling's reagent, the answer is 4. Now, let me show you the picture. This is the ligand, guys, okay? The ligand has slightly complex structure, but what you have to remember is, everybody, have a look. Here you have an O atom. Here you have an O atom, correct? You have an O atom here. This will be the donor side. This will be the donor side. Yes, then what do you have? This will be the donor side. And the last one right here. Here also you will have a donor side. That means there are 4 donor side. Okay. Yes. What is the meaning of bridging? Chalo, what do you understand? Tell me. What does a bridge means? What does a bridge means? A bridge means something that bridges, right? So Mn and Mn, these are acting like bridges. But is there a Cu that is a CO, a carbonyl? Is there a carbonyl that is bridging anything? Is there any bridge that you can see that is forming? No, that's it. This question is easy. This question is easy. Don't worry about it so much. Guys, clear hai? Clear hai, no? Let's move on. Yes? Let's move on. Let's move on, shall we? Chalo. Okay. Okay. Alright guys, this next question is something that connects 2 things. Very good, yes. If the CFSC of TiH2O6 3 plus is a minus 96.0 kilojoule per mole, this complex will absorb maximum at wavelength dash nanometer. You have to assume Planck's constant is equal to this, speed of light is equal to this, and Avogadro constant is equal to this. Okay, great. Now let's solve this, everybody. Looks like a tough question, but believe me, it is not. Yes? Believe you me, this is also not a tough question. Shall we do it, guys? Everybody, are you all with me? Are you all with me? Why do I not see your answers? Ha, theek hai. Chalo. So they are saying that we have, not with red. Red will not be visible clearly. We'll write it with yellow. Huh? What do we have here? Yes, guys, everybody, are you all with me? Chalo. So we have here TiH2O6 3 plus. This is our compound. We can clearly see that H2O is a neutral ligand. That means Ti is in +3 oxidation state. Acha, now titanium, scandium, then titanium. Titanium has a atomic number 22. Scandium is 21. So 22 means 3d2, 4s2. 3 electrons are gone. That means it will be 3d1. Believe you me? Yes, do you all believe me? Great. Now we know that CFSC formula is, when I was teaching you the lesson I have taught you, CFSC formula is minus 0.4 multiplied with T2 plus 0.6 multiplied with Eg delta octahedral plus NP. Remember, I have told you this. So here, now I can clearly see that if it is 3d1, that means in T2G you will have only 1 electron. In Eg, will there be any electron? None. So minus 0.4 multiplied with 1 will be 0.4. So we will have minus 0.4 multiplied with delta octahedral. You are also given that the CFSC delta octahedral, Yes, this CFSE right here is equal to minus 96.0 kilojoule. If it is kilojoule, but choose, if it is kilojoule, then can I write it as minus 96 multiplied with 10 to the power 3 joule, and that is equal to minus 0.4 multiplied with delta octahedral. Now what do I have to do? I have to calculate delta octahedral. So delta octahedral is equal to, everybody have a look guys, have a look. Now what am I going to do? See here, I have to say this is in minus 0.4, so I'll definitely have to use the Avogadro constant somewhere, right? I will have to use the Avogadro constant somewhere, everybody. Will I have to do it or not? I will have to. So that means what will I be getting? I will be getting minus 96 into 10 to the power 3 divided by minus 0.4 multiplied with 6 into 10 to the power 23. That is my delta octahedral. Yes, but I also know that, not I, everybody, we all know that energy E is equal to hc by lambda. You will be thinking that, oh, this has come, then it will be very tough. No, just equate this. Yes, everybody, just equate this with this. This value that you have, right here, equate this formula, okay? From here, you will have to calculate lambda. So now calculate lambda, and H value is given to you 6.4 into 10 to the power minus 34. C value is given to you 3.0 into 10 to the power 8. Put up these values, and what will you be getting? Then if you calculate, I think you will be able to get it somewhere around 480 nanometer. Now calculate this and tell me, everybody. Now calculate this and tell me. Yes, calculate and then tell me the answer. It should be 480 nanometer, but calculate and tell me. Just put the values of H and C and calculate, everybody. Rishi, Pahul sir will be taking that session, bacha, very soon. Yes, Pahul sir will be taking the session, bacha. Pahul sir very soon will be taking that session. Huh? Don't worry. Don't worry. Guys, is this clear? Is this clear? Just try, no? Just try calculating once. I think you will get that answer. Just try and calculate this once. I think you will get the same answer exactly, everybody. You should be getting 480 nanometer, I believe, because that is supposed to be the answer. See, 480 is the answer. Are you all here with me? People not able to see your answers, guys. What do you think? Are you getting this? Are you getting this? Lambda is equal to, basically it will be HC. Done? Done? Yes, you are getting it. So V is saying that it is done, and who is saying? Janu is also saying. Nagasai, did you calculate it? Yes, 480. Rishi, Nishita. Okay. Then let's move on. Next question. The spin-only magnetic moment of MnH2O62 plus complex is. This is a question in JEE Mains, guys. What is your confidence level now? Tell me. Confidence level is absolutely God level now. Yeah. I believe that you all will be able to completely do your coordination compounds and D and F block elements. Please, no ounce of doubt should be there in coordination complex. My favorite chapter, guys. You must be able to do it. Okay. The spin only magnetic moment of MnH2O62 plus complex is. Let's figure it out. Mn. Dekho. See, manganese has an atomic number 25. 25 bole to it is 3d5 4s2, right? Now what happens is H2O is a neutral ligand, does not have any charge. So clearly manganese is in +2 oxidation state. If it is in +2 oxidation state, these two will go away. That means 3d5. If it is 3d5, that means 5 unpaired electrons. If it is 5 unpaired electrons, then the Bohr magneton will be equal to 5.84, 5.82. 5.84 can be rounded off to 6. So the answer is 6 Bohr magneton, nearest integer. Nearest integer is 6. Am I correct? Am I correct, everybody? Yes or no, guys? Am I correct? Yes? Approximately 6. Yes. Okay, very good, very good. Looks like many students have just had their dinner, just had their lunch, and now they are back, huh? Hey, but Badmash bachchus you are, huh? Sachi mein. That's why Shreyas sir calls you Pandu, huh? No, not 6 unpaired electron. Rudra, no. Rudra, you are making a mistake here. There are 5 unpaired electron. Thank you, Rishi. 5 unpaired electron. 5 unpaired electron. Bole to Bohr magneton. Magnetic moment will be equal to 5 point something. Now, 5 point something can be rounded off to 6. Hence, 6 Bohr magneton is the magnetic moment. Understood? Yes. Good. Chalo, moving on. Transition metal complex with highest value of crystal field splitting will be. Okay, everybody, here you might think that, ma'am, this looks very, very tough. How do we do this? First of all, look at all the metals. What are the central metal atoms that you have? You have chromium, you have molybdenum, you have iron, and you have osmium, right? Yes, everybody. Now we know generally we know that the CFSE of octahedral complexes, when you have a 5D element, osmium is a 5D transition element. It's a 5D series element. Okay, osmium is a 5D series element. So everybody, the 5D series element, they have a greater splitting of CFSE than the 3D. Am I making sense? Yeah. Am I making sense? Let me write that down. Chalo, let me write that down. What did I say? No, I'm not able to write it down. Sorry, I can't write it down. Changing my mind. I'm changing my mind, okay? Yes? Shreyas sir is also here, guys. Shreyas sir is also here. Yes, what happened? Why you guys are not liking the session? Go ahead, like it. Hi, Shreyas sir. See, Shreyas sir, I've taken your name. Next time you return the favor, you take my name in the session. Hai okay. What did I say, everybody? The CFSE of 5D series. CFSE 5D series is greater than 4D and 3D. Okay. Now, what do we know? We can see that these chromium, iron are definitely 3D. Where does molybdenum fall, everyone? Molybdenum falls in the 4D series, and osmium is a 5D series. Hence, you will have a greater CFSE with osmium. Clear? What is the reason for that? That is the reason. The reason is that CFSE of 5D series is more. Yeah, 5D series is more. The reason is that. That is the reason. Okay? Chalo guys, moving on. Next question. Again, match the following, everybody. Match the list. Okay. PtCl4 2-. Now we do not have a compound with 3D series. See, mostly you will definitely have a 3D series metals. But there are chances that they might give you a platinum or a palladium component. So make sure that you learn. In the session, I have told you the exceptional elements which have, the exceptional elements that have their different kind of a electronic configuration. What was it? Do you all remember? What was it? Copper, gold, silver, platinum, corrupt, new bureaucrats, rupee, money taking, rupee, rhyming, pandi. Do you remember? I had told you this, right? But platinum does not fall there. Hai na? Platinum does not fall there. So platinum, what is the electronic configuration, everyone? What is the electronic configuration of platinum, guys? Anybody who can tell me? Platinum has a electronic configuration. I'm looking at the chat box. Somebody can tell me? I know. Let's see. Someone told me 6s04d10. Hey, nah. No, it's 5d86s2. It is 5d86s2. Clearly, platinum is in a +2 oxidation state, right? Because Cl4 and 2-. That means it will be 5d8. And by the way, right here, what happens is Cl acts like a strong field again. Achha, this is also a rule, huh? This is also a rule. With a 4D series element, there is no weak field ligand. Cl will also act like a strong field ligand, by the way. This is a rule, okay? So what will Cl do? Cl will also try to pair it up, and then it will take up, DsP2 hybridization, okay? This will take up DsP2 hybridization, all right? Now do it for CONH36. Once you do it for CONH36, I think it will be clearer for you. For CONH36, if you do, you will be having CO. Cobalt will be in 3d6. If it is in 3d6, then what will happen? If it is in 3d6, that means that you will have D2sp3 hybridization. Correct? Yes. Now let's do it for PCl5. In PCl5, what happens? In PCl5, remember in P block elements, we have studied this. In PCl5, what do you have is, everybody, no answers I'm seeing, huh? No answers I'm seeing. PCl5, it will take sp3 dehybridization, because in this case, what happens is, they get in the excited state, P, phosphorus, in the excited state, in each and every orbital will have 1, 1, 1, 1, 1, 1 electron. Cl will donate 1, 1, 1, 1, 1, 1 electron, and then it forms the bond. Remember, this is not a coordination compound here. PCl5 is a compound. It's just a compound. It's not a coordination complex, right, everybody? Do you remember this, everyone? Is it making sense or nonsense, everyone? Is it making sense or nonsense, guys? Yes? Is it making sense or nonsense? Yes? Very good. Very, very, very good. Yes, well done, everybody. So that means PCl5 will have sp3d, right? It will have sp3d. Very good. Very good. Yes, well done, guys. Well done. So that means what is the answer? People are saying option B. Option B is the answer. A will be 3, B is 4, C is 1. Yeah. C is 1, no? PCl5 is sp3d. It's option A, no? No. A is 3. A is 3. Yeah. Option B. Option B. Option B is the correct answer. Yes. Option B is the correct answer. Very good. Very good. Chalo. Moving on, guys. Next question. White precipitate of AgCl dissolves in aqueous ammonia solution due to the formation of, what do you think? What do you think, everyone? Due to the formation of, yes, white precipitate of AgCl dissolves in aqueous ammonia due to the formation of anybody. Hi, Manisha. Hi, Ganesh. Hello. Very good afternoon, guys. Very good afternoon. It will form AgNH3Cl. AgNH3 that means this. Option C is the correct answer. Okay, have a look. AgCl plus ammonia, right? NH3. So what will you get? You will be getting a complex which is like this, AgNH3 and here you will have Cl. So option C is the correct answer. Make it sense? Not B. Option C, bacha. Option C. It is option C, bacha. Yes, Rudra, very good. Option C is the correct answer. Now, guys, look at this. Arrange the following coordination compounds in the increasing order of magnetic moment. Shall we do this? Yes, Ganesh, what's your doubt? What's your doubt, bacha? Sanjay, you said C. You are right. Okay. Alright, let's do this, everybody. Arrange the following coordination compounds in the increasing order of magnetic moments. Yes, in the increasing order of magnetic moment. Chalo. Let's do this. Clearly, FeF63 minus, because it will have. Okay, guys, let's solve this. Yeah, this is supposedly very easy. Fe has what? Atomic number of 26, है ना? Fe has atomic number 26. If it is 26, that means it is 3d6 4s2. Now 6 minus 3, it will definitely be in, Fe will be in plus 3 oxidation state. In plus 3 oxidation state, what will happen? 2 from here, 1 from here. 3D, 5 it will be. If it is 5, F is a weak field ligand. If F is a weak field ligand, that means there will be 5 unpaired electron, no pairing will happen. That means this will have a magnetic moment equal to 5.84 or some sort of like that. Correct? Yes? Very good. Okay, which chapter? Very good question. Very good option. Very good question. Ganesh is asking which chapter. Somebody please tell him which chapter. Then, right here, Cn is a strong field ligand. Okay, Cn is a strong field ligand, but we have 3D5. So, even if it tries to pair it up, 1, 2, 3 and 4 and 5, right? So, we will have 1, 2, 3, 4 and 5. So, what will Cn do? Even if it pairs up, we will still have D2sp3 hybridization and we still have one unpaired electron. So, what will happen? We will have 1 point something something will be the magnetic moment. MnCl6 minus everybody, that means Mn is in C, 6 minus 3, that means Mn is in plus 3 oxidation state. In plus 3 oxidation state, Mn will have 3D4, isn't it? If it is 3D4, then what will happen? That means there are 4 unpaired electron. 4 unpaired electron bole to 4 point something something. MnCn6 minus Mn plus 3, that means 3D4. Even if it is 3D4, there will be, we can draw it like this, isn't it? 1, 2, 3, 4 and 5. So we will have 1, 2, 3 and 4. Even if there is pairing up happens, even then we will have 2 unpaired electrons, right? So this will be 2 point something something. Now what is the answer? Now what is the answer, everybody? A is the highest, then it is A, C, D, B. A, C, D, B. A, C, D, B. Where do we have A, C, D, B? A, C, D, B. Option B is the correct answer, right? Option B is the correct answer. Am I right, everybody? Yes, guys? Very good. Very good. Option B is the, yes, Beluga, it is option B. Yes, Rishi, option B. Nagasai, very good. Yes. Yes. Option B is the correct answer. Chalo, moving on. Which of the following will have a maximum stabilization due to crystal field? Anybody? Okay, now we have reached JEE Main 2022. Now we have reached JEE Mains 2022, everybody. So chalo, let's solve this, everyone. What is the answer going to be? What is the answer going to be? Okay, first of all, have a look. We know that a strong field ligand tries to bring a stabilization effect. So if we have a strong field ligand plus we have a cobalt in plus 3 oxidation state, so we can clearly see that cobalt in plus 3 oxidation state will also have a greater effective nuclear charge, isn't it? Yes, everybody. Look here. Right here, everyone, have a look. Cobalt in plus 3 oxidation state will have greater effective nuclear charge. Greater effective nuclear charge. Greater effective nuclear charge. Plus, you have what? You have strong field ligand. So, I'm just writing it as SFL. SFL is strong field ligand. So, here you will see that maximum stabilization occurs. Okay? Alright, everybody? Yes, this is clear, guys. Now, do we know the answer? Now, do we understand the reason? Do we understand the reason, guys? Yes, we do. Chalo, next question, everyone. Okay. For this, what you have to do is NiCN4 2 minus a square planar and diamagnetic complex with dsp2 hybridization for Ni. But NiCO4 is tetrahedral paramagnetic with sp3 hybridization. Ni is in Ni right here will be in 0 oxidation state. If it is 0 oxidation state, that means 3D8 4s2. If it is 3D8 4s2, then what will happen is the 4s electrons will be pushed here. The 4s electron will be pushed to 3d8, right? And then you will have sp3 hybridization. That is true. That is true. But is NiCO4 going to be paramagnetic or diamagnetic? Guys, any answer? Guys, any answer? In the second statement, they are saying that NiCl4 2 minus and NiCO4 both have a same d electron configuration, have the same geometry and are paramagnetic. Yes, guys. Yes, guys. Tell me what is the answer. Come on, just read the statements, everybody. I'll move away from the board. Try and attempt this. I believe that you will be able to do it. Yes, I believe that you will be able to do it, guys. Yes? Tell me. We will have NiCN4 that is diamagnetic. Of course, NiCN4 is definitely going to be diamagnetic. NiCO4 is also going to be diamagnetic because this is also strong field ligand, right? In NiCO4, we will have what hybridization? We will have sp3 hybridization, absolutely. dsp2 hybridization in NiCN4, that is also correct, absolutely. NiCl4 is the only thing that is going to be paramagnetic. So what is going to be our answer? That means that what is going to be our answer, everybody? Our answer is both statement 1 and statement 2 are false, right? Option B is the correct answer. Option B, na? No. Now, option B has to be the correct answer because see, it says that NiCO4 is tetrahedral paramagnetic. NiCO4 cannot be paramagnetic. NiCO4 is diamagnetic. Right, guys? No, it has to be option B. Option C is wrong. Statement 1 is also incorrect. Statement 2 is also incorrect. Statement 2 is also incorrect. Statement 1 is also incorrect, right? Option B is the correct answer. Yes. Remember this, yeah? Option B is the correct answer. Okay. Chalo, let me just tell you. What did I write here? What did I tell you, everybody? What did I tell you, guys? Yes. What are you answering? You guys are saying that it is wrong. Chalo, let me show you once again. Everybody, have a look, guys. Have a look. I said, what did I tell you? I have told you Ni, hai na? NiCN4 2 minus. Calculate this and find it out. NiCN4 minus will have what? D8 configuration. Correct? It will have D8 configuration. Why so? Here 4, here 2 minus. Ni will be in +2 oxidation state. In +2 oxidation state, it will have 3D8. I can clearly see that Cn is a strong field ligand. If it is strong field ligand, pairing up will happen. If it is pairing up, then what will happen? dsp2 hybridization. With dsp2 hybridization, I am definitely going to get a diamagnetic compound. Next, what do we have? Next, we have NiCO4, right? In this case, we will have a D10 configuration because 4s will be pushed to the D8. So 4s plus 2, that plus 2 comes to D8. It will have D10 configuration. Again, strong field ligand, everybody. If it is strong field ligand, we get sp3 hybridization. And this also, my dear students, is a diamagnetic. Now, next one, everybody, is your NiC. One second here. Can somebody point out what mistake I made? The mistake was that I have introduced a bracket here. I should not be introducing bracket with NiCl4. Why? Because Cl is just one atom. If we have multiple atoms only, then we introduce a parenthesis. So NiCl4 here was a compound NiCl4 2 minus, right? NiCl4 2 minus will have D8 configuration. Yes. But if it is D8, we will still have, we have here weak field ligand. We have weak field ligand. Weak field ligand, but so that means there will be no pairing up. If no pairing up happens, that means all the d orbitals are taken care of. That means this will have sp3 hybridization, but this is paramagnetic. So clearly NiCl4 2 minus is paramagnetic. This is not paramagnetic. That means that option B is the only correct answer. Clear hai? Clear hai? Hey, who is writing sp5? There is nothing as sp5, guys. There is nothing as sp5. Voice ही नहीं आ रहा है. Yes, Rudranath. Very good. Yes. So option B is the correct answer. Got it? Clear? Chalo. Next. Now we have here everybody in CuSO4.5H2O. CuO bonds are present. In CuSO4.5H2O, ligands coordinating with Cu2 ions are O and S based ligands. No. CuSO4.5H2O. No. Here the donor site is only oxygen, guys, not sulfur at all. Not sulfur at all. Okay. So I believe that it will be statement 1 is correct, but statement 2 is incorrect. What do you all say? I think it is option C. Yes, it is option C, everyone. Statement 1 is correct, statement 2 is incorrect. Why? Because here the donor site is only oxygen and not sulfur. In case of SO4, donor site is only S. Okay? Alright? Clear? Clear hai na bachchos? Okay. Chalo. Next question, everybody. The correct order of energy absorption of the following metal complexes is. This is so very easy, everyone. Obviously, this will have the highest, right? This will have the highest energy absorption. Then it will be option B and then it will be option C. So it will be A, B, C. Option A is the correct answer. Look at this. This is the level of question that you are getting in JEE Mains from these two chapters. Don't you think that you will be able to do? I believe that, I think in these two chapters, we must be getting 90 percentile, right? At least 90 percentile we should be getting, right? Nothing less than this will work, okay? I need you all to come back and tell me that, yes, ma'am, whatever questions came from coordination and DNF block, we aced it. Will you all do this? I'll wait for you all, okay? I'll wait for you all. Chalo, guys, moving on to the next question, everyone. The metal complex that is diamagnetic here is. Which one of them is diamagnetic? Chalo, let's solve it, everybody. Yes, let's solve it, guys. Come on. What do we know? Copper has 29, right? If it is 29, then that means that this is a exception. What exception? We get 3D10-4S1. Now, if this is a K3 bachus, that means that here it will have a 3 minus. Cn has a 4. So 4 minus 3, what will you get? You will be getting copper is in, Cu is in +1 oxidation state. Hence, we will have 3D10. Does this look like this is diamagnetic? What do you all think? Is this diamagnetic, guys? What do you all think? This is diamagnetic. Yes, this is diamagnetic. 3D10 all paired up. So option A is our correct answer. So very lucky that option A was the correct answer. Otherwise, we will have to do it for each one of them and then figure out the correct answer. Option A, right? Option A is the correct answer. Chalo, moving on, guys. Hai na? Low oxidation state of metals in their complexes are common when ligands have a good pi accepting character. Option A is the correct answer. If you remember, do you remember this, guys? Do you remember? I had taught you, yes? Back bonding, synergic bonding, pi accepting acids. I have taught you this. I've taught you this. Do you remember? Yes? Now what happens? When the metal and the ligand are there, now the ligand has, do you guys remember, everybody? How many of you remember this? How many of you remember this? I've taught you. So let's say that you have a metal here, right? And let's say that you have a ligand. You have a ligand of AB type. Yes. Here there is a sigma bond and a pi bond. Correct. Now what will happen is, let's say that this is the ligand. The ligand has here 2 electrons. The ligand will give it to the metal's empty shell here. It will form a sigma bond first. Now what happens is, most of the ligand, they also have empty p orbitals, isn't it? They have, yes, they have, let's say here, orbitals, p orbitals. Yes. Do you also remember what happens here? Yes. If there is a p orbital, that means that there is an anti-bonding p orbital. Guys, molecular orbital theory that we have studied in chemical bonding, everybody. Do you remember what happened? 1s, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Then what do you have? You have what? Pi 2x, pi 2px, pi 2py. Then you have pi star 2px, pi star 2py. Do you remember? Do you remember? Yes? Very good. So here there will be empty anti-bonding orbital. In this case, this will come back here. There will be a back bonding that is happening, and the ligand acts like a pi acceptor. When the ligand accepts the pi, or what am I saying? The ligand is behaving like a pi acceptor, right? It just accepted some electrons and it formed a pi bond along with the sigma bond. The sigma bond is obviously there. The sigma bond is there. But with the sigma bond, it is also forming a pi bond. And when it does, then now what will happen? The metal will have a low oxidation state now. The metal will obviously have a low oxidation state. Oxidation state cannot increase. The metal will have a low oxidation state. That is exactly what this question is asking. Make sense, nonsense, everyone? Yes, Gayu, do you remember? Anti-bonding. Yes, anti-bonding. So here this is called as back bonding, synergic bonding. So whenever you have a ligand which acts like a good accepting character, which acts like a good pi accepting character, then we have a low oxidation state of the metal. Chalo, moving on, guys. Okay, let's do this. Another match list 1 with list 2. Should we even be doing this, or are you guys acing this? Absolutely. We can move on to the next question, everybody. Should we even do this, or can I give this to you as a homework, everybody? Can I give this to you as a homework? I believe that you will all be able to do it. The answer is anyway written. The answer is anyway there. Yes, guys, what do you think? Yes or no, everyone? Tell me. This is clear. Shall I give it to you as a homework? I think I can give it to you as a homework. There are a lot of questions, by the way. I'll be sending the PDF in the Telegram channel. Do join the Telegram channel. This will be a good practice. Homework? Yes. Let me give this to you as a homework because this is very easy, very simple. I think that you will all be able to do it. Chalo. Moving on to the next question, everyone. Okay. Octahedral complexes of copper 2 undergo structural distortion. John Teller distortion. Yes, we have studied about this in coordination compound. John Teller distortion. Chalo, I'll tell you, don't worry. Which one of the given copper 2 complexes will show the maximum structural distortion? See, guys, when do you actually have a John Teller distortion? Acha, how many of you know who is John Teller? Have you guys watched the movie Oppenheimer? How many of you have watched the movie Oppenheimer, guys? Let's see. How many of you have watched the movie Oppenheimer? Let's see. Gayu, Beluga, Deepak, anybody who has watched the movie Oppenheimer? In Oppenheimer, with OP, yes, with OP, right? You also have somebody else who was there. In that whole group, John Teller was also there, okay? John Teller was also there. Now, John Teller, what he did was, he was responsible for an effect when he said that if he said that, guys, are you listening to me? He said that in a complex, if the metal ion has an unsymmetrical Eg or T2G, for example, let's say that you have T2G 6, you have Eg3. Now, is 3 symmetric? Do you think that the number 3 is an odd number? Is it symmetrical? It will possess unsymmetry. That time it will show a distortion. That time it will show a distortion, and that distortion was studied by John Teller. That's why we call it as John Teller distortion. Okay, what do we call it? We call it as John Teller distortion. Now, whatever example I have given it to you, right, I am giving you the perfect example. Everybody have a look at CuH2O6SO4. In case of CuH2O6SO4, you will see that CuH2O right here, this whole compound will possess exactly this configuration. Because it possesses this configuration, we see that in the Eg, in this Eg, there is unsymmetry. Okay, there is unsymmetry. Hence, this will go through John Teller distortion. Any doubt here, everybody? Any doubt here? Any doubt here, guys? Any doubt here? Or do you all know this? Everybody knows what is this John Teller distortion or not, guys? I can see your answers, but tell me what is John. Do you guys understand what is John Teller distortion? What he said? If there is any unsymmetry in the d orbital, then there will be a slight distortion, and that is exactly what is happening here. Eg has there are 3 electrons present in Eg, which is unsymmetrical. That's why this will show you John Teller distortion. Guys, are we clear? Very good, very good, very good. Chalo. All right, everybody. Moving on to the next question then. Yes. In the cobalt carbonyl complex, CO2, CO8, number of CO-CO bond is X and terminal ligand CO is. Okay. Looks like a confusing one, but it is not. Okay. It is not. Chalo. There are CO2, CO8. So you have, basically the structure is going to look like you have cobalt here. You have cobalt here. Now what happens is you have 1, 2, 3, 1, 2, 3. You have one, this is CO here, CO, this, and then these are all the carbonyl ligands, okay? These are all carbonyl ligands here. And this is, okay, once again, everybody, please have a look, guys. Understand that. Don't get confused, everybody. Don't get confused. These two are cobalt metal. These two are cobalt metal. The rest, all of them are ligands. Okay, the rest, all of them are ligands here. So what do we understand? What do we understand? We understand that the number of CO-CO bond. How many number of CO-CO bond is there? Cobalt-cobalt bond, guys. How many number of cobalt-cobalt bond is there? 1. That is equal to your X. Terminal ligands. Okay, terminal C capital O capital ligand. How many are there? You have 1, 2, 3, 4, 5, 6. You have 6 terminal ligands, right? 6 terminal ligands. So 6 plus 1 is equal to 7. Am I right? Very good. 7 is the correct answer. Yes, 7 is the correct answer. Chalo. Okay, next question, everyone. Next question. Okay. If CuH2O4 2 plus absorbs a light of wavelength 600 nanometer for DD transition, when the value of octahedral crystal field splitting energy for CuH2O6 2 plus will be dash into 10 to the power minus 21 joules. Okay, you know what? Let's do one thing. Let's do one thing. Let's do one thing. This I'm going to give it to you as a homework, but today in the evening at 7 p.m. I will be releasing the answer in the Telegram channel. I will give you a handwritten Telegram channel. I'll give you the answer there. Plus, I will also post it in the community post. Okay, this question I'll be giving you in the community post, everybody. So try and solve it. I just want you all to try and solve it. If you can, it is very good. If you cannot, it's okay. I will give you the answer. Today at 7 p.m. I will give you this answer, or tomorrow 7 p.m. I think tomorrow 7 p.m. I'll give you one day. I'll give you one day. You try to solve it. Okay? Try and solve it. Try and solve it. Try and solve it. If you cannot, no worries. We will do it. Yes? No worries. We will do it. But otherwise, try and solve it. Either today 7 p.m. or tomorrow 7 p.m. I'll release the answer in the Telegram channel as well as in the community post. Have a look there. This is a slightly tough question. If you can solve it, very good. If you cannot, no worries. You will get the answer. But have a look at this question. Okay? Alright? Yes? Chalo guys. Moving on. Moving on. Shall we do more or shall we call Namrata ma'am? Everybody. Shall we call Namrata ma'am? Because I have a lot of questions. Like I have some 150 slides here. I have a lot of questions. What do you want me to do? Shall I continue or should we try calling Namrata ma'am? Let's see if Namrata ma'am is free now. Yeah? What do you guys think? Shall we call Namrata ma'am? Hi Shakti, thank you so much, bacha. Thank you so much. Chalo, let's call Namrata ma'am and see if she's available now. Let's ask her. हेलो मैम. हाँ मैम, आप फ्री हो? नहीं, मैंने खत्म नहीं किया. शैल आई एंड इट? आर यू लाइक इन द स्टूडियो? ठीक है, तो आई एम एंडिंग इट. यू कैन स्टार्ट इट. ठीक है. ओके ओके मैम, बाय बाय. All right, guys, this is the end of our chemistry session. I believe that we have done a lot of question, and Namrata ma'am is also there. ठीक है. 3 years, yeah, ZZ. I think it should be available. ठीक है. So Namrata ma'am is going to be here, everybody, and believe me that you must go and join our Telegram channel, everybody. If you join our Telegram channel, you know you will be getting the PDF. There will be a lot of question in the PDF, so please do join it. We will see you there. And now Namrata ma'am is going to come, everybody. So yeah, I shall see you all very very soon. No, I will sending it to you. You can do it, okay? You can do it. Chalo guys, bye bye. Do not forget to join the Telegram channel. There will be DPPs. Try and solve it. It will be good for you, okay? Bye bye. See you all. See you all. Have a nice class, everybody. Have a nice class. Bye bye. See you all. Bye.
Hey my ninja warriors, how are you all? Before I start any further, do let me know whether I'm perfectly audible and visible to you guys. Alright, all set. Shreyas sir class done, Nabamita ma'am class done. Now is the time. Class from Ninja ma'am, okay? Alright. In the chat box, please let me know whether I'm perfectly audible and visible to you guys so that we can further proceed today's session. Alright. Let me just check. Okay. Alright, so I've got the green signal. I guess I'm perfectly audible and visible. So you all know that we are going to solve the previous year questions from the topic limits, continuity and differentiability. Okay. But along with that, I want to give you some additional advantage over here. So okay. Yes. So apart from that, I wanted to talk to you about something. Do you guys know that how much score you need to gain in your mathematics, JEE mathematics exam to get exactly 99 percentile? Do you know how much score you need to score in mathematics so that you score 99 percentile? Anyone in the chat box? What score should lead you to the 99 percentile or more in mathematics only? I am talking about only mathematics. Yes, in the chat box. So let me just tell you. Okay. Gotram is saying 60 marks. 60 marks. Okay. So very close. Approximately 55, around 55 marks if you score, then you will score yes in mathematics. So that means you need to just score you need to attempt only 50% of the paper, only 50% of the paper, slightly more than 50% of the paper, and you are done. So just let me know, out of 25 questions, how many questions you should attempt correctly so that you get this perfect 55 score. For example, if you attempt 12 questions correctly, you will get 48 marks. You all know that. Only 12 questions, 48 marks, right? And if you attempt 13 questions correctly, then 52 marks. Very close to 99 percentile, right? So that means your target is to attempt 14 questions, at least 14 questions correctly, so you will surpass the 99 percentile score. Okay, so yes, now just tell me one thing, that how do you aim? How many questions do you aim? Is it 12? Is it 13? Is it 14? Is it 15? So I guess approximately 11 to 14, 15 should be your target, and more than that it would be obviously beneficial. Minimum 11 questions should be correct, right? So out of 25, attempting 11 correct question, is that a big thing I am asking from you? Just tell me in the chat box. Is that a very big thing I am asking from you? Not at all, right? But then there is a little catch in mathematics paper. What happens is, there are some questions which are very easy, right? There are like 7 to 8 questions they ask out of 25. Let me just tell you, out of 25, 7 to 8 questions are very easy questions, right? It's just that we just need to identify those questions. Why we fail, where we fail is to identify this question. We come home and we say, oh, this question was so easy, but I left this question. Why? Because you were not able to identify that easy question. You left that easy question, right? You left that easy question and you went to the moderate or difficult level, lengthier question. You wasted your time, and there was one question which was present on the paper which was easy, that you could have cracked very easily, right? It happens with all of us, right? So 7 to 8 easy questions, and then there are like 6 to 7 moderate level questions. Minimum, I am talking about minimum 6 to 8 moderate level questions are present. You can target that 6 to 7 and the next pass. So I am going to share a strategy to attempt the question, and that strategy we are going to apply in the today's session as well. I'm going to share a strategy. So whenever you see a paper, whenever you see a question paper, for example mathematics, what do? The moment you see question paper, just give 15-20 seconds to scan it. 15-20 seconds to scan it. So question number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or all the way up to 25, because 30 questions are there, all the way up to 30. So what you need to do is, this is my alpha, beta, gamma strategy which I am going to share with you, which we are going to apply in today's session, alpha, beta, gamma strategy. So what you need to do is, you just need to start scanning the paper, and out of those 25 questions, you need to identify alpha question. These alpha questions are those questions which looks easy, and you see it and you gain that confidence. Okay ma'am, now this question I'll be able to do, so that you can't you don't miss out on easy questions. So identify at least 7 to 8 questions which are doable questions in the first pass, in the first scan, in the very first scan, in the first 10 seconds. You need to quickly identify those questions which are alpha questions, mark it as alpha, okay? And then rescan that paper in another 10 seconds, rescan it. These will be beta question, that would be moderate, mark it as beta questions, okay? That's it. And the third category would be gamma questions. You know that I have not read that chapter, or by looking at the question only you get scared. No, this question is not my cup of tea. You are not going to attempt that question until you finish your alpha and beta question. Only you will focus only on alpha and beta question. by doing this strategy, this is a topper strategy, by the way. The students have shared the strategy with me who have topped the JEE Main exam, not even JEE Main, in fact various competitive exams, for example CAT, GRE, GMAT, all the exams. So this is the best strategy where you don't miss out on any easy question. Missing out on any easy question will obviously obviously decrease your mark, reduce your marks, right? Okay, so alpha, beta, gamma strategy, easy, moderate, easy. So in first 15 minutes you will be able to solve these 7-8 questions, so that in first 15 minutes you will gain that confidence, and once you are in that confidence now, you will automatically score very good in the overall examination. Do you agree or not? So let's just start solving the questions, the PYQ questions now, and let's just give it a thought after solving the question. Let's not just move to the next question. Let's just give it a thought that, okay, was this an alpha question? Was this a beta question? Was this that type of question which I was not able to do it in the examination? Give it a 5-second thought that what will happen if this kind of question will come in actual JEE Main. Will I be able to do it or not? Okay, this thought will definitely help you to identify those questions alpha, beta, gamma. Shall we start? Yes. Okay, the very first question JEE Main 2023. The very first question, JEE Main from JEE Main 2023. Alright, what is the question? Limit of the expression, this very expression, okay, power is sine square t, there is some formatting error, please ignore that, where t tends to 0. Asked in JEE Main 2023, this current year. Okay, let's just start attempting it. So I have already taught you yesterday, the moment you see any limits question, what do you first do? Will you start solving this question? No, you will check the form of the question first, form of the expression first. Okay, let's just start actually checking the form. So I can clearly see the moment I plug in t0, I will get 1 raised to power infinity, 2 raised to power infinity, 3 raised to power infinity, n raised to power infinity, and okay, so this is going towards infinity, and the sine square t, so infinity raised to power 0 is the form. Okay, alright, infinity raised to power 0 is the form. So here what we need to do is we need to do some manipulation in this question. We need to do some manipulation. We need to take something common from this so that the form will get manipulated or updated. I'll show you how we are going to do that. Okay, so yes, alright. So I can clearly see this n raised to power 1 upon sine square t. Can I take this common? Can I take n raised to power 1 by sine square t? Can I take this out? If I take this out, let us see what will happen. Okay, so the moment I take this out, it will become n 1 raised to power sine square t. Okay, if we are taking common, clearly see that sine square t is also there. Okay, let me change the color. So sine square t will be here. Okay, sine square t will be here. Alright, bracket. Now 1 raised to power 1 by sine square t, 1 raised to power 1 by sine square t. We have taken n raised to power 1 by sine square t common, so it will get divided. The first term will be 1 upon n raised to power 1 by sine square t. Clear or not? The process is clear or not? What I have done, I have taken this particular term common out from this bracket which is written over here along with the power sine square t. Done. Now this particular thing does not have this common term, so we just need to divide it. 1 by n sine 1 upon sine square t. What would be the second term? Tell me. 2 by n raised to power 1 upon sine square t. What would be the third term? 3 by n 1 by sine square t. Correct? And what would be the last term? N upon n 1 by sine square t. Please don't forget this. power sine square t. Only this step. Only this step. Only this step is difficult, or you can say tricky. Now the question has become super duper easy because sine square t will get cancelled out. So we are left with what? N times, now tell me. Here t tends to 0, limit t tends to 0. The moment you put t tend to 0, 1 by 0 will become infinity. So 1 by n raised to power infinity will be what? Tending towards 0, right? So this will be gone. 0. Again, similarly, this will also be gone. 0, because obviously, if I compare 1 and n, which one is bigger? Obviously, n is bigger. So this is a fraction. Fraction raised to power infinity is 0. Fraction raised to power infinity is 0. Fraction raised to power infinity is 0. Every term is becoming 0 except the last term. N will get cancelled out. This is becoming exact 1. Exact 1 raised to power infinity is 1. So inside the bracket I can clearly see this is becoming 1, right? And 1 raised to power what? 0 is 1 only. So this is 1 and this is coming out as n. N is the correct answer. I know there are some students who will have some doubts. Please ask your doubts. Shoot your doubts. I am here. I'll be taking care of the doubts. All right. Okay, Soni Tomar is asking, ma'am, where is physics session? Today's physics session, are you talking about today's physics session? So it's in the same session. This is the one and only session. So once I end the stream, then you will see Shreya sir session, then Abamita ma'am session, and last one is the my session. Okay? Alright. Okay. Let me just clear one more time. Let me just tell you one more time. What I did is, I just took this particular term common. Okay? I took this particular term common. Okay? Let me just take it common. So the moment I take n raised to power 1 by sine square t. Okay? So the first term will become what? Tell me one thing. Okay. 1 plus x. If I take x common out of this, if I take x common, then what will happen? If I take x common, it will become 1 by x plus 1. That means what we are doing is, if it is not having any x, we need to divide it by that x. Right? That's how we take common. So, we are taking common. What? N raised to power 1 by sine square t. So 1 by n raised to power 1 by sine square t. We need to divide this by term. Now just multiply. You will get 1 only. If you multiply, you will get 1. Right? 1 by n, then 2 by n raised to power 1 by sine square t. Then 3 by n raised to power 1 by sine square t. And all the way up to n upon n raised to power 1 by sine square t raised to power sine square t. Correct? Yes, this is happening. Okay, and power this is also what? Sine square t. Sine square t, sine square cancel. N. This will become 0 because fraction raised to power infinity is 0. Fraction raised to power infinity is 0. Fraction raised to power infinity is 0. Only the last term will be 1. 1 raised to power 1 by sine square t, sine square t, sine square t gone. 1 will be your answer. So 0 plus 0. Every term will be 0. Only the last term will be 1. And sine square t, the power will be infinity or 0. Cancel out. Okay, so it will become what? N only. Got it or not? Got it or not? Okay, Gautam Raj, I will reply to your comment 100%. Okay, common part done. Yes, this is exact 1. N cancel out. Exact 1 raised to power infinity raised to power 0 is 1 only. That's why it is written down as 1. Okay. Okay. Achyut Gon is saying why we are not using 1 power infinity method. because the form is not 1 raised to power infinity. If you go and check, that's why I tell you, always check the form. The moment I check the form, this is not proper 1 raised to power infinity form, not at all. And here also it is becoming 1 raised to power infinity, but exact 1 raised to power infinity, I told you yesterday. Exact 1 raised to power infinity is proper one. This is not an indeterminate form. Okay, it is very simple. It is like class 10th question, class 9th question. 1 square is what? 1. 1 cube is what? 1. 1 raised to power 10 is what? 1. 1 raised to power 1000 is what? 1. 1 raised to power crore is what? 1. 1 raised to power infinity is what? 1. But condition is that 1 should be the exact one, the only condition. Okay, got it? Okay, let's move on to the next question. Alright, JEE Main 2023 again. JEE Main 2023 again. Again. Alright. So, this question, okay, by the way. Just do let me know what was this question. What was the type of the question? Was it an alpha? Was it in beta? Was it in gamma? By the way, this alpha, beta, gamma questions may vary from person to person. Maybe I think this is an alpha for me, but you have not studied the chapter nicely. So you can say, no ma'am, this chapter, this is not an alpha for me. Just write it in the chat box. Whether you call it an alpha, that means easy question. Beta, that means moderate. It is easy, but it is lengthy maybe. So this is moderate. It will take time. So alpha, beta or gamma. So I can see students have started writing alpha, then beta also. Okay, be honest with yourself. If this question comes in your exam, JEE Main exam, what will you call it? Alpha, beta or gamma? Always give it a thought. Okay, whether we both are solving or you are solving on your own. Also give last 5 seconds to that problem. Okay ma'am, okay. So this is an alpha question. No, this is a beta question. I don't think I'll be able to solve this question at all when it comes in the examination, when it comes in JEE Main test. So mark it as gamma. Okay. Be true to yourself. Okay. Next question. Chalo, let's start this. Let x is equals to 2 be a root of the equation this. Alright. This is the equation. Okay, that simply means you can plug in 2 over here, isn't it? So that simply means I can write 4 plus 2p plus q is equals to 0. The very first statement is giving me this as the equation. Let me write it on the right hand side. Okay, let me go ahead and read the question. Fx is given as piecewise definition. Okay. So fx is 0 when x is equals to 2p, and fx is this whole expression where x is not equal to 2p. What we need to figure out? Limit of x tend to 2p plus f of x, right? Okay. So what we need to figure out is, tell me one thing. Limit of f of x is tending towards 2p plus. Can I write it as f of 2p plus h? I have taught you this yesterday. Are these two same thing? Yes. Okay. So what I need to calculate is f of 2p plus h. Obviously, limit h tend to 0. Then limit h tend to 0 will come into the picture. Limit h tend to 0 plus, right? H tend to 0 plus. Can I write it this way? Okay. Cool or not? Yes. So I just need to put, what I need to do is I need to just take out this, so I need to copy it. Okay, f of x is equals to 1 minus cos x square minus 4px plus q square plus 8q plus 16 upon x minus 2p raised to power. Alright. So what I need to calculate is limit x tend to h tend to 0 plus. So the moment I plug in 2p plus h, f of 2p plus h, that's what I need to calculate, right? Let me just show you one more time. In the question, we need to figure out limit x tend to 2p plus f of x. What I did is I actually substituted x equals to 2p plus h. So x equal to 2p plus h, that's what we need to figure out, right? Okay, x is equals to 2p plus h. So put x is equals to 2p plus h, okay? Alright, so do you remember that standard limit? I told you yesterday, this is my favorite standard limit, 1 minus cos x upon x square. Limit x tend to 0 is what? Tell me. Tell me. Tell me the value of this. Half, right? So what we are going to do is we are going to create the same thing over here. Same thing over here. So for this, what I need is 1 minus cos. Inside there is this expression. So I actually need to write this expression. Write the same expression with a square over here. So it will become what? X square minus 4px plus q square plus 8q plus 16, right? With a square, don't forget, with a square, right? With a square, and post that. Okay. With a square, because I need a square of this. I need square of this in the denominator as per the standard formula. Here it is x, here it is x square. Multiply, I need to multiply it with x square minus 4px plus q square plus 8q plus 16 whole square. Perfect? Yes? So this will become what? Tell me. This will become what? This will become half. Okay? This will become half. So let me just mark it as half. Alright? Okay. And now just put x is equals to 2p plus h. X is equals to 2p plus h. Start putting x equals to 2p plus h in here. The moment I put 2p plus h, I will get 2p plus h whole square minus 4p 2p plus h, alright, and this value which is plus q square plus 8q plus 16 whole upon this 2p plus h, so h raised to power 4. H raised to power 4. Okay, alright. Actually, there is yes. Got it? Let me just confirm once. I just wanted to check the question. I guess this question has some square missing. Okay, let me just check. Give me a moment. Let me just check whether we have a square missing or not. All right, there is one mistake. Actually, this is not power 4, this is power 2. This is power 2. This is power 2. So here this will be power 2. So sorry about that. So sorry about that. It's one mistake, one typing mistake. This is 2. Yes. So the moment you put, okay. Yes. Okay, let's just begin with the starting. Let's just start this question from the beginning. So this was the question. Okay, x is equals to 2, be the root of this equation. So we have plugged in 2 over here. The moment you put 2 over here, you will get this equation. Okay, keep that aside. Now, if I talk about this, the question is asking us to calculate limit of x, fx where x is tending towards 2p plus. So I have plug in x is equals to 2p plus h in this whole equation. The moment you plug in x is equals to 2p plus h, you will get this, right? And we have created 1 minus cos something upon that square into that square. So this is what we have got. Now just expand it. This is h, this is square only. Try expanding it. What will you get is 1 by 2. You will get h square plus 4p square plus 4ph, right? This will be minus 8p square minus 4ph plus q square plus 8q plus 16 upon h square, right? And this is multiplication. This is the value of limit you are getting. Now you just need to put h tend to, limit h tend to 0 plus. Correct? The moment you put h tend to 0 plus, you will get h square by h square. So that will be 1. Okay, h square by h square will be 1. 4ph gone, right? So you will be getting what? q square plus 8q plus 16 minus 4p square, right? This particular thing you are getting. Now what I am trying to tell you is this particular expression is 0. I will show you how. So this is the expression what we've got. Now 2p plus q is equals to, okay, let it be this way. q plus 4 is equals to minus 2p, square both the sides. So q square plus 16 plus 8q is equals to 4p square. This is the statement, q square plus 16 plus 8q. You can put 4p square in the place of this. q square plus 16 plus 8q. So this will become what? 4p square. Okay, 4p square. Perfect. Alright. Okay, so this will become 0. This will become 0. The whole expression will become 0. And you are going to get what? A 1 as an answer. Half as an answer. Half as an answer, because there is an half over here. So half is the correct answer of this particular. Half is not given. Half is not there. One minus cos. Answer should be half. Okay, answer should be half. Let me just check. There is some problem with this question. Okay, let's just, it has some problem. No, it has some, okay, greatest integer. Okay, GIF, yes. GIF of half is what? A 0, yes. Perfect. Yes, GIF. Thank you, black caps. Yes, GIF. All right. Perfect. ठीक है? Okay. Shall I tell you one more time? Yes, one more time with a shortcut. Okay, not the lengthy solution. I'll give you a small solution for this. Okay, so let's start with the beginning only, because there was some error in this question. That's why we got confused. It is 2. Let me mark it as 2. Okay, ma'am, tough question, but it looks very, no, it is not that tough. Okay, give me 1 minute. Okay, so the moment you put x is equals to 2 over here, what will happen is 4 plus 2p plus q is equal to 0, right? Okay, alright, let's start the question from the beginning. 4 plus 2p plus q is equals to 0. Alright, perfect. Now what I'm gonna do is q plus 4 is equal to what? Minus 2p. Do you agree or not? Okay, q plus 4 is equals to minus 2p, right? Square both the side. If you square both the side, what would you get? q square plus 16 plus 8q is equals to 4p square. Is equals to 4p square. So what you can do is you can just delete this and make it as 4p square, right? 4p square. Okay, Vijay Lakshmi is saying, ma'am, denominator given is correct. Maybe it is correct. Let's see. Let us make it as the original denominator only. Let us make it as an original denominator only. Okay, so 4p square. Okay, Vijay Lakshmi, perfect. 1 minus cos this particular expression upon x minus 2p raised to power 4. Clear? Okay. Now 1 minus cos. Can you see what is happening inside the bracket? This is a perfect square. Perfect square of x minus 2p square. Right? And upon there is x minus 2p raised to power 4. Yes, Vijay Lakshmi, you are correct. Limit x tend to 2p. X tend to 2p plus. Okay? Alright? Alright? Yes, it is correct. Okay? Now I can clearly see that 1 minus cos something whole upon something square is equal to half. You all know. 1 minus cos something upon something square is equal to half. That something should be equal to 0. It is happening right here. It is happening right here. 1 minus cos something which is actually becoming 0, and here it is that its square is there. It is clearly half. One step question. Actually, I did some mistake in the calculation, so this would be your one step question. Have a look. The question is correct. Alright, one step question. Just ignore this. We'll ignore the solution. So what we did was x is equals to 2 is root of the solution. I have inserted 2 over here and I've got this equation. Shift 2p on the other side, square it. You will realize q square plus 8q plus 16 can be written down as 4p square. And this, my dear student, is becoming whole square. X minus 2p whole square. And this whole square is present over here again with a square. That's what we want. That's what we want in the standard limit. 1 minus cos 0 upon that 0 ka square. 1 minus cos. The same thing is here and square is available in the denominator. So this is clearly becoming half. So this is becoming what? Half. GIF of half is nothing but 0. Option C, absolutely right. Okay. Clear? Yes. Again, I would say this is an alpha question, but my bad, actually I went in the wrong direction. I started the question with the wrong direction. Okay, my bad. Chalo, let's move on to the next problem. This is the problem. All right, again from the limits. Shall we start? Okay. All right. So here actually it looks very scary. Fx is given, then gx is given, then hx in terms of fx is also given, right? And greatest integer function is also involved. What we need to calculate over here is limit of this particular expression. And trust me, this particular question is one of those questions which actually looks scary but is very, very easy. We don't need to calculate g of h of x. We are not here to calculate the composite function, right? We will solve it with very, very easy steps. Okay, shall we go ahead? So here we need to calculate what? Limit of g of h of x minus 1. Just tell me one thing. What we need to do is we just need to calculate left hand limit and right hand limit, isn't it? Yes or no? Left hand limit and right hand limit. Okay, so what should I calculate first? Tell me. Shall I calculate right hand limit? For right hand limit, what I need to do is I need to put x is equals to 1 plus. That's it. I need to put x is equals to 1 plus in this expression. Start putting 1 plus over here. So what would I get? G of h of 1 plus minus 1. Or we can call it as 1 plus h. Yes, 1 plus h minus 1. Can I do that? 1 plus h minus 1. Here h would be a positive quantity. Okay, 1 and 1 cancelled, so I'll be getting G of H of, okay, so H, actually H of H will confuse us. H of H will confuse us. So what we can do is, we can just put 1 plus K. Okay, so it will become H of K plus, where K is a positive quantity. Where K is a positive quantity. Because H function is already given to us, na, it will confuse us. So G of H of K plus. So here we need to figure out what? Tell me. So I need to figure out, tell me H of K plus. Tell me H of K plus. Where is H? Here is H. Here is H. So H of K plus. K is a positive, smallest positive quantity. So this will become 2 into 0. Because GIF of a small positive quantity is what? 0. So this is 2 into 0, gone 0, minus f of 0 plus. So f of 0 plus we need to figure out. What is f of 0 plus? Where should, so f is this. We need to calculate f of 0 plus. Okay. So f of 0 plus will come from here. F of 0 plus will come from here. So f of 0 plus, for f of 0 plus we don't need to go here. We need to go here. The moment I plug in any positive quantity, so this will become x by x. So this will become 1. So this will become f of 1. Actually, so 0 minus 1. Right? So h of k plus is coming out as what? Minus 1. Getting my point? Yes or no? Yes or no? You've got h of k plus minus 1 and you can go ahead and replace h of k plus as minus 1. So you will get g of minus 1. G of minus 1. Now what is g of minus 1? Where should I go? Where is g? Here is g. G of minus 1. Okay, g of exact minus 1 by the way. G of exact minus 1 is what? Coming out as 1. So right hand limit is coming out as 1. Left hand limit, your homework. This is your homework by the way. Left hand limit you will calculate, it should come out as 1. By the way, we are not calculating left hand limit in this particular question. Why? Why? Because all the options are suggesting some value. There is no such option in which it is mentioned that limit does not exist. There is no such option. There is no such option in which I can say that limit does not exist. If maybe B option was limit does not exist, then I would have to check RHL is 1, LHL is also 1, then only I can say the limit is 1. Right now I am sure that limit exists because the option says the limits तो definitely exist. Are getting my point? अगर एक भी option limits does not exist होता तो we would have calculated LHL also, we have equated, we would have made sure that okay, LHL and RHL are equal. Okay, all right. Any problem in calculating this? Shall I explain it one more time? Shall I explain it one more time? Any problem, any difficulty in calculating this? All good? All clear? We just have actually calculated the right hand limit. For right hand limit, I will put 1 plus, or we can say 1 plus k. 1 plus k, where k is some positive quantity, right? The moment I plug in x is equals to 1 plus k, 1 will get cancelled out. G of h of k plus, that means h of some positive quantity we are here to calculate. Yes, h of some positive quantity. Now where is h? Here is h. H of some positive quantity we are trying to calculate. The moment I plug in some positive quantity, very small positive quantity inside greatest integer function, it will become 0. We know that this is becoming 0. And f of 0 plus, f of 0 plus. So we need to go here because f is here. F of 0 plus. The moment I plug in very small positive quantity in this, x is not 0 but it is rather greater than 0. So this is the fact, this is the branch which we need to calculate. So x upon x, both are positive, mod will become positive only, so it will become 1. So f of positive quantity is coming out as what? 1. So 0 minus 1, that means h of k plus is coming out as minus 1. Now plug in the value, this is exact minus 1. Okay, so this minus 1 will go here. G of h of minus G of minus 1, g of minus 1, clearly we can see that g of minus 1 is nothing but 1. Okay, stop spamming Frank. Shreya sir and Nabamita ma'am's PYQ is available in this particular session only. We are running one marathon. In one session you will get Shreya sir PYQ, Nabamita ma'am PYQ and my PYQ. Okay, you will get after my live ends. Don't worry about that. Okay. Alright, I guess this question is clear. Next question on your screen, JEE Main 2023. Again, you'll be saying, ma'am, every question from JEE Main 2023. Okay. Alright, so this question again, this question will have x cube. There is some mistake. X cube is here. No mistake, but x cube actually is like it got hidden. Okay. So x cube. Consider x cube. Alright, the question says limit x tend to infinity, this upon this multiply x cube. This is an infinity by infinity form. This is an infinity by infinity form. What do we do in infinity by infinity form? I have taught you this yesterday. What do we do? Remember the techniques. Yes, Rock again. Very nice, very nice. I have told you yesterday, whenever you see infinity by infinity form, whatever is the highest power, take that common. So I can clearly see that here x is the highest power, but it is inside the square root, right? It is inside the square root. So it will become root x. Root x will come common. Root x raised to power 6. That means from the numerator x cube will come out common, and from the denominator highest power is x raised to power 6 and x raised to power 6, right? So from the denominator x raised to power 6 will come out. Okay. Alright. No L'Hopital. If you apply L'Hopital, you will be gone actually. Plus, please consider positive sign. Please consider positive sign. There are some mistakes in today's session actually. Positive sign. Glad I checked. Take out x cube common, no L'Hopital. If you apply L'Hopital, you will be dead. You will be stuck in infinite loop. Okay. Alright, that's why I actually, if you, expansion also you can, actually there is no need of applying expansion, Vijay Lakshmi. Just take maximum power common and you will be sorted. Chalo, saath mein karte hain, saath mein. Let's do it together. Just take only one step problem. Only one step problem. Okay? One step problem. Just take highest power common. Stick to the basics. This is an alpha question. Okay? No calculation mistake. So I already told you here x square is here. Here positive sign is here. Okay? Just take out x common. If I take x common, you also know that x is inside the square root. So it will become x raised to power half. But power 6 is already there. So it will become what? X cube. X cube. 1x cube is already here. 1x cube is already here. So let me just write this x cube also here. Let me apply the bracket. The moment I take x outside, it will become 3 plus 1 by x. 3 plus 1 by x. Okay. And we have a square root over here. Half. Plus 3 minus 1 by x. Again we have a square root over here. Alright. And okay. And one more bracket I have, which is what? Which is power 6. Yes. 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 Okay. Next. Again same thing I'm gonna do over here. So 3 plus 1 by x raised to power half minus 3 minus 1 by x raised to power half. Okay. Then we have power 6 as well. So this is power 6. Done. 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 And bracket close. Okay. Okay. Whole upon, whole upon, whole upon. Now tell me one thing. Tell me one thing. X raised to power 6 you can take common. X raised to power 6 you can take common. The moment you take x raised to power 6 common, you will be left with 1 plus, 1 plus, this will become what? 1 minus 1 by x square, power half and whole raised to power 6 plus, again same thing, 1 minus 1 by x square power half whole raised to power 6, bracket close. Sorted or no? Okay, let me take another color. Now x raised to power 6, x raised to power 3, x raised to power 3 gone. Remember, x is tending towards infinity. So this is becoming infinite, 1 by infinity 0, 1 by infinity 0, okay. 1 by infinity 0, 1 by infinity 0, 1 by infinity 0, okay. So you will be actually left with what? Root 3, okay, plus root 3, okay, root 3 plus root 3 power 6, okay, and then we have plus sign, root 3 minus root 3 power 6 whole upon, what is this? 1 plus 1 raised to power half is 1, 1 plus 1, 2 raised to power 6 plus 1 minus 1 raised to power 6 is 0 raised to power 6. Are you getting my point? Yes, that's what you are getting. Now this is 0, this is also 0. So 2 root 3 raised to power 6 upon 2 raised to power 6. This is your final answer. Root 3 raised to power 6 would be nothing but 27. So 27, option B, absolutely correct. Absolutely correct. Tell me, was that one step question or not? If done correctly without any silly mistakes, without forgetting any power, any brackets, that's the whole USP of this question. The beauty of this question is nothing but don't do calculation mistake. What happens is we forget this 6, we forget this half, we forget this positive sign, we forget so many things in this, and then eventually the easy question will become difficult or will give us the negative marks. Okay, right? Alpha, beta or gamma? Alpha, beta or gamma? So for all of those who have missed, like Gothram is expecting, yes ma'am, I missed 1. So you will miss 1, okay? I know like 90% of the student will miss some or the other power, plus or number. So what to do? What to do? Tell me what to do. Just solve it one more time till the very end, till you receive the correct answer. Otherwise there is no point. If you are not able to solve this question here without any examination pressure, then you won't be able to solve it there, as simple as that. So the moment you arrive at the incorrect answer or any mistake, don't leave that question. Do it again till the very answer. Okay. So I can see beta, beta, beta in the chat box. All right. All right. Let's move towards the next question from the JEE Main 2021. All right. From the JEE Main 2021, let me just complete this question. There is some formatting issue in this PPT, I guess. ax square plus bx, ax square plus bx minus 4 is equals to 0. Yeah. Correct. Perfect question. So if A is this and if alpha is this and beta is this, is alpha. This is your alpha, this is your beta. You have to calculate two limits, two individual limits, so that you get the value of alpha and beta. Okay. Now you've got the value of alpha and beta. Now alpha and beta are roots of this particular equation. So you need to calculate the value of A and B, not alpha and beta. The question is not asking you the value of limits. The question is asking you the value of A and B. Okay. I'll give you 2 minutes. Will you be able to solve this question? Solve this. Tell me the value of alpha first. Tell me the value of alpha. Tell me the value of alpha. tell me the value of alpha. How to solve it? First of all, what will you do? Check the form. 0 by 0 form. So how will you do it? By factorization maybe. By rationalization will not work over here. Try doing factorization. Shall we start with factorization? Yes? Okay. Let's just simplify it. First simplify the trigonometry part. So now alpha is equal to limit of the expression where x tend to pi by 4 tan cube x minus tan x. Can I take tan common? Actually no need of series expansion as well. Then this will become tan square x minus 1. So tan square x minus 1 whole upon cos x plus pi by 4. Please open this, x plus pi by 4. So it will become what? 1 by root 2 sin x, no, 1 by root 2 cos x minus sin x. Cos x minus sin x. Cos x minus sin x. Okay? Yes? Let me just simplify it one more time. Just tan square x can be written down as what? Sin by cos. Let me write it as sin by cos. Limit x tend to pi by 4 tan x, then we will have sin square by cos square. So it will become sin square x minus cos square x upon cos square x. Take LCM and cos x minus sin x. Solving further, we need to solve it one more time. So this will become what? Sin square x minus cos square x, a square minus b square. So it will become what? C, tan x. Then we have cos square x. Okay, we have 1 by root 2 also. The root 2 is here. Let's not forget the root 2. Root 2 tan x cos square x, sin minus cos, sin plus cos upon cos minus sin. Sin minus cos, cos minus sin will get cancelled out, but with a negative sign. Yes, with a negative sign. Okay. And x is tending towards pi by 4. Now is the time you can put pi by 4 over here. The moment you put pi by 4, you will get minus root 2. Multiply tan x, tan pi by 4 is 1. Cos square pi by 4 is what? 1 by 2. Okay. And this will be what? 1 by root 2 plus 1 by root 2. So that would be 2 by root 2. Root 2 cancel. So this will become minus 4. Alpha is coming out as minus 4. Minus 4. Minus 4. Yes. Perfect. Shall I explain it one more time? Just pure factorization, cancellation and calculation. Okay. So what I did is I took tan x common and I opened cos a plus b. Cos a cos b minus sin a sin b. Okay. The moment I took tan x common, I realized that this will become sin square x minus cos square x once I convert tan x into sin by cos. Take LCM. Okay, this is here. Now sin square minus cos square can be splitted as sin minus cos, sin plus cos, but here you can clearly see if I cancel these two, a minus sign will come out. Now is the time you plug in pi by 4 in this particular limit. Tan pi by 4, it will become 1, minus root 2 is here. Cos square pi by 4 is half. Then 1 by root 2, 1 by root 2 is 2 by root 2. Root 2 cancel, minus 4 is the correct answer. Perfect. Alpha is coming out as minus 4. What about beta? What about beta? Have you checked on the form of beta? Yes, I can see Tiger ka answer is beta is equals to 1. Have you guys checked form of this particular limit? So this is nothing but 1 raised to power infinity form. What do we do with 1 raised to power infinity form? This is my favorite form. What do we do with 1 raised to power infinity form? We write it as, so beta will be equals to e raised to power. Now the power cot x will come in front. So this is cot x. And you have to subtract 1 from the base. So cos x minus 1. Limit x tend to 0. Limit x tend to 0. So remember that 1 minus cos x upon x square is equals to half. So you will need 1x square over here. you will need 1x square over here. So you just need to multiply it with x square and divide it with x square. So that it will become what? Minus half. So beta will become what? E raised to power 1 upon tan x. So x square by tan x into minus half. Now tell me. Again, tan x by x is what? 1. But we have one more x. So this will become e raised to power 0. Because tan x by x will become 1, but 1x will be left out. The moment you plug in x is equals to 0, you get e power 0. So 1 will be the final answer of beta. So alpha is coming out as -4, beta is coming out as 1, right? And alpha and beta are roots of this particular equation. Let us form this equation. Let us just form this equation whose roots are -4 and 1. Let me just form the equation whose roots are -4 and beta is equals to 1. So x plus 4 and x minus 1. Alright. So it will become x square and then plus 3x minus 4 is equals to 0. What is there in the question? It is given that ax square plus bx minus 4 is the equation. Clearly you can compare. A is equals to 1, b is equals to 3 is your final answer. 1 comma 3. Option D. Option D. Yes. Perfect. Tell me the nature of the question. Was it an alpha question? Was it a beta question? Was it a gamma question? Alpha or beta or gamma? Gamma to nahi hai. For sure it is not a gamma question. For sure it is not a gamma question. Do you want me to repeat it one more time? Alpha, beta, or maybe the final part? I will do that for you. If anyone asks me to repeat it, I will do that for you. Beta. Okay. And you know what? I will suggest you to solve each and every question at least twice. Because the moment you solve it for first time, okay, if you got the question smoothly, then it's fine. But if you have struggled with the question a lot for the very first time, do solve it second time, because the second time will be actually, it will not take much time. It will take the half of the time which you took it in the first place, right? So solve each and every PYQ twice. Trust me, this particular tip you will actually come and tell me, yes ma'am, it is working for us. Our subject, our chapters are getting like very good. I'm getting very good marks, okay? All right. Shreyas sir is here. Hello Shreyas sir. 5 hours and counting. Yes. So we have a next question over here. All right. Okay. So students are joining in. Tiger Dada is asking me, what is the meaning of alpha, beta and gamma? So in the very beginning, I have given one strategy, one basic strategy to solve questions in your JEE Main actual paper and to give the mock. Basically, it was a test taking strategy. All right. Which like many toppers used to apply in solving the paper. Okay. So alpha, yeah, students are telling you alpha means this is an easy question. So what I have told you is solve this question, give last 2-3 seconds and analyze it and ask yourself, was it an easy question, was it a moderate question, or was it a very difficult question? And what will happen when the question comes in your actual JEE Main exam? Then will you be able to do it in like 1 minute, less than 1 minute, or it will take you like 3 minutes, more than 3 minutes? So analyze that. That will help you in identifying the question in the JEE Main exam, because 7 to 8 questions are very, very easy questions in your JEE Main exam, right? All right. Okay. Chalo. Next question. Fx is given as this, then at x equal to 0. Okay. So what we need to figure out, let us check the options. Let us check the options. In option A, f is continuous. In option B, f is continuous. In option C, f is continuous. Okay, that means, and in option D there is no such thing that f is discontinuous. That means f is all the options are saying f is continuous. Have you looked at the options carefully? A is also saying f is continuous, B is also saying f is continuous, C is also saying f is continuous, and D is actually also saying that f is continuous, right? So f is so continuous. So I don't need to check. And it is very obvious that f is continuous. How? Tell me. F of 0 plus. The moment you plug in 0 over here, it will become what? 0 into sine infinity. Now I have told you yesterday that sine infinity is what? A finite quantity. Sine infinity is not infinite. Sine infinity value is a finite value which lies between -1 and 1. It is a finite quantity, right? So this will become 0. F of 0 plus is coming out as 0. Same goes with f of 0 minus. It will become 0 into sine infinity. So again it is also becoming 0. And f of 0 is given as 0. So that means it is very obvious that your function is continuous. Getting my point? Yes. So f तो continuous है. F तो is definitely continuous. ठीक है, चलो. Now what is next thing? F is not differentiable, f dash both are continuous, f is continuous, f dash. So I can clearly see the next thing which I need to figure out is, what about f dash? Whether my f dash is continuous or not. Whether my f dash is continuous or not, the moment I check my f dash, B and C, one option will get eliminated. Right? Either f dash is continuous or f dash is discontinuous. This is true. This is true. Okay, so I can clearly see either f dash continuous hoga, f dash discontinuous hoga. So it is very obvious that either B or C is true, A is incorrect, D is also incorrect. Right? It is very obvious that B and C, from B and C, something is going to be the correct answer. Alright, perfect. Okay, let us check for on the next page. Okay, next page. So fx would be what? X square sine 1 by x when x is not equal to 0, and fx is equals to 0 when x is equals to 0. Let us calculate f dash x. What is happening? I guess the caption got on automatically, right? Is this? Yes, this was the issue. Okay. ठीक है. F dash x. Can you help me calculating f dash x? Yes, subtitles. Okay. Can you help me calculating f dash x? F dash x will be what? So I need to apply the product rule. So x square is constant. Sine 1 by x. So derivative will be cos 1 by x into minus 1 by x square plus. Now sine 1 by x will be constant. So it will become 2x into sine 1 by x. Correct? X square cancel out. So f dash x is coming out as cos 1 by x plus, with a negative sign, 2x sine 1 by x. Okay. Now we need to figure out whether this, and when it is true when x is not equal to 0, and this is 0 when your x is equal to 0. Right? This is your f dash x. Correct or not? Now I need to figure out whether this new function is continuous or not. How will I test it? Very easy. I just need to know that f dash 0 plus is equals to f dash 0 is equals to f dash 0 minus. If this is true, then our function f dash is also continuous. Okay. So the moment I plug in 0 plus in this, I realize that this will become 0. So f dash 0 will become what? Something plus 0. What about this? What about this? This is an oscillatory function. This is an oscillatory function. This will oscillate I told you this yesterday. These kind of functions are discontinuous function. I told you in the yesterday's lecture. Go to the PDF, watch it. These kind of functions are discontinuous functions, especially at x equal to 0 I am talking about. So it is so obvious. Discontinuous at 1. Why 1? No, discontinuous at 0. So the moment I plug in 0, it will become oscillatory. At 0, this is discontinuous. So I can clearly see that f dash is discontinuous. So option B is absolutely right. Yes, option B is absolutely right. F dash is not continuous. Got it? Yes. Luxury Hitler typo, कोई बात नहीं, no issue. All right. Shall we move towards next question? So this question we did in the yesterday's class. I already told you this is the power over here. So shall I skip this? Shall I skip this question? We already did this question in yesterday's class, right? So this is a homework for those students who were not there in my yesterday's class, okay? Who were not there. And remember, this is a power, 1 plus mod cos x raised to r. Rest everything is fine. Okay? Alright, another question. JEE Main 2023. Now this question is very different. Is given and it says it is continuous at this. Tell me the value of this. These type of questions are very common, right? So till now we have done proper trending question, but this question is very different question actually. This type of question is very different question. It is very rare question. So let's do some rare questions as well. Okay. So what is happening over the approach is also a little bit different. You may not have like solved from the approach I'm gonna solve it. So like fresh mind, understand with the help with the fresh mind. Okay. Yes. So what is happening over here? 2 raised to power half minus 2 raised to power 1 by 3. 2 raised to power half minus 2 raised to power 1 by 5 and all the way up to this. Okay. So I can clearly see that the expression is this. 2 raised to power half minus 2 raised to power 1 by 3. This is your first expression. 2 raised to power half, observe this is like common throughout all the brackets. 2 raised to power half minus 2 raised to power 1 by 5. Okay. And all the way up to 2 raised to power half minus 2 raised to power 1 by 2n plus 1. Limit n tend to infinity is there. LT n tend to infinity. This is your expression. Correct? Yes? Okay. Now tell me one thing, that these two brackets, you need to compare these two brackets. I want you to compare these two brackets. Compare and let me know which one is bigger and which one is smaller. Which bracket is bigger and which bracket is smaller. So this is root 2 minus cube root of 3. By the way, observe one thing, that each bracket is less than 1. Calculate it. The very first bracket, the value is less than 1. The second bracket, value is less than 1. Third bracket, value is at least I can say for this, I can vouch for this. This bracket is less than 1. Yes, this bracket is less than 1. Alright, root 2, 2 raised to power 1 by 3. This is the expression we need to calculate. Okay, second one is bigger. Yeah, the expression is becoming bigger and bigger and bigger, but eventually all the expressions are less than 1. All the expressions are less than 1. And n is tending towards infinity. Okay, one method is very, very simple, that this expression is also less than 1. This expression is also less than 1. And this expression is also less than 1. How many terms are there? Who will tell me? How many terms are there? 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 Sorry, ये 2 raised to power 2 है, हाँ. How many terms are there? Infinite terms. When you multiply fractions, because this is also a fraction. Fraction number 1, fraction number 2, fraction number 3, fraction number infinity. When you multiply all the fractions infinite times, what will you get? Do this in the calculator. Very basic question. We just need to analyze it. The moment I multiply each and every fraction infinite times, it will become 0. Yes? Yes? Okay. So the thought is very different in this question. I agree. There must be some student telling me in the chat box, ma'am, we won't be able to think like this. But I have told you this. I have told you once now. A question in similar manner, if it arrives in your JEE Main, will you be able to do that? Yes. Sometimes there is a first time, right? It has to be first time somewhere. Okay. Alright. Done? Dusted? Shall we move ahead? One step, yes. This question again we did it in the last class for all of those who have not attended my yesterday's session. So this is a homework for those students, right? JEE Main 2023 latest question. Rock again, not understand. Okay. Rock again, I am saying that calculate root 2 minus 2 raised to power 1 by 3. This particular bracket is less than 1. Okay. Positive but less than 1. Again, this bracket is also positive but less than 1. What about this? This bracket is also positive but less than 1. Positive but less than 1. Now, do this exercise. Do you have calculator? Yes, we all have smartphones. So pick up the smartphone and try multiplying fraction, any fraction. Maybe this is like 0.4, then 0.8, then 0.7. Okay, try multiplying, keep on multiplying, because there are infinite terms. N is tending towards infinity, that means infinite terms, right? Last term would be the infinite term. If you multiply all the fractions, as many fractions as possible, infinite times, your value will tend towards 0. Okay? Okay? Alright. Homework question. Done, done, done. Next question on your screen. Alright. Next question on your screen. No, today we are not keeping the session too long. It's been already long, right? I will keep the session quite short, just 2-3 questions more and some homework questions, and I'll be leaving. Okay? All right? Yes. Don't worry. So here, what is the question? If alpha greater than beta greater than 0 are the roots of this particular equation. Okay. All right. Then we need to figure out the value of k. So basically we need to figure out limit of this expression. This is 1 by alpha. We need to figure out limit of this expression. Once we figure out limit of this expression, we just need to compare and we need to put the value k over here. Okay? Okay? Alright? And trust me, this is very easy question. Very easy question. Okay. So I can clearly see that x square plus bx plus a and here ax square plus bx plus 1. These two are related but not exactly same. Right? This particular quadratic and this particular quadratic, they look similar but they are not exactly same. Can anyone tell me what is the relation between this? Can anyone tell me? By the way, a hint is given over here as well. Some hint is given over here as well. Yes, Gothram, very good, very good. So in the question itself, it is given that ax square plus bx plus 1 is equals to 0 has two roots alpha and beta. And the moment I replace x to 1 by x, what I will get is a by x square plus b by x plus 1 is equals to 0. That means it will become a plus bx plus x square is equals to 0, or I can write it as x square plus bx plus a is equals to 0. Now what will be the roots of this equation? Who is going to tell me? Who is going to tell me? This equation has roots alpha and beta. I have replaced x by 1 by x. I have got this particular equation. Now tell me. What are the roots of this equation? Very good, Luxury Hitler. The roots will be 1 by alpha and 1 by beta. I told you that hint is already given over here, 1 by alpha. Right? So if alpha and beta are roots of this equation, because we have done the substitution replacement, so the roots of this equation will be 1 by alpha and 1 by beta. So can I write x square plus bx plus a as x minus 1 by alpha and x minus 1 by beta? Can I do that? Can I do that? Can I do that? Yes. So I will do that now. I will do that now. Okay? Okay. So just understand one thing, that x square plus bx plus a is equals to 0 will be having root as 1 by alpha and 1 by beta. This is very crucial. This is very critical. This is very important. You have to understand this. So now limit. Let's just look at here, 1 by alpha. This is 1 by alpha. Okay. So this will become 1 minus cos x minus 1 by alpha, x minus 1 by beta. Can I write it this way? Whole upon, what is this? What is this? 2 is here. Okay, let me write it as 2 over here. But I need x minus 1 by alpha over here. I don't need 1 minus alpha x. Are you getting my point? I don't need this. I don't need this. What I need is what? And trust me, what form is getting? Which form is this? Which form is this? Have you realized the form? The moment you plug in 1 by alpha over here, it will become 1 minus cos 0 by 0 square. But what I need to do, I need to create same 0 square over here. Then only I can write, I can use this 1 minus cos x upon x square is equals to half limit x tend to 0. That's what I am trying to create. Getting my point? So I should take alpha common from here. So it will become 2 alpha square, and it will become, the moment I take alpha common, alpha minus, okay. So 1 by alpha minus x, or x minus 1 by alpha square. Yes? Yes? And don't forget power half. Power half. Alright. Okay. So now to make the complete limit, what I'll be needing is, this 2 alpha square is already there, I know. 2 alpha square is already there. Let it keep it aside. Okay. So x minus 1 by alpha is here. X minus 1 by alpha square is present. X minus 1 by beta is here. I need to multiply x minus 1 by beta square inside the square root, and so I am dividing. I need to multiply also x minus 1 by beta. Yes, because the power is half. Half square cancel out. So I have actually divided x minus 1 by beta only. So x minus 1 by beta power 1 I will multiply. Done? Yes? Okay. Alright. So what I'll be left with is, now plug in x tend to 1 by alpha. The moment you plug in x tend to 1 by alpha, this will become 0. Right? This will become 0. So 1 minus cos 0 by same 0 square. This will become what? Half. This will become half. So half into 2 alpha square. So 1 by 2 into 1 by 2 alpha square power half, and put 1 by alpha over here as well. So 1 by alpha minus 1 by beta, it will become what? 1 by 2 alpha, 1 by alpha minus 1 by beta. Compare 1 by k, 1 by 2 alpha, k is equals to 2 alpha, option C. Have a look. Okay, one more time. So in the beginning, this was the quadratic equation given to us. and this was the quadratic equation was used in the question. So we have to create some correlation between these two. We realize the moment I replace x by 1 by x, I will get this equation. So the roots, if the roots of this equation are alpha and beta, the roots of this equation will be 1 by alpha and 1 by beta. So I can clearly write it as x minus root, x minus another root. What about negative sign, ma'am? Which negative sign? Negative sign. Oh, 1 by beta minus 1 by alpha. Okay. X minus. One negative sign is there, I guess. I have made some mistake, I guess. Okay. Yes, Vaishnavi. Yes. So what is happening over here? In the question it is given that alpha is greater than beta. Alpha is greater than beta. So that means what? 1 by beta would be greater than 1 by alpha. 1 by beta would be greater than 1 by alpha. Okay. So this I have multiplied inside the square. Right, I have just compensated it, so I will have to multiply it in a modulus. Okay, I will have to do it in the modulus. Why? See, square and root, the moment it will come out from the square, it will become a modulus quantity, right? So apply the modulus. Which one is bigger, 1 by beta or 1 by alpha? So 1 by beta is bigger, so this will be in modulus. So this modulus will get opened with a negative sign. That's way it will get compensated. Okay. Actually, I have not multiplied x minus, I have not divided with x minus 1 by beta. Actually, I have divided with mod of x minus 1 by beta. Why? Because there is a square root and we can't keep negative quantity in the square root. So this is mod x minus 1 by beta, and this is also mod x minus 1 by beta. Now you have to figure out 1 by beta is greater than 1 by alpha. So that means this quantity will be negative, obviously. So the mod will get opened with a negative sign, so 2 alpha. That's why this information is given to us. We have not used this information. Each and every information is actually very useful for the question to solve. Alright. Okay. So this question is also having a formatting error. Alright. So let me just write this expression one more time. Limit x tend to 0, e raised to power ax minus cos of bx, okay, minus cx by 2 e raised to power minus cx whole upon 1 minus cos of 2x. Okay, this is the original question. JEE Main 2023. Yes. Luxury Hitler, you are going in on the right track. I am so happy that some students are actually aware that where to apply, what to apply. Clear cut expansion question. Okay? Shall I write all the expansions for you here? For all of those who have not remembered the expansions, I'll make it remember to you. Okay? E raised to power x, very easy. 1 plus x square by factorial 2 plus x cube by factorial 3 and so on. Okay? What about cos x? I already told you cos is an even function. All the even powers, alternate sign, x square by 2 factorial, x cube plus x raised to power 4 by 4 factorial minus x raised to power 6 and so on. Only these two expansions are useful, isn't it? Very easy question, not very difficult. Not at all. Alpha question. Trust me, these kind of questions are very trending. It will come in 2024 100% because it is coming in 2021, 2022, 2023. Check the paper. You just have to apply the expansion and equate it to the final value. This is 17. Shall we start? E raised to power ax. So you just need to replace x by ax in this. Let's do that. So limit x tend to 0, 1 plus ax whole square by 2 factorial and so on. Only 3 terms. Only up to square terms, right? Minus sign cos bx. So 1 minus bx by 2 factorial. Actually bx square by 2 factorial. But that's it. And then minus cx. And then we have to like open e raised to power minus cx. What will I do? I will replace x by minus cx. So 1 minus cx, that's it. 1 minus cx because I need to go only up to squared terms. Whole upon what? 1 minus cos 2x. You all know 1 minus cos 2x, my favorite standard limit. Tell me. What should I multiply? 1 minus cos 2x. What should I multiply in the numerator? 1 minus cos 0. And I have to give what? 2x whole square. Yes? 1 minus cos 2x upon 2x whole square. Which standard limit? 1 minus cos something upon that something square is half. Right? 2x whole square. Correct? 2x whole square I have multiplied. So 2x whole square I will have to divide as well. Right? This will become what? This will become a 2 in the numerator. Right? 1 by 2. Yes. A 2 in the... Yes. A 2 in the numerator. So 2 multiply. Now 1 and 1 are getting cancelled out. Okay. What is the terms? X wali? A and then minus cx. A minus cx. Okay. Cx by 2 was here. Okay. A minus cx by 2. So a minus c by 2 times x. This is the term related to x. Right? A minus c by 2x. What about x square? So a square by 2 plus a square by 2. What about this? Minus plus b square by 2. Alright. And then plus c square by 2. Yes. This is the coefficient of x square. Right? Whole upon 4x square. Whole upon 4x square. Let me just copy it. Okay. So twice multiply a minus c by 2x. Then plus a square plus b square plus c square by 2. We have x square. And there are other terms related to x cube something x raised to power 4 whole upon close. And then we have 4. Okay. No, we have 4x square. Limit x tend to 0. This is our expression. This is equal to what? 17. Getting my point? Now tell me. This is 2. This is gone. Okay. Now tell me one thing. For this limit to exist, the very first term, this is becoming actually a minus c by 2 upon x. Here x is tending towards 0. So this expression will go towards infinity. Right? What about this? A square plus b square plus c square by 4. Then x square by x square is 1. Plus so on all the way 0 terms and then is equals to 17. Tell me one thing. If this whole expression, limit x tend to 0, if the whole expression is equal to 17, then how come this will become infinity? This has to die. Because if this doesn't die, then this expression will take whole expression towards infinity, it will not become 17. We want this expression to exist and become finite. So this has to die. This has to become 0, right? So C will be equal to 2a. C will be equal to 2a, and you clearly see if this is 0, rest everything is 0. A square plus b square plus c square is equals to 68. Put c is equals to 2a, so 5a square plus b square is nothing but 68. 68 will be the final answer. Option C is absolutely right. Okay. All right. So this is the expansion. I have applied the expansion over here nicely. Then I have calculated the coefficient of x square. That's it. No coefficient of x cube needed. Why? Because I have only x square over here. No, I have only x square term over here. X cube term will get 0. X raised to power 4 term will become 0. Are you getting my point? Okay. Now this is the coefficient of x, this is coefficient of x square. There will be terms x cube, x raised to power 4, which I am not interested in. This has to become 0 because x by x square will be 1 by x, and 1 by x will create a trouble. 1 by infinity, it will create 1 by infinity. So if a is equals to c by 2, then only this will become no problem, no issue. This will not create any issue. Okay. Got it? All right. All right. Next question. Understood? Any doubt, any confusion, please ask me. I'll one more time I'll explain it to you. Don't worry about that. All right, this is very nice question. This is not at all difficult question. Very easy question. Doable question. What about this? What will you tell? Alpha, beta or gamma? Alpha, beta or gamma? Okay. So let us understand this question first. There is a function f which is defined by this. And this function involves GIFX, GIFX. Okay. One tip of the day. The moment you see greatest integer function, and in case you know the bifurcation, you know the intervals, try splitting the interval more and more, as much as possible. Try splitting the interval. Try breaking the definition as much as possible. Are you getting my point? What I'm trying to say? So we need to figure out, actually we need to plot the graph of fx. Once we plot the graph of fx, we will plot the graph of mod fx, right? Very easy question, not at all difficult. It is looking difficult because of GIF of x. We will first of all get rid of GIF of x. I will tell you how. So first of all, just rewrite the definition. F of x is equal to, I am just breaking this particular segment left, right and center. How? So this is minus 2 to 0. Can I write it as x belongs to minus 2 to minus 1? Or open bracket, yes, open bracket. Minus 2 to minus 1, open bracket. Then next, x belongs to minus 1 to 0. Then x belongs to 0 to 1. And then x belongs to 1 to 2. That's it. Just break it. If you are going to break it, this GIFX is gonna disappear. As simple as that. Okay, let me just ask you. In this particular situation, tell me what will happen to GIF of x. If x is belonging to this particular interval, what will be your GIF of x? Or rather tell me about this. When x is 0 to 1, so this is the definition. When x is 0 to 1, your GIF of x will become 0. This will become 0. 0 multiply this. So in this particular thing, your function is becoming 0. Getting my point? the moment I have defined this region that my x is 0 to 1, my x is a fraction. If my x is a fraction, in this particular branch I will go, this is your GIF of x. GIF of any fraction is 0, this will become 0. So the whole expression, my fx will become 0. Same, let's do same with 1 to 2. If my x belong to 1 to 2, that means suppose 1.5, my x is 1.5, right? If my x is 1.5, it will become 1 into x minus 1, so it will become just x minus 1. You have, can you see, you have got rid of GIF of x. Now what about this? Tell me about this. Minus 2 to 1, some students were telling me, between minus 2 to 1, your GIF x will become what? Minus 2 only. So this will become minus 2. Your GIF x will become what? Minus 2. And between minus 1 to 0, your GIF x will become minus 1x. Perfect. Minus 1 to 0, right? At minus 1, it will become minus x. So minus 2. Correct? This is the definition. Can we plot this curve? Isn't it very easy to plot the curve? Yes, it is definitely easy. Let me just help you, or you will help me to plot this curve. So 0 से लेके 1 तक, between 0 to 1, my curve will look like, so 0 पे value is 0, 1 पे value is, 1 पे value, if you put 1, 1 पे value is also 0. So from 0 to 1 including 1, the value is 0. Right? What about 1 to 2? So this is my 1, this is my 2. What about between 1 to 2? 1 to 2, there is a straight line. Right? The moment you plug in 2, you will get a 1. So it will be this and this. Yes, this is minus 1, this is minus 2. Minus 1, minus 2. Okay. Now between 0 and minus 1, we have this with us. What is this? Minus x. So the moment you plug in minus 1, you will get a 1. So the line will look like this. The moment you plug in 0, you will get 0 only. Minus 1 pe you get minus 1. Okay. What about minus 1 over here? So you will get a 2, straight away 2. So it will look like this. And the moment you plug in minus 2, you will get a 4. So your line will look like this. So this is the curve of f of x. This is the curve of f of x. By the way, we are not interested in y is equals to f of x. We are interested in y is equals to mod of f of x. And you know what? Mod of f of x and f of x will look like same only because there is no curve which is below the x-axis. Right? You know what do we do in creating mod of f of x? We just take mirror image of the portion which is below the x-axis and we are done. But here there is no portion. So it will look like same. So in this case, y is equals to f of x graph and y is equals to mod f of x graph are one and same thing. Same only. Yes. Now tell me about continuity and differentiability. The question is asking you to calculate points of continuity and differentiability. So point of continuity and differentiability, M and end. So M is point of continuity. I can clearly see the function is overall continuous except this point minus 1. So points of discontinuity is 1. Points of discontinuity M is equals to 1. Right? M is equals to 1. Luxury Hitler, M is equals to 1. Right? What about points of non-differentiability? So point of non-differentiability is this one. This is a sharp corner. This is the second sharp corner. And this is the jump. So there are 3 points. There are 3 points. Yes? 3 points. So 3 plus 1 to 4 is your correct answer. 4. m plus n is equal to what? 3 plus 1, 4. And clearly it is given in the open interval. Yes, m are the number of points. They have, m is not something, number of points. We need to calculate number of points. They are not asking us about the value of x. Be careful. M is the number of points at which fx is not continuous, and n is the number at gx is discontinuous. Okay, that's one number of points, because again this is a numerical answer type question, so negative answer will not be. No. See now. Number B, be careful about the question, the terms used in the question. Okay, all right. Okay, another question. Yes, the last question of the day. Then I'll give you 2 homeworks today and we'll wrap up the session. Okay, chalo, very easy question, very easy question. I scared of graph, now it looks very easy. Yes, Gutram, graphs are actually easier than the many difficult questions. Okay, chalo, fx is given to us and we need to figure out the continuity of the function at x equals to 0 and x equal to 1, right? We don't need to think about the whole question. We are just interested in whether it is continuous at 0 and 1. How will we do it? So we need to figure out f of 0 first. Let's talk about 0. Okay, f of 0, put exact 0. Exact 0, 0 minus 0, 0, 0. So f of 0, clearly it is 0. Clearly it is 0. F of 0 is 0, right? What about f of 0 plus? 0 plus h. Be careful in this particular question. F of 0 plus h. 0 plus h would be what? GIF of h square minus h plus, right? This h is a positive number. Mod of minus h plus GIF of a positive quantity is 0. Modulus close. Okay? Okay. This we can write it straight away. Now tell me about this. So this is anyway, this is mod h will come at 0. What about this? What about this? H square minus h. Who will tell me? H square minus h. H square minus h. Will it become 0? Will it become 0? 0 or something else? Luxury Hitler is saying 0. Okay. All right. Gotram Raj is saying 0. Do you have your phones with you? Do you have your mobile phone with you? Can anyone tell me if h square minus h, can anyone tell me the exact value of h square minus h where h is a 0.1? Let us put a value. Yes, now you are getting it. So what happens when you have h is a very small positive quantity? That means it is a small fraction. If you square a small fraction, it becomes even smaller, right? So h square is smaller than h, so this will become a negative quantity, small negative quantity, and the GIF of negative small quantity will become what? -1. So this will become -1. So this is discontinuous at, not continuous at x equal to 0. Not continuous at x equal to 0. So not continuous at x equal to 0, that means option C wrong ho gaya. Option A is also incorrect. Okay, and between B and D there is one option which can be correct. Got it? Very important. Nice. Chalo, let's talk about f of 1 now. It is not that difficult, it just needs some trick. So f of 1, tell me the value of f of 1, the exact one. The exact one. So 1 minus 1, 0, minus 1 plus 1, 0. So f of 1 is also coming out as 0, right? Now we need to calculate f of 1 plus h. Alright, 1 plus h. So it will become what? GIF of 1 plus h whole square minus 1 plus h GIF close. Okay. Plus modulus of minus of 1 plus h and this will be what? 1 plus, right? So it will become 1 only, modulus close. Minus 1 plus 1 cancel, this will become 0 only, this whole modulus, because minus h is anyway 0. So this portion is coming out as 0. So 1 and 1 is getting cancelled out. So we are having left with h square plus 2h minus h. So h square plus h only. H square plus h will become 0. So f of 1 plus h is also coming out as 0. F of 1 plus h is also coming out as 0. Now we just need to figure out f of 1 minus h. 1 minus h. So 1 minus h square minus 1 minus h. 1 minus h square minus 1 minus h bracket close plus. What is there? 1 minus h. So mod of minus 1 minus h and plus 1 minus h ka GIF. GIF of 1 minus h. That means GIF of 0.99999. So it will become 0 only. Modulus close. Okay. So let's just expand it. So 1 and 1 cancel. H square minus 2h and minus minus plus h. Right? Bracket close. Plus this is what? 1. 1. What about this? H square minus h again plus 1. So this is becoming minus 1 plus 1. So this left hand limit is also coming out as 0. Left hand limit is also 0. Right hand limit is also 0. Value of function f of 1 is also 0. So that means function is continuous at x equal to 1 but discontinuous at x equal to 0. Option B. Be very careful. This is the question actually which will it will take very less time if you know the concept. Okay, this is a scoring question for those who know the trick, who know the drill. Right? Alpha, beta or gamma? Just tell me alpha, beta or gamma. Tell me alpha, beta or gamma. Alpha, beta or gamma. Alpha, beta or gamma. Alright. I have actually one more last question. Shall we do it or shall I give you the homework? One last question. Shall we do it? Are you enjoying it? Because that question is like this question, maximum of. Remember we did minimum. So that question. Okay, so last, it is definitely the last question. Okay, in this particular question it is given that fx is given. Let me just rewrite the fx. Let me just rewrite the fx. Maximum of 1 plus x plus GIF of x. Okay, so I already told you just now in the previous question, in the question previous to that question, I told you the moment you see GIF of x, I gave you the tip, and you know the interval, just what you gonna do is just break the interval as much as possible. So we are going to break it. X belongs to 0 to 1 and then x belongs to 1 to 2 and next x belongs to 2, like this. That's how you expand it. Okay, all right, ready? Split it. Yes, fx is equals to this. All right, now maximum of 1 plus x plus GIF of x. When your x belongs to this particular interval 0 to 1, so it will become 1 plus x only. So maximum of 1 plus x, maximum of 1 plus x, okay, 2 plus x and okay, 2 plus x, and the third thing is what? X plus this will become 0, so x. Okay, all the GIF is gone, becomes 0. So maximum of these three functions, that's it. Cool. When x belongs to 1 to 2, what will happen when x belongs to 1 to 2? GIF will become 1. So 1 plus x plus 1. So this will become what? Maximum of 2 plus x Alright, 2 plus x again, and okay, 2 plus x again, and what about this? This is x plus 2, okay, it's 2 plus x again. Actually 2 plus x only, it will become 2 plus x only. What about this? The moment you plug in x is equals to 2, you will get 1 plus x plus 2, so that will become maximum of. The moment you plug in 2, so 2 plus 1, 3, 3 plus 2 is 5. The moment you plug in 2 over here, 2 plus 2 is 4. And here if you put 2, 2 plus 4 is 6. Alright. Now out of all the values, maximum is 2 plus x. Out of all the value, maximum is 2 plus x. Out of all the value, maximum is 6. So our fx became what? The updated definition is what? Okay, so it is x plus 2, x belongs to 0 to 2. X belongs to 0 to 2. Okay, and 6 when x is equals to 2. Alright, 0 to 2 and 6 when x belongs to 2. Okay, so f is non-differentiable. F is continuous and non-differentiable. So x plus 2 and x, okay. So number of points of discontinuity. What is the interval? 0 to 2 is the interval. Number of points of discontinuity is what? Okay. So actually, okay. Yes. So actually x is discontinuous at x is equals to 2. Right? Because interval given for discontinuity is different. This is the interval given for continuity. At x equal to 2, you can clearly see. At x equal to 2, what is happening? The moment you put 2 over here, it will become 4, it will become 6. You can clearly see x is discontinuous at 2. But for differentiability, it has given some different interval. So f is actually, so in 0 to 2, x is differentiable everywhere. So differentiability everywhere. Right? So m is equals to 1, n is equals to 0. So 1 plus 0. So 3 is the correct answer. Option D. Option D. No, Gautam Raj. No. Are you getting my point? The interval given for continuity is 0 including and 2 including. So my function is discontinuous at x is equals to 2, clearly visible. So x is discontinuous at x equal to 2. Now some people will say, okay ma'am, but non-differentiable at x equal to 2. Yes. Okay, that is another thing. But differentiability interval is not including 2. Right? Getting my point? So it is differentiable x plus 2. It is differentiable everywhere 0 to 2 excluding the both. Okay? Alright, so let's just finish this particular session quickly. And you all know that tomorrow Shreyas sir session is there. Okay, JEE Flash 2.0. You have to attend. Click on the notification button. Along with that, VDPP Vedantu Daily Practice Problem. You have to attend it. Okay, the link is given in description box. Alright, and along with that, you have to subscribe to our very own Vedantu JEE Telegram channel. Okay, JEE English Telegram channel. Again, link is given in the description box of each and every video, my video also. Alright, okay, so I will see you in the next session, next JEE Flash session now. I'll take your leave. This is me, Namrata, signing off.